तुम लोग किट ले लिए हो? जा करके लो, नहीं लड़के निकला में दे रहा है।
जो रजिस्ट्रेशन करवाया है सुफियान से किट ले लेना।
वहाँ अपना नाम लिख करके किट ले लो।
मास्क लगा, मास्क लगा। मास्क नहीं है तो वहां से ले लो, नहीं वहां गेट पर है, ले लो। मास्क लगाओ। क्या हाल चाल सोनू जी?
Okay, now we will start. A very good morning to all of you. I am Dr. Siman Srivastava, convener of this conference. On behalf of organizing committee of this conference, I feel privileged to welcome all of you present here and all eminent speakers and participants from all over the country who have joined through online platform. Thank you for joining us. Despite of current pandemic situation, University Department of Chemistry, Lalit Narayan Mithila University, Darbhanga made again an effort to club all of us for international e-conference on recent advances in chemical sciences. Now we will proceed for the first technical session of this conference, which will be followed by the inaugural session as per the program schedule. Our speaker for this conference is Professor Ashutosh Mishra from Department of Chemistry, Indian Institute of Technology, Hyderabad, who is connected with us on Google Meet. Welcome, sir. Good morning, sir. Thank you for accepting our invitation.
Now, good morning, Dr. Suman. Yeah, it's my pleasure.
Now I invite Professor Prem Mohan Mishra, sir, Principal MLSM College and great teacher of chemistry, to chair this session, and Dr. Abhishek Rai, Assistant Professor of this department, as rapporteur for this session. Prem Mohan Mishra, sir, and Dr.
ओम शिवां ब्रह्मचार सागर परमा माद्यान जगद्व्यापनी पुस्तकां चर्चांतकारापहां अस्ते स्फटिक मालिकां विततिं पद्मासने संस्थितां वन्दितां परमेश्वरीं भगवतीं बुद्धिमतां शारदां सरस्वती महाभागे विद्येकमलोचने विश्वरूपे विशालाक्षी विद्यां देवी परमेश्वरी. Now, first of all, I would like to thank Dr. K.K. Jha, HOD, University Department of Chemistry of this university, and my elder brother, Mr. Shriman Srivastava, and all the dignitaries on the dais, our speaker of this technical session, and my dear friend, students. I am happy to introduce Professor Ashutosh Mishra ji. Dr. Ashutosh Mishra completed his MSc in chemistry from GBU Gorakhpur University in 2003. He ranked among top 20% of CSIR GRF NET awardees for the year 2005. He joined as a PhD scholar in the famous Indian Institute of Technology, Kanpur, under the supervision of Professor Sandeep Verma, Secretary of SERB, DST, Government of India. Dr. Mishra was awarded reputed Eli Lilly and Company Asia Outstanding Thesis Award, and he secured first prize in 2011 for his doctoral thesis. After completing his PhD, Dr. Mishra worked as a postdoctoral fellow in Northwestern University, Chicago, USA, a prominent university of USA, and he worked there from 2011 to 2017. After that, in 2017, Dr. Mishra joined as Assistant Professor in the Department of Chemistry, Indian Institute of Technology, Hyderabad. Dr. Mishra has made significant scientific contributions in high impact factor journals, top journals of India and abroad. I can name some of them. Journal of American Chemical Society, which impact factor is 15.4. Accounts of Chemical Research, impact factor 21.6. In Organic Chemistry, Journal of Physical Chemistry, B, Dalton Transactions, etc. These are all world famous journals. His current research interests deal biomimetic analog of flavoenzymes, short and synthetic peptides, and DNA-based hybrid materials. He is with us. He has joined the seminar through Google Meet. And today, he will be talking about the multifaceted DNA material, charge transport, and self-assemble behavior. Without coming between you and the speaker, I'm inviting Dr. Ashutosh Mishra sir to start his lecture. Welcome.
Hello. Audible, you sir?
Hello, Dr. Ashutosh Mishra, we are audible. Are you connected? Hello.
Hi, am I audible?
Yes.
Hello.
You are audible.
Sorry to ask you again, am I audible or?
Yes, you are audible. Audible.
Okay, great. First of all, thank you so much for inviting me there to present my work, to talk to you guys, and especially to interact the young minds who are sitting over there. I can see a couple of faces who took all this pain to be physically present in the auditorium to hear us. So I thought that my first interaction will be for them, and of course, I'm really happy to be a part of this seminar. And I thank the chairperson for all his kind words for introduction. And so my name is Ashutosh Kumar Mishra, and I hope you can see my slides. Is it visible to you all?
No, your slides are not visible.
Now is it visible?
Please share.
Hello.
No.
Okay. Okay, give me 1 minute. I think. Is it visible now? Still no. Okay.
Please share your screen.
So these are the challenges what we face in today's online era. Oh, wait a second. Yeah, okay. Just 1 minute. I figured out what is the problem. Now it should be visible to you all, right?
We have to finish this session by 10:26, 20:27. We have request.
Can somebody confirm?
Yes, it is visible now. You can go ahead.
Okay. So I believe you guys can see.
We have one request. Please finish it by 10:30. We have elaboration section after 10:30. Thank you. Start. Go ahead.
Sure. So the title of my talk is the multifaceted DNA material. I will be basically talking about the charge transport and self-assembled behavior of this DNA moiety. But before that, I just wanted to, I have highlighted this term, the DNA. Why? Because I think we all understand what is DNA, and we all know that this is a genetic material, right? So I want you to have a closer look at the structure of this DNA, and which is nothing but a very simple structure, right? Two strands. If you can focus my, if you can follow the pointer, there's two strands out there, the two single strands which are having a sugar phosphate backbone, and in the center they have these nucleobases which are connected together through the what we call the hydrogen bonding interaction, right, between the ATGC pair. So in a nutshell, if I have to define the chemical structure of DNA, what I'm going to say is it is having a very simple structure involved with only four nucleobases, right? You can see here the adenine, the structure of the adenine, thymine, guanine, and the cytosine. So we have to deal with only four nucleobases, as simple as that, right? And it has a phosphate and sugar backbone, isn't it? And one more peculiar property is there, which is because of this double helical model, it also attains this stacking interaction between the bases. And I will talk why it is important, or what kind of applications we can use from this stacking interaction. And if you look at this side, which is where my cursor is, the extreme right-hand side corner, you see that if you heat this double helical DNA, it can simply denature and goes to the two single strand DNA, isn't it? Important point here is, if you cool it back and give appropriate time, it will go back to the duplex nature without even a single mismatch. Okay. The important point is how much time you are providing. So, in a nutshell, looks very simple structure, isn't it? But how and why the nature has chosen this molecule to perform the most important part, which is the genetic material, right? To have the information from one species to another species, from one generation to another generation, without getting affected, because even a single mutation in a DNA can cause a big change, right? So I want to start with this quote from Alfred North Whitehead, who says that the silly question is the first intimation of some totally new development, right? Most of the time we talk about the bio-inspired materials, we talk about the biomimetic systems, and in simple, what we talk is whatever we look around ourselves, right? We look around this natural system, we look at somebody might have looked at this sun rays thing, he might have wanted to work with the optics of this thing. Somebody might see the color of these leaves and the discovery of chlorophyll and the photosynthesis, and now we are discussing about the artificial photosynthesis, if we can perform that. Somebody might have looked at the color of the flowers and which has started the development of sensor-based systems, which are chromophore, development of the chromophores and all that, right? But basically, it all started with a very, very simple question that this is what I'm observing and what to do with that, right? The important point is how to take it to the next level. And I want to start with a simple question that even though the parents are same, why we have a different offspring? When I say different offspring, I didn't mean a different species, but I'm talking about kids or a children of the same parent, but they have a very, very different features, isn't it? They might be having a different appearance, they might be having a different height, weight, all that, right? Uh, so why is that? And when people have started looking at them closely, uh, they thought of or they came up with the idea that okay, probably somewhere down this meiosis region, where the gene from a parent, if you consider this blue line as a genes from the paternal side, and this orange one chromosome, which is a gene from the maternal side, they overlap during the meiosis part, right? They overlap, and half of them they transfer their genes to the other offspring part, and that's how it the diversity within this genome sequences arises, right? You can see that the parental part, half of them becomes the orange part. That means the characters from the mother is also incorporated now, and that means you cannot treat this simple DNA uh, similar to or exactly similar to the parental DNA. It has its own new features, right? What I'm trying to convey here is a simple question, as simple as that. Okay, why different offspring, right? Come up with the development of this recombinant DNA, right? And in fact, today, in today's time, we are actually dealing with the recombinant of DNA, where we are physically introducing a new characters in the offspring. Anyway, so when my title was the DNA materials, right? That means we don't want to look at the DNA from a natural perspective. We do get inspired from the natural point of view, but we want to use it as a material, right? And I will give you a simple example that even just trying to understand this feature, how this crossover occurs, this is called the holiday junction. And one of the guy has actually asked to develop a model. Can we have a simple model to understand the feature of this crossover? And if you look at this side, the 4 DNA, which is coming from the parent to half and the crossover linkage, they just try to develop this model. Okay. And this simple question that how we can develop a model for this holiday junction part has actually led to a DNA, the entire basic for the DNA nanotechnology area, where nowadays what you can do is you can design your sequences. Obviously, each sequence has to be unique because you are only dealing with the 4 nucleobases. And when I say unique, it's all kind of permutation combination part that which base should come to next to which base, right? So if you have all kind of unique bases, you simply take all this, synthesize all this small single strand DNA, mix them in a pot, and you can come up with all variety of structures, right? I don't want to go in detail of these things, but if you look at the overall timeline for this DNA nanotechnology field, it started with the simple idea of how you can synthesize this DNA junction. Okay, the holiday junction part where you have this crossover DNA. Can you develop a model for that one? It was as simple as that. And the actual question arises from the recombination of the DNA part, which actually comes from somebody might have thought that, okay, why different offsprings has the different features, right? Similar to this one, our inspiration came from a simple understanding of another biological phenomena, which talks about DNA damage, right? And how this DNA can repair itself. Okay. So when you talk about the DNA repairs mechanism, it actually tells that the electrons suppose this is the part which is absorbing this damaged thing, and it has to travel all the way from this side to this side through electron. Okay, and when I say electron, that means it can transport electricity, isn't it? But this is a biological system, very difficult to work with the entire system. So what we thought is, the first proposed idea is that if electron can move from one part of the DNA to another part of the DNA, can we use this DNA as a molecular wire, like an actual molecular wire? Can we so, and the basic reason why we thought about this one is a stacking interaction, which is kind of an inherent property of this DNA. The orbitals are overlapping. They can give you a smooth pathway for electron to move from one junction to another junction. And if you look at the first few examples, they basically have two kinds of chromophores which can give some signal, because you can excite this molecule, the electron can move through the DNA, and then you can detect it at the other end. It's as simple as that the two persons are standing at the two ends. One starts the race, the other one ends the race with a flag, right? Both can give some sort of signal that to identify that actually the electron has moved from one end to the other end. Okay. So these are a couple of few papers, and I basically want to talk about this part where Professor Lewis from Northwestern, he has introduced organic chromophore, because the problem with the other two is they have a metal center. Okay, they have used the metal ion to induce the electron, and metal has their own properties, right? They are also conducting materials. So we wanted to use something which does not conduct electricity or does not influence the dynamics of this electron transfer part. So we have used a chromophore, the normal organic molecule. Okay, it's still being based organic molecule, which can give a different signal at one end, and then at the other end we have a different chromophore which will give you a different signal to identify. And I will explain this with this this slide, that you have this still bin diamide kind of system, and this is a normal. You can think of this as a normal absorption spectra, UV spectra. You must have studied through this UV visible spectroscopy, right? Ignore this term for a while. Femtosecond transient spectra. What it actually does is, because the timeline here is not even a second, not even a millisecond, not even a microsecond. It falls in like a picosecond range, 10 to the power minus 12 seconds. Okay, so it's very, very fast phenomena, and that's why we have to modify this instrument. But technically, it gives you the UV vis absorption spectra from this molecule. So if you start, you excite this molecule with the light, and you will see certain absorption for this molecule, this particular molecule. So this is the singlet excited state, what we call that molecule is now charged up. It's all ready to run, right? It's all ready to induce the electron, which is going to run throughout the DNA to the last end, which is this part where we have an acceptor molecule. Again, a still bin based system, but it absorbs at a different wavelength, right? So once the molecule is charged up, this molecule is charged up by photoexcitation. Okay. What it will do, it will it will take one electron from the neighboring base, get a radical anion species, the minus sign here, and the positive sign will travel all the way through these DNA structure. Here the A and T stands for adenine, T stands for thymine, G stands for guanine, C stands for cytosine. Just for the simplicity, I have shown it in the two-dimensional structure, so that you can understand the importance of the bases. Okay, what is the importance of bases? So what will happen next is, once you have excited this or charge up, took one electron, and it just moves through this DNA to the other end. Once it reaches the other end, this also starts fluorescent, right? This also starts showing the signal, what you can see in this absorption spectra here, right? This signal, which was not there in your earlier part, right? The earlier the signal was only coming from this side, which is the SA, denoted as the SA part. Once the electron moves from this end to the other end, only then you start seeing a signal here, which grows into, means becomes intense and intense as the time passes. And what you can see here is the timeline, and PS stands for a picosecond time. So say, for example, if I have to simplify this thing, after once I have excited my molecule, after 3.5 picosecond, I'm going to record one spectra. Okay. After 25 picosecond, I recorded another one, and so on. So we can actually get the timeline, how much time it is taking from running from this end to this end, point A to point B, if I have to talk in that sense, how much time the electron takes within the DNA to move from, say, say 100-meter race. Okay. So technically, what we have already understood in this field is this much, where if you look at this part, where you actually excite one of the chromophore, you will see two signals, one from the acceptor, one from the donor. Over a period of time, they will go away, because the timeline is such a short timeline, right? It falls in a picosecond range, right? So we are getting signals from two ends, this end and this end. But technically, we don't know if there's anything happening through the DNA or not, because it might also be possible. We have no idea about this center part. We have no idea about, because we don't know. We never got any signal from the actual DNA basis, isn't it? So it might be possible that instead of going through the DNA, it might be just jumping from one end to the another end by some other means, right? So you have to characterize this part. You have to optimize your experimental setup to understand that whether it's actually going through one end or it's going through the DNA. Okay. So the missing link was how we are going to track this movement of electron or the whole carrier in a exact sense. Okay. So you can do two things. You can modify your bases. Instead of having a guanine, you can have a modified guanine, which can give it signal. So once the electron reaches to this modified guanine, it will again show a different kind of signals. Or you can modify this acceptor itself, right? Sorry, the donor itself. So initially we have worked with this molecule, which is a stilbene thing. And if you look at it, has a very broad spectrum in absorption spectra, and we don't see any distinction between the charge up stilbene, the excited state, versus when it actually becomes negatively charged, right? As compared to, we have modified our molecules slightly. So the redox potential is almost same, 1.44 versus 1.78, not much difference. Okay, structurally it is almost of the same length, so that we can accommodate within the two strands of DNA. And if you look at this spectral properties, the charge state is this one, which is labeled as star, and once it takes the electron, once it becomes a negative charge, it shows a different signal. That means we will get information from here as well, and that's what we try to do. We have synthesized some small DNA structure with the DPA stand for this molecule, what we have modified, and guanine has been used as an acceptor. So once the charge will reaches to guanine, the process is done, right? What we try to do is we try to increase the gap between this donor and acceptor. I assume that you are going to run a race of 10 meter, race of 100 meter, race of 1 kilometer, right? So if we can get all this information, we will get to know about the average speed and all that, right? Where it is getting stuck, how to make it more faster and all that kind of thing, okay? So similarly, we have got these three things, and then again, we have increased the distance between this one, okay? From your starting point to the end point. We have increased the distance by increasing the number of bases in between, fine? Again, we have went back to record
Good morning, sir.
Good morning. We went back to record our absorption spectra, and now if I have to highlight few points, you see, I have shown you that, okay, the DPA, the first chromophore, gives you a separate signal for the excited state, right? So once it gets excited after say 1 picosecond or even less than 1 picosecond, which is 0.2 picosecond, it shows a signal for excited state. And immediately after that, if you look at this part, which is actually the negative charge, that means once it takes the electron after 1 picosecond only, it shows a different signal, right? And interestingly, we also see an additional third signal, which is corresponding to G based upon our other observation that it appears and decays along with this negative charge. So we have assigned this as a guanine radical anion, cation. And just to keep things in perspective, this was the first time when a guanine radical cation, experimental proof has been given for the guanine radical cation. Before this, there was no example where you can actually see any kind of spectra or any kind of experimental suggestion which tells you directly that this is what G radical cation looks like. Okay. So we got three signals. That means we can have the entire story in our place. We can have the signal once we excite this molecule. This is just the excited state, and once it moves to takes the negative charge here and the positive charge to the neighboring base, we also have a signal for that one. Once I say signal, that means you are also getting this timeline. How much time it is taking from moving from this excited state to a radical state and then to a guanine part, right? Similarly, if you look at for the longer sequences where the distance is more, we have recorded again the same transient absorption spectra. And if you look at for the first two molecules, where there's slight increase in the distance between your donor and the acceptor part, you don't see any signal. Even your guanine cation radical has also vanishes in this one. You don't see any signal for the guanine radical cation. But as you move for a 4 adenine in between, or 5 adenine in between the donor and the acceptor, or 6, they all started showing some sort of signal at this wavelength, 575 wavelength region, right? And even in where you don't have any G, you don't have a guanine here, even there you are seeing, this is the red line here, you are seeing a hump here which corresponds to adenine polaron. And what do you mean by adenine polaron? Because adenine itself don't, I won't say don't show any signal, but the signal is so weak, that's why people have unable to identify it before. But once you have a 4 adenine in place, they all together, the charge will be separated over the entire area, and they will fluoresce. They will give you some sort of signal in the absorption spectra. Okay, so this is what we have been seeing for the first time again. Okay, so in a nutshell, if I have to tell you, of course, based upon all this observation, and we have the timeline because we were recording against, we were recording against this timeline, right? 1 picosecond, 2 picosecond, 5 second, 5 picosecond to say 7,800 picosecond timeline. That means we can directly calculate how much time this chromophore takes to inject the electron onto the adenine part. Okay, and once it goes from adenine to guanine, that timeline we can also calculate. Of course, we can calculate once it is going to get to the ground state. And if you look at the timeline for injection, it's hardly 3 picoseconds, never been reported before. Okay, of course, the charge recombination time is very high depending upon how far one has to run, right? If we have to run for 10 kilometers, it's going to take more time, and as compared to if we have to run for only 1 kilometer. So this is the difference what we see once you increase the distance between the two ends. Okay. So technically, what I try to show is with the simple bio-inspired concept, we came up to this conclusion. We have tracked the path of this electron to the end. Okay. Somebody might be thinking, what is the importance of this part? Because imagine the next generation, the future application for this kind of studies falls in where you are actually using the DNA as a molecular wire. Okay, you can use it as a chip. Within a chip, your chip size will be very small. You can use it for a biomedical applications and all that. Because instead of using a wire, say, for example, if I have to give one example, the people with the heart disease must be using this pacemakers, right? And pacemakers, the size is still a bit bigger as compared to what we can do with the DNA. And the same performance, because now the charge can move from one end to the another end with the help of this battery and all that, right? In fact, there's another concept is coming up where you actually can store the information within the DNA part, and instead of using your USB, you can use the DNA-based USB, which can store like 700 terabytes in just a small package. So things are moving in a very, very forward direction. And hopefully you guys, one from you, the younger lot, may come up, take this to the next level and make it like the actual reality part, okay? So with this, I would like to thank you all, and I'm really happy to go through your website. I have seen a couple of pictures which has really inspired me to actually visit there. Online thing has one demerit that you cannot actually physically go over there, but looking at the couple of pictures, what I saw on the website is really encouraging that I should be visiting there in my next for my next talk. Before I end up, I thought I will simply show, give just a small overview of what is IIT Hyderabad doing in its current form. So this is a model for the IIT Hyderabad, and presently we are working with these three buildings. This is the one building, this is the A block building, this is the B block building, this is the C block building. All these three buildings are fully functional. We are working in it. And the other buildings, what you can see here, and these four, they are still under construction. Hopefully, this is our chemistry building. Hopefully, we'll get it within 6 months. The biotechnology building is almost ready to work with. And these are the hostels at this end. So the actual appearance-wise, it looks like this: A block, B block, and the C block thing. And this is just another view of these A block, B block, and the C block parts. The hostels where the students live, it's really nice architecture for each and every building. This is the cafeteria, the mess area where all of us, including the students, faculty, whoever wants to have their lunch, dinner, breakfast, we used to go there. And this is actually the departmental building, which will be coming up in future, hopefully within 6 months. And this is the current strength of the department. And with this, I like to thank you all to give me the opportunity to talk and interact with you guys, and hopefully, so this is one suggestion for the younger generation, that even though you have a very, very silly question like what I have shown in the beginning, it may end up giving a very, very marvelous result, depending upon how far and how much scientifically you can prove that silly concept or the question, if you can answer that question. So with this, I will thank you all, and I will be happy to take any questions if you have.
Thank you, Dr. Mishra, for a nice lecture. Sorry, we are running from constraint of time. So I would like, please you share your email address, and participant can interact with you directly on your email. Right now, we don't have time to discuss with you because our chief guest has arrived. He is sitting in the dais. So sorry to disturb you, and very, very much thank you for your nice presentation. Thank you, sir.
Thank you, sir. Thank you so much for your all nice words.
Good morning all. Hi Indra. Welcome all the dignitaries and participants in E-ICRACS-21. As all the dignitaries have taken their respective seats, let's proceed with the inaugural session. Akhand Mandalakaram, Vyaptam Yen Characharam, Tatpadam Darshitam Yen Tashmai Shri Gurve Namah. अर्थात उस महान गुरु का अभिवादन जिसको व्यवस्था का साक्षात्कार करना संभव किया, वो पूरे ब्रह्मांड में व्याप्त है, सभी जगह और नृत्य में। privilege to extend a warm welcome to Honorable Vice Chancellor, Dr. Professor S.P. Singh sir, Pro Vice Chancellor, Dr. Professor Dolly Sinha ma'am, Honorable Registrar, Professor Mustaq Ahmed sir, Dean Faculty of Science, Professor B.N. Shah sir, Head of our department and other departments, respected teachers, delegates participating online and offline, research scholars, persons from print and electronic media, and at last but not the least, all the students participating in International E-Conference on the theme Recent Advances in Chemical Science.
I welcome all the eminent speakers and great guests from all over the globe to share their knowledge and vast experiences with all of us present here. We are honored to have you all with us. We feel privileged to announce that this is 2021 Second International Conference of our department to be conducted on a digital platform in line with the social distancing norms due to COVID-19 pandemic.
As we have gathered here for the E-Conference organized by the Department of Chemistry, LMNU, so let's begin with the Kulki. I would like to welcome Anta, Manisha, Pallavi, and Nikita of our department to perform our very own Kulki, which will give you a glimpse of Mithila University and Mathil tradition and its beautiful culture. During the Kulki, I request all the dignitaries and participants to stand on their respective places. I request further for no clapping after the Kulki.
I would like to welcome again Anta, Manisha, Pallavi, and Nikita of our department to perform our own Kulki.
Shri Ram Udit Mahabali Mahal Murti Mahal Parikrata Narayan Yud Lalit Vishnu Vidyalaya Jnani Pradata Shri Ram Udit Mahabali Mahal Murti Mahal Parikrata Narayan Yud Lalit Vishnu Vidyalaya Jnani Pradata Rat Kamal Samal Susrit Nilantarag Vibhashit Chaya Pal Makhan Lok Sut Garbit 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 Khaya Mithila Mudit Mahamani Mari Mari Murti Mahal Parikrata Dakshin Gang Tarang Kaushiki Dakshin Gang Tarang Kaushiki Purv Bang Vistara Karunar Madhya Bhagavati Shobhit Paschim Gangat Dhara Atmajnani Udhan Meer Mane Udit Ank Anusara Kamal Ashtadal Tantra Mantra Shat Pune Yantra Parivara Mithila Mudit Mahamani Mari Mari Murti Mahal Parikrata Dharma Karma Bhaji Bhai Jyoti Dharma Karma
मिथिला मुदित महाबली वर वर मुक्त महल परित्राता प्रौद्योगिकी के साथ प्रबंधन प्रौद्योगिकी के साथ प्रबंधन रंजन युग जन क्रीड़ा विविध शास्त्र विषयादि सुशिक्षा विविध शास्त्र विषयादि सुशिक्षा वृद्धि गणित हर क्रीड़ा मिथिला भरत भूमि भूमंडल विश्व अवरुद्ध गाता भूषित सर्वोपरि अभिनव मनुज विधाता मिथिला मुदित महाबली वर वर मूर्ति महल परित्राता नारायण युद्ध ललित विश्वविद्यालय ज्ञान प्रदाता मिथिला मुदित महाबली वर वर मूर्ति महल परित्राता
Thank you, Manisha, Antara, Nikita, and Pallavi.
Light leads the way down this and symbolizes knowledge and wisdom. Let us wish that this light of education takes over the darkness of differences, injustice, and violence in the world and guide us towards progress, equality, and freedom. Thus, it is rightly said, "जहाँ जाऊंगी रोशनी फैलाऊंगी, ये चिराग का अपना मकान नहीं होता." Now, I would like to invite our chief guest along with other respected dignitaries to have our traditional and auspicious lamp lighting ceremony. I request Manisha to please assist the dignitaries with candlelit lighting.
बना दिए तो वीडियो खोल लो 1 2 3 4 5 6
आइए सर
Also,
हाँ फिर बढ़ रहा है पकड़ रहा है।
ले ले ऐसे करके नहीं लादा पड़ता है हम पर हम कहीं वो मोबाइल
Science without safety and environment concerns is just like a nightmare. The need of COVID era is to work with the nature and show the same gesture in one's behavior and deeds. The one who plants a tree plants a road. This work provoked our mind and we will try to make it possible by honoring our guests by presenting them samples. I would request our actually Professor K.K. Bhaskar to felicitate and honor the Vice Chancellor of our university and an eminent Professor of Economics and Chief Patron of E-ICRACS-21. Dr. Professor S.P. Singh sir, and I request Pallavi to please assist actually sir in felicitation with this happening. Thank you, sir. Thank you, Pallavi. I would like to honor our Pro Vice Chancellor and E-ICRACS-21 patron, Dr. Professor Dolly Sinha ma'am. I request Professor A.S. Sani sir to felicitate our Pro Vice Chancellor with sampling. I request Nikita to assist sir with sampling. Thank you, sir. Thank you, Nikita. Let's proceed with the felicitating Great Faculty of Science, Professor B.S. Thakur. I request Dr. Shiman Srivastav, sir, to present sampling to him. I request Shalini assist sir with sampling. Thank you, sir. Thank you, Shalini. Next, I would like to welcome our Honorable Registrar, Dr. Mustaq Ahmed, sir, and I request Professor S.K. Chaudhary, sir, to please felicitate him. I request Manisha to assist sir with the sampling. Now moving forward, I would like to invite Dr. Abhishek Sir to felicitate our head of department, Professor K.K. Bhaskar, and I request Shalini to please assist sir in felicitation with this honor. Thank you, sir. Thank you, Shalini. After felicitating the guests, we are moving towards the addresses. It doesn't matter who you are and where you came from. The ability to trust begins with your vision. The only limits you can achieve are the limits you believe. The harder the struggle, the more glorious is the triumph. To start with, I request our head of department, Sir K.K. Thakur, to welcome the dignitaries present on the dais and off the dais. We are honored to have Professor K.K. Thakur as the head of our department. He is a great professor, mentored very caring and encouraging towards the students of the department. I would like to invite him for the welcome address. Please welcome, sir.
आप सबों को मेरा प्रणाम। मैं नम आंखों से विज्ञान डॉक्टर सतीश कुमार चौधरी को नमन करते हुए कुलपति के आदेश से यह कार्यक्रम शुरू करता हूँ। Respected Honorable Vice Chancellor Sir, Dr. S.K. Singh Sir, Respected Honorable Vice Chancellor Dr. Dolly Sinha Ma'am, मेरे बड़े भाई और जलवायु विभाग के विभाग अध्यक्ष एवं विज्ञान संकाय के डॉक्टर बी.एस. झा सर, दलित न्याय विश्वविद्यालय के कर्मठ एवं विद्वान इसका डॉक्टर मुश्ताक अहमद साहब, उपस्थित विभिन्न विभागों के विभागाध्यक्ष महोदय, विभिन्न कॉलेजों के प्रधानाचार्य महोदय, विभिन्न कॉलेजों एवं स्नातकोत्तर विभाग के शिक्षकगण, ऑनलाइन से जुड़े हुए देश विदेश से मेरे मित्र, प्रिंट मीडिया एवं इलेक्ट्रॉनिक मीडिया के बंधुगण, छात्रों एवं छात्राओं, आप सभी को मैं अपनी ओर से और रसायन शास्त्र परिवार की ओर से अभिनंदन एवं स्वागत करता हूँ। बड़े हर्ष की बात है कि आज दिनांक 28 जुलाई 2021 को स्नातकोत्तर रसायन शास्त्र विभाग द्वारा इंटरनेशनल जी कॉन्फ्रेंस आयोजित की जा रही है। इस सेमिनार का विषय है मिशन एडवांसेस इन केमिकल साइंस। इस सेमिनार में देश विदेश के लगभग 300 लोग ऑनलाइन और ऑफलाइन मोड में जुड़े हुए हैं। इस सेमिनार में हमारे स्पीकर हैं प्रोफेसर श्याम पांडे जी, KIT जापान। दूसरे स्पीकर प्रोफेसर आशुतोष मिश्रा जी हैं, जो IIT हैदराबाद से। तीसरे स्पीकर डॉक्टर रघुमणि सिंह जी हैं, जो भाभा एटॉमिक रिसर्च सेंटर मुंबई से हैं। चौथे स्पीकर डॉक्टर सौमित, जो यूनिवर्सिटी ऑफ केप टाउन साउथ अफ्रीका से हैं। पांचवें स्पीकर डॉक्टर नरेंद्र मिश्रा जी हैं, जो कोपेनहेगन यूनिवर्सिटी डेनमार्क से हैं। मैं इनका भी अभिनंदन और स्वागत करता हूँ। विभाग के लिए ये बहुत बड़ी उपलब्धि है, क्योंकि 6 महीना के अंतराल में ये दूसरा इंटरनेशनल जी कॉन्फ्रेंस इस विभाग के द्वारा आयोजित की जा रही है। इससे पहले 1 और 2 फरवरी 2021 को इंटरनेशनल कॉन्फ्रेंस इस विभाग में हो चुका है। ये सभी तब संभव हो पाया जब हमारे अभिभावक कुलपति प्रोफेसर SP सिंह सर और उप कुलपति प्रोफेसर डॉली सिन्हा मैम जैसे कर्मठ व्यक्तियों का नेतृत्व मिला। विभाग आप लोगों के प्रति आभार व्यक्त करता है और विश्वास दिलाता है, आगे भी जब जब आप हमें इस तरह के आयोजन करने का अवसर प्रदान करेंगे, हम लोग उसी पर खड़ा होंगे। हमारे विद्वान कुलपति प्रोफेसर SP सिंह सर बिहार के 4 विश्वविद्यालय के कुलपति होने के बावजूद अपना बहुमूल्य समय निकालकर इसमें आए। इसके लिए पुनः मैं अपने विभाग और रसायन शास्त्र विभाग के परिवार से उनका हार्दिक अभिनंदन और स्वागत करते हैं। धन्यवाद।
Thank you so much, sir, for your words. I would like to invite convener of E-ICRACS-21 conference, a very young and energetic professor of our department, Dr. Siman Srivastava sir, who will introduce us about the theme of today's program and will share his views about E-ICRACS-21.
Very good morning to all of you. As a convener of this conference, I take this opportunity to welcome Chief Patron of this conference, Professor SP Singh sir, Vice Chancellor of this university, Professor Dolly Sinha ma'am, Co-Vice Chancellor of this university, Professor B.R. Doctor, Dean Faculty of Science and guest of honor of this conference, this event, and Professor Mustafa Ahmad sir, Registrar of this university. I always say, as I feel, for the present leadership of our university, encouragement, enthusiasm, and excellence are the 3 major priorities of the current leadership of this university. How? This can be realized by the fact that University Department of Chemistry itself organizing several international conferences within the 6 months, and other departments of university too. Second one is that leadership is working on to establish an advanced research central research facility with sophisticated instruments and computational facility, which will be first one of its kind in this whole region of Bihar. You all must understand the importance of knowledge of chemistry during this pandemic. Because of chemistry, world find vaccine to protect from corona. You also must come across scientific rangoli made by our students, which is 2-DG, 2-deoxy-D-glucose, anti-COVID drug developed by DRDO India. This could be possible because of a good knowledge of chemistry, with an objective of encouraging the spirit of research and innovation among our postgraduate students and research scholars, University Department of Chemistry. He is proud to host this one-day e-conference with knowledgeable talk by eminent speakers relevant to the theme of this conference. The speakers of this conference are working in Japan, South Africa, Denmark, IIT, BAR, and they are well recognized among the scientific community and excelling in their respective area in terms of citation of their research work articles with a F citation about 30 and 50 and total citation about 6,000, which shows scientific recognition of their research work. One of the speakers, Dr. Ramani from BARC, is listed among top 2% Indian scientists based on independent research from Stanford University, USA. I hope you all will get some fruitful information today. Thank you.
Thank you, sir. Now, the time has come to unwind the souvenir of E-ICRACS-21. I request all the dignitaries on the dais to kindly grace the occasion.
Our Honorable Registrar, Dr. Mushtaq Ahmed Sir, has been principal of reputed colleges and an extremely good administrator and a man of development with love of business. So let's welcome him to address and acknowledge us. You are welcome, sir.
Dean of Science, Professor D.S. झा साहब, इस विभाग के विभागाध्यक्ष प्रोफेसर झा साहब, स्थानीय एजुकेशन कॉलेज के प्रधानाचार्य, यूनिवर्सिटी के विद्वान प्रोफेसर प्रेमोहन मिश्रा जी, सभागार में उपस्थित विभिन्न कॉलेजों के शिक्षकगण, इस विभाग के तमाम सम्मानित शिक्षक, प्रोफेसर अंसारी साहब, श्रीमान जी, छात्र छात्राओं, सबसे पहले तो आपके विभाग के प्रति आभार के विभाग ने विश्वविद्यालय के द्वारा निर्धारित कार्यक्रमों को ससमय पूरा करने की कोशिश की और ज्वलंत विषय पर ये सेमिनार रखा। बदलते समय में रसायन शास्त्र की अहमियत, अफादियत के क्या महत्वपूर्ण कार्यक्रम आगे होंगे या इसकी संभव जो इसकी आज के दौर में जो चैलेंजेस आए हैं उस पर आधारित विज्ञान, केमिस्ट्री किस तरह मानव समाज के लिए उपयोगी होगा, उस पर विचार विमर्श के लिए आपने इस सेमिनार का आयोजन रखा। 18वीं सदी इसे शायद आप को पढ़ाया जाता होगा। जाबिर बिन हय्यान को केमिस्ट्री का जन्मदाता कहा जाता है। 730 में उसका जन्म हुआ था। उसने केमिस्ट्री का एक फार्मूला दिया था और वो फार्मूला ये दिया था, ऐसी बात है कि अरबी का विद्वान था, हिकमत जानता था। तो जाबिर बिन हय्यान ने कहा था कि दुनिया में दो चीजें हैं, जो एक धातु है, उस धातु का घनत्व, इससे दुनिया में तब्दीली लाया जा सकती है। और उसने केमिस्ट्री की बुनियाद रखी और एक बड़ी बड़ी किताब लिखी और उसी जमाने में एक बड़ा आला तैयार किया उसने, जिससे आप बुखार जांचते हैं आज कि एक सिरा पे गर्म जैसे आपके जिस्म में लगाया जाता है, दूसरे सिरा पड़ा चला जाता है, उसका मूजिब भी उसे कहा जाता है, अल-तबीब उसका नाम रखा उसने। ये बात है 730 में पैदा हुआ और 757 में वो पूरे अरब दुनिया में एक बड़े विद्वान के रूप में प्रचारित हो गया। जाबिर बिन हय्यान, उसको अंग्रेजी में जाबिर बिन हय्यान लिखते हैं। ये केमिस्ट्री का मूजिब था। उसने कहा था कि आने वाली दुनिया जो होगी वो कंपोजिशन की होगी और इसके बगैर आगे नहीं बढ़ सकते। और पूरी अरब सभ्यता को जब आप पढ़ेंगे या उस वक्त उसके बाद यूनान की सभ्यता, वो जाबिर बिन हय्यान की थ्योरी पे पूरी केमिस्ट्री भरी हुई, पूरी केमिस्ट्री भरी हुई। क्योंकि हम अरबी के माध्यम से जाबिर हय्यान को पढ़ते रहे, इसलिए केमिस्ट्री जानने में मुझे कोई असुविधा नहीं। आपका कौन वैसे आप जानते हैं कि मैं अदब का साहित्य का छात्र रहा, लेकिन हमारे जमाने में मैट्रिक का कंपलसरी था, तो वहां तो पढ़ाई मैंने। लेकिन उस जमाने में भी वो जितने आपकी धातुएं ये हैं उसको याद करने में आसानी इसलिए हुई कि हम लोगों ने शुरू में ही उसको अरबी के माध्यम से पढ़ लिया था। 97-98 तक पढ़ चुके थे, जब 8वां कॉपी तो हुआ कि 100 हो गया। इसलिए ये विषय आज की तारीख में नहीं, बल्कि दुनिया में जब से विज्ञान के बारे में लोगों ने सोचना समझना शुरू किया, उस समय से केमिस्ट्री एक अहम भूमिका में रही है। और अब तो ये शब्द जीवन के हर एक पहलू पे हो गया है। छात्र और शिक्षक की केमिस्ट्री क्या है, राजनेता की केमिस्ट्री क्या है, उस समाज की केमिस्ट्री क्या है, ये इसका रूप ही बदल गया। अर्थ ये हुआ कि ये शब्द हमारे जीवन का एक हिस्सा बन गया। वो सिर्फ एक विज्ञान के रूप में नहीं, बल्कि हमारे जीवन के प्रत्येक हिस्से में। आप कहते हैं अच्छा इतना क्या केमिस्ट्री अच्छा है, व्हाट मींस क्या है इसकी केमिस्ट्री, क्या है ये शब्द इस तरह का होने का अर्थ ये हो गया कि इसकी प्रमाणिकता भी है। और विज्ञान तो ऐसी बात है कि प्रमाणित करने का भी शास्त्र है। तो आप लोग इस सेमिनार के जरिए ये प्रमाणित करेंगे कि केमिस्ट्री आज के तारीख में, अब जब दुनिया के सामने, अभी आपने बनाया है सामने कि हमारी जो दवा इजाद हुई उसका केमिकल H2 और ये सब किया है, बनाया है आपने उसको फॉर्मूला, केमिकल बॉन्ड के जरिए किस तरह से दुनिया बढ़ती है, साइक्लिंग होती है, क्या बनता है उसको, ये सब आपने सामने रखा है। मैं समझता हूँ कि आप जो नई पीढ़ी है उसके सामने एक नई केमिस्ट्री का अध्याय खुला। ये कोविड-19 के बाद आपके लिए जो पहले की केमिस्ट्री रही है, उस केमिस्ट्री से एक अलग केमिस्ट्री की दावत दी जा रही है। अब आपको अपने इससे सोचना है कि हम आगे की दुनिया को सुरक्षित करने के लिए, अपने आप को जीवन को बढ़ने को, जीवन को अस्थायित्व देने के लिए हम किस केमिस्ट्री के लिए, किस दवा का इजाद करें। पहले की दवाएं, जितनी दवाएं थी कोविड वायरस पे के लिए नाकाम हो गई। अब तक की जितनी केमिस्ट्री आती थी वो सारी की सारी नाकाम हो गई। अब केमिस्ट्री जो अभी दवा इजाद हुई, जो हम इंजेक्शन लेते हैं कोविशील्ड, इसके बाद की भी जरूरत है, इसलिए कि ये भी 100% कामयाब नहीं है। तो आपको जो आपने विषय भी रखा है क्या होगा बदलाव, तो इस सेमिनार में मैं समझता हूँ कि इसके माध्यम से एक बड़ा संदेश जाएगा। पिछले दिनों भी जियोलॉजी डिपार्टमेंट में इसी तरह का विषय रखा गया। ये एक बहुत अच्छी बात है कि हम घिसे पिटे जो शब्द है, शब्दावली है, उसके हम सेमिनार नहीं रख रहे हैं, बल्कि अपने विषय के नए आयामों पर विचार विमर्श करने के लिए बैठ रहे हैं। तो हमारे इससे एक नई पहचान बनेगी। जब आप कोई नई बात करते हैं तो दुनिया हमारी तरफ देखती है, और भारत तो हमेशा दुनिया के लिए एक पथ प्रदर्शक रहा है और मिथिला का दावा भी रहा है। तो ज्ञान विज्ञान के क्षेत्र में कि हम बहुत पताका लहराते रहे हैं। तो मिथिला विश्वविद्यालय आज के समय में भी ये प्रमाणित करने के लिए सेमिनार आयोजित किया। उसके लिए पुनः विभाग के सभी सहयोगी विभाग के साथ अशोक बाबू और अन्य विवेकानंद बाबू जी फिजिक्स के भी टीचर यहाँ बैठे हुए हैं। मैं समझता हूँ कि मिथिला विश्वविद्यालय जिस आगे चल रहा है, माननीय कुलपति प्रोफेसर एस पी सिंह साहब, माननीय प्रतिकुलपति महोदय, आप देखिए कितना अच्छा यहाँ पे नर्सरी है। माननीय प्रतिकुलपति महोदय साइंस के हैं और साइंस को बनाने के लिए अर्थ की जरूरत है। कुलपति जी अर्थशास्त्र के हैं। बिल्कुल एकदम पटरी सीधे सीधे चल रही है, कहीं दिक्कत नहीं है। साइंस और अर्थ कहीं कमी नहीं है। आपको बहुत बहुत मुबारकबाद। धन्यवाद।
Thank you so much, sir, for informative and valuable words. I request our Dean Faculty of Science, Professor B.S. Chasser, who is a dynamic and enthusiastic personality, to address the audience. Welcome, sir.
Most Honorable Vice Chancellor, Mithila University, Professor S.P. Singh sir, Honorable Pro Vice Chancellor, Madam Professor Dolly Sinha, young, energetic, dynamic Registrar of the University, Professor Mustaq Ahmed, Head of the Department of Chemistry, and my younger brother, Professor K.K. Jha, chairing the dais, Professor S.K. Chaudhary, the convener of the conference, Dr. Seeman Srivastava, my fellow friends of other departments, students, friends from the media. At the outset, I would like to thank the present university administration, this tribe, the grand chemistry, which is in the right direction. The university is moving in the right direction under their leadership, and we are gaining and will be gaining newer and newer heights. So once again, I thank them for motivating and inspiring the faculties to organize conferences and seminars of both national and international level. All this have made the scenario on the campus academically vibrant even during the COVID pandemic. The aim of this international seminar, as it appears to me from its title, Recent Advances in Chemical Sciences, I think, is to expose our faculties, research scholars, and PG students to the latest developments in various areas of chemical sciences, which I am sure will motivate them to undertake research projects on these lines, which may ultimately lead to the welfare of mankind. Friends, the present area belongs to the research of interdisciplinary nature. If one looks back at the Nobel Prize or other research excellence awards, you would find that most of the awards have been won by joint works of life scientists, physicists, and chemical scientists. So, being a student of life science, I would rather urge or propose here, I use this platform to propose that there must be a biophysical chemist association in our university. Maybe it may have some other name, but I think it suits the interdisciplinary aspect. So a sort of association like Biophysical Chemists Association we formed in our university under the banner of which major interdisciplinary research projects can be, say, framed and can be sent to the various funding agencies for grants. And once the grants are made available, there is no reason that we can't excel. We would be, we would have a team of, say, experts or rather investigators from life science departments, chemistry departments, physics departments, and the joint venture will give a good result, and the outcome of those results will take our university to new academic heights. I think this task must be assigned to our brilliant, young, and dynamic faculties, new teachers recruited by BPSC in the recent past. So they should come forward and take this task. As regards the frontier areas, so chemical neuroscience, molecular imaging, drug delivery, and environmental biophysical chemistry are some of the frontier interdisciplinary areas. I call upon the young faculties who are the budding scientists and future of this university to take up research on these lines. As regards chemistry, experts have predicted 2021's big trends of chemistry, which I quote, as new products that enable recycling and circularity, that provide energy savings in use and corresponding reductions in carbon footprint, and that utilize renewable, all of which will enhance performance attributes and benefits for consumers. This is the big trends predicted by the experts for chemistry in 2021. So with these backdrops, I am sure that the exchange of knowledge in recent developments in various areas of chemical sciences during the different technical sessions that we will have from this right after this inaugural session will definitely form a backbone for research activities in our university. At last, I have been assigned only 5 minutes in time, so I thought I am under expectation. So at last, I congratulate the chemistry team for organizing a multi-dimensional conference and under the leadership of Professor K.K. Jha, and also thank the organizers for giving me an opportunity to share this platform. Thank you once again to all.
Thank you, sir, for acknowledging us with your inspiring words. Honorable Pro Vice Chancellor of and Patron of E-ICRACS-21, Dr. Professor Dolly Sinha ma'am, a brilliant administrator and an amazing prior to this university, she was Pro Vice Chancellor of Patna University. We are glad to have such learned lady as Pro Vice Chancellor of our university. Let's welcome ma'am to bless us with her thoughts and guidance. You are welcome, ma'am.
Namaskar and very good morning to all. Professor S.P. Singh, Honorable Vice Chancellor of L.N. Vitala University and the Chief Patron of this conference, Professor B.S. Jha, Dean, Faculty of Science, Professor K.K. Jha, Head Department of Chemistry and President of the conference, Professor Mustaq Ahmad, Registrar and co-patron of the conference, delegates, participants, faculty members of the University Department of Chemistry and various units of the university, and I could see In the audience also, we have equally learned professors. In front of me, Professor Prem Mohan Mishra sir of chemistry is there. He is also the principal of MLSN College. Dr. Ashok Jha, Professor Arun Kumar Singh, and all the members of the organizing committee, namely Dr. Simant Srivastav, convener, Dr. Abhishek Rai, organizing secretary, Professor S.K. Chaudhary, treasurer, Dr. B.K. Sonu, coordinator, technical sessions, Professor A.S. Ansari, coordinator, press and media, Professor S.S. Shah, coordinator, hospitality, representatives of the press and electronic media, other distinguished academicians and personalities in the audience, ladies and gentlemen, and my dear students. It is indeed a matter of great happiness that the Department of Chemistry, Ellen Mikula University, is organizing an international conference on recent advances in chemical sciences in hybrid mode. The topic of the conference is very pertinent and legit. I emphasize the word legit, and why I am using this word, I will explain later on. I am delighted by looking at the list of distinguished speakers and resource persons. We are fortunate to have with us Professor Sam S. Pandey of KIT Japan, and he will also be delivering keynote address. Professor Pandey, on behalf of the university and on my personal note, I welcome you once again and extend my greetings to you. Professor Ashutosh Sharma of IIT Hyderabad, Professor R.S. Ningpolam, Senior Scientist, BARC, Mumbai, Dr. Souvik Samantha, Drug Discovery and Development Center, University of Cape Town, South Africa, Dr. Narendra Mishra, Department of Chemistry, University of Copenhagen, Denmark. What a wonderful congregation. Researchers from 3 continents are here to share their knowledge with the faculty and students of our university. I am confident that the deliberations during the conference would be of a very high level. On behalf of the university and again on my personal note, I welcome all the speakers in this conference and extend my greetings. The credit of organizing the conference of this level goes to Professor K.K. Jha, Head Department of Chemistry, and his team of faculty members and research scholars. I appreciate their effort wholeheartedly. I am sure that the chemistry teachers and a large number of student participants would be hugely benefited and academically enriched by the high quality lectures and deliberations by distinguished professors and researchers from various parts of the world. It is very satisfying for me that the responsibility of organizing a conference of such level is shouldered by 2 very young teachers of the department, Dr. Simant Srivastav as the convener and Dr. Abhishek Rai as the organizing secretary. I congratulate the department for their effort. Now, as I mentioned earlier also, the topic of the conference is very pertinent and legit. Here I mean pertinent means genuinely or truly. So chemistry is genuinely required to clean up, and legit means clean up your own act on the right or the wrong side. Now the role of chemistry in our life, we are all familiar with it, how much we need chemistry, and the research in chemistry is genuinely required. But along with all the benefits of chemistry, we are also aware of its other side, and there we need to legit it. Chemists study the various substances with a particular focus on the process by which one substance could be transformed into another. Generally, the objective is to produce a more valuable substance. History of science tells us that it all started with alchemy in olden days. Human beings have always had the quest for the philosopher's stone, which is a magical substance that would transmute ordinary metals such as iron, copper, tin, lead, etc. into silver and gold, and also devoted their efforts to prepare the elixir of life that would cure any disease, including the ultimate disease, the death. The philosopher's stone and the elixir of life could be considered parallel quests, for each would cure metallic or human bodies, respectively, yielding immortal perfection. And thus, the science of chemistry evolved as the human population on Earth increased gradually along with the man's aspiration for quality and comfortable living. We started depending on chemistry more and more. The use of chemical fertilizer to increase the agricultural yield and chemical products became essential if the world's population is to be clothed, housed, and fed. From the toothpaste in the morning to foods and medicines to mouthwash in the night, we are heavily dependent on chemistry. For the first two-thirds of the 20th century, chemistry was seen by many as the science of the future. The potential of chemical products for enriching society appeared to be unlimited. Increasingly, however, and especially in the public mind, the negative aspects of chemistry have come to the fore. Disposal of chemical byproducts at waste disposal sites of limited capacity has resulted in environmental hazards and health problems of enormous concern. The legitimate use of drugs for the medically supervised treatment of disease has been tainted by the growing misuse of mood-altering drugs. The very word chemicals have come to be used all too frequently in a pejorative sense, that is, in a negative or derogatory sense. There is, as a result, a danger that the pursuit and application of chemical knowledge may be seen as bearing risks that outweigh the benefits. However, we have to accept that long-term, environmentally acceptable solutions to pollution problems are not attainable without a better knowledge of chemical sciences. There is such truth in the aforementioned that chemical problems require chemical solutions. Often, common man blame the progress of science and industrialization for our environmental issues. But where the science and technology has reached today, we cannot go back. What we have to do, we have to improve our knowledge of science more and more, and apply that to technology to reduce the effects we have already done on the environment. So chemical inquiry will lead to a better understanding of the behavior of both natural and synthetic materials, and to the discovery of new substances that will equip future generations to meet their needs better and deal with their problems. Progress in chemistry can no longer be measured only in terms of economics and utility. The discovery and manufacture of new chemical goods must continue to be economically feasible, but must also be environmentally acceptable. The impact of new substances on the environment now needs to be assessed before large-scale production begins, and environmental compatibility has become a valued property of these materials. So my dear students, whenever you will be synthesizing any new material, you have to keep the environmental aspect of the substance in your mind. Now earlier we have to use many chemicals for research, but now with the improved knowledge of machine learning, computational science, computational chemistry now is a big branch of chemistry, and I have seen that that is also there in your sub team. So through this AI, artificial intelligence, we can perform experiments. Without performing the experiments, we can get the result, we can visualize what is going to happen. So there is now no need to use the chemicals always and throw them in the soil. We drain our chemicals, most of our chemistry labs, they are not equipped with proper disposal of chemicals. We just throw the chemicals in the drains and they go to the groundwater and again we extract that and we treat that. So this is a very important aspect, my dear students. Whenever you will be performing any experiment or your studies or research, you must think of the environment. Chemistry has justly been called the central science. Learning chemistry helps us better understand the world around us and is critical to human, animal, planet, and overall health of the earth and its sustainability. Chemistry, as we all accept, is most important subject of science and is a link between all branches of science, be it physical science or biological sciences. A good understanding of chemistry is therefore very important. It helps us understand the world around us better and improve the quality of life. My earlier speaker have already thrown light on the pandemic situation and how we are dependent on chemistry, whether for medicine or for vaccinations or for the PPE kits and other protective gears that our medical personnel wear and the common people also wear. So we all know about that. So my dear students, you are very fortunate that you got an opportunity to study chemistry, and I am very happy that you have such a good team of teachers who are organizing conferences of such level. So once again, I congratulate all of you, the teachers, organizing committee members, for choosing such a wonderful topic, which is the need of the hour. I extend my best wishes for the success of the conference. I must mention that I'm very delighted that the sub-theme includes computational chemistry and green chemistry. I think you have to bear with me again in the afternoon in the valedictory session. So there I would like a few words on green chemistry. Thank you all. Thank you very much.
Thank you so much, ma'am, for your informative words. Teamwork is the obvious ability that is required to translate any vision into reality. With these words, may I take the honor to request our Vice Chancellor, Dr. Professor S.P. Singh sir, to address the audience. Prior to this, he was the Vice Chancellor of Lucknow University and presently is the Vice Chancellor of 4 universities. Sir is visionary, learned, and a wonderful administrator. We are honored to have such a leading personality as the Chief Patron of E-ICRACS-21. You're welcome, sir.
Thank you to everybody. I think it is my second visit to the department. The first visit was the wonderful personality, learned man, great man, legend of the university, and authority of the subject, with late Professor Ratan Chaudhary. I must pay the tribute to his soul departed with us. Really, it's a great occasion for me here. Today, on the occasion of your international seminar, E-conference, my learned colleagues sitting over here, patron of the conference, Vice Chancellor of the University, Professor Dadisina, co-patron, Registrar of the University, a learned personality, Professor Mushtaq Ahmad, wonderful man, learned personality, Dean Faculty of Science, Chief Guest of the function, Sir B.S. Shah, President of the conference, Head of the department, Professor K.K. Jha, Head of the departments of the PG departments of the university, Principal of the college, Professor Mishra, faculty members, dear students. The person, the learned speaker, keynote speakers joining us on the platform, I must welcome them and take gratitude for their cooperations, for their painstaking and to coming with us, joining with us. Professor Sam S. Pandey from Japan, Professor Ashutosh Mishra, IIT Hyderabad, Professor R.S. Nankumjam, Bharat Mumbai, Dr. Souvik Samanta from South Africa, Dr. Narendra Mishra from Denmark, other peoples who are joining us from each platform or either sitting a friend from the media. The topic that has been chosen by the organizing team, it's a wonderful topic, and it's a topic with the life. Because if the things have anything without the life, that means no movement is there, nothing is there, no advancement is there, no life is there. Now, if life is missing, then we imagine nothing could be happen in the sense, nothing could be happen in the society, nothing could be happen in the society. In that way, you have chosen a topic, recent advances in chemical science. I must congratulate to the team, organizing team, for choosing such a wonderful topic that relates with the life, that have a relationship with the life. Suppose if there are any things without movement, what will happen for that particular thing? So movement is very necessary for any kind of life. If you are living, so movement is necessary for that. And if you are to just enjoying the life with all satisfaction, with all welfare, with the all-round development of the life, enjoying the life, and that means the advances what is to be going on the particular discipline, but knowing to them is a very important, very essential. Without knowing the essentials, we cannot fight with the present, we cannot save the future. So advances, advanced movement is a wonderful thought, it's a very important for the enjoying the present life and also same time for the shaping our future life in that. We know that two things are the very important in our life. One, imagine, without these two things, life is nothing. One is the strength or to live the life. Passion to live with the life. Without passion, without strength, nothing could be happening in life. So that is the inner strength, that is the inner passion, comes from within from yourself. is the one important aspect. And the second aspect that is needed, that is the environment, that is the atmosphere to create, to generate, to perceive, to protect your vision, your passion. So the first thing is your hand. The first thing, very first thing, to create a passion within yourself. It's very much in your hand. So no one else to create that passion within you. It's only and only you. But the other things, we are not able to create the environment what is suiting with us. Cannot. Suitable environment we cannot create. We cannot say if the all suitable environment will be there, we'll do that. So never will be happen. The suitable environment, the suitable atmospheres will never come with you and say to you that you do these things, I am with you. Nothing never happen in your life. So always, the one thing that is important thing that is governed by you, created by you, generated by you, preserved by you, that is your vision, that is your passion, that is your dedication, that is your object. So you just decide your passion, just decide your vision, just decide your object. For the second thing, your chemistry comes in that way. For the second things, your chemistry comes in that way. Concluding my speech, telling you that thing. The one thing that is more important for that, it's one saying, don't get upset with the people, the situation, with the people, the situation, because both are powerless. Don't get upset with the people and the situation because both are powerless. कुछ दम नहीं उनमें. दम कहाँ है? Without your reaction. Don't get upset with the people and the situation because they are powerless without your reaction. Your chemistry is there. Unless you are providing the reaction in that way, nothing could be damaged in your heart, nothing could be damaged in your anything. Nothing could be damaged. So when the moment you just react to everybody, to destroy your energy in that way. When you are just reacting to the situation, and sitting at dharna and other things, you will never get anything what you just perceive or decide. So I must congratulate the team, organizing team, convener of the team, Dr. Simon Srivastava, organizing secretary, Dr. E-ICRACS, coordinator, Professor A.S. Ansari, treasurer, Professor S. K. Chaudhary, coordinator, technical session, Dr. V. K. Sunu, coordinator, hospitality, Mr. S. S. Jha. For deciding the topic, to undertake the responsibility to complete the e-conference on e-platform, inviting the such people, me and you both. Without the participators, without the students, without the youth support, it could not be happen. The seminar could not be happen for the successful result. Thank you so much for calling me, inviting me, giving this opportunity to interact with you. It's a wonderful opportunity for me with interaction with you people, to the students, especially to the faculty members. Thank you.
So we will have a photo session of this association in front of Rangoli.
Thank you, sir, for inspiring us with your precious, loving, and kind words. How quickly time flies. With this, the inaugural session draws to its end. Now, I would like to call upon respected Professor A.S. Ansari, sir, to take the rostrum and convey a vote of thanks.
Good morning to all of you. Our Chief Patron, Honorable Vice Chancellor Sir, Patron, Honorable Vice Chancellor Ma'am, Chief Guest and Dean Faculty of Science, Jeta Sir, Co-Patron and Registrar Sir, President of this E-Conference and Head of Department, Jeta Sir, our ex-GSW, Ashok Kumar Jha Sir, Head of Department of Physics, Kumar Singh, and Principal, MS College, Raymond Vishal. Our resource persons from India and abroad who are connected in the conference. Distinguished guests, professor and faculty members, delegates, students, online and offline, and of course of electronic media. I am thankful to our Honorable Vice Chancellor Sir, who has given consent to inaugurate the International E-Conference and spending his precious time from his busy schedule. I can only say, कुछ लोग थे जो वक्त के सांचे में ढल गए, कुछ लोग थे जो वक्त के सांचे में ढल गए, कुछ लोग हैं जो वक्त को सांचे में ढल गए। शुक्रिया सर, आपके शामिल होने से रौनक तो बढ़ी। शुक्रिया सर, आपके शामिल होने से रौनक तो बढ़ी, वरना ये महफिलें इंटरनेशनल E-Conference अधूरी रहती। Bunch of thanks to our Pro Vice Chancellor Ma'am for valuable suggestions and kind information. I am very much thankful to our Dean Faculty of Science, Professor V. Jha, for sparing time for the E-Conference. A lot of thanks and compliment to our young dynamic registrar, Professor Mushtaq Ahmad Sahab, for whom I can say, वाबिस्ता हो गई हैं उम्मीदें आपसे, वाबिस्ता हो गई हैं उम्मीदें आपसे, उम्मीदों के चिराग जलाने का शुक्रिया। Millions of thanks to our online guests, keynote speaker Professor Shyam S. Pandey, Kyushu Institute of Technology, Japan, Professor Ashutosh Mishra, IIT Hyderabad, Dr. Sanvik Samanta, South Africa, Dr. R.S. Nickthausen, BRA, Howard Community Center, Mumbai, Dr. Nandita Mishra, University of Copenhagen, Denmark, who gave consent and spared their valuable time for the E-Conference. I must thank to our university head, Professor K.K. Jha, whose dynamic leadership helped accomplishing this event, and our faculty members, Professor S.K. Chaudhary, young dynamic convener, Dr. Sriman Srivastava, enthusiastic Dr. Abhishek Rai, Dr. Vikas Kumar Sonu, our colleagues from other colleges, and our students, research scholars, not staff, for their day and night work. I thank all the distinguished delegates, research scholars, for all places, our electronic media persons. All the audiences, hats off to you. Thanks so much for paying valuable attention. यादों के रूप में रहेंगे सबके साथ, यादों के रूप में रहेंगे सबके साथ, आप सबके यहाँ आने का 100 बार शुक्रिया। Thank you.
Thank you, sir, for presenting vote of thanks. Now, I request Anurag, Manisha, Pallavi, and Nikita to come over. I request everyone present here to please stand on their respective places for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता, पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा, विंध्य
हिमाचल यमुना गंगा उज्जल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जय जय मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे I request our Honorable Vice Chancellor Sir to kindly permit us to close this inaugural ceremony and allow us to proceed for the next technical sessions of the E-ICRACS-21. Thank you for being with us. Thank you so much. I request all the dignitaries, respected professors, delegates, print media persons to kindly join us outside for the high tea. Thank you so much again.
Good morning, Shyam sir. We are audible to you. Good morning, Shyam sir. Unmute yourself, sir. Sir, unmute yourself.
Konnichiwa Sensei. I can't hear you, sir. सुनाई नहीं दे रहा है. श्याम सर, सोनू बोल रहा हूँ. कुछ भी सुनाई नहीं. आपका माइक नहीं काम कर रहा है सर. माइक नहीं. अभी तक नहीं होता है.
Okay. Now can you listen? Is it okay?
बस थोड़ी देर में हम लोग का सेशन शुरू होगा सर.
Okay. So if listening, then all right. आवाज आ रही कि नहीं? सुनाई दे रहा है?
हाँ सर, अब सुनाई दे रहा है सर.
Okay, चलिए, thank you.
सर 2 मिनट का भी ब्रेक हुई है. अभी वाइस चांसलर सर आए हुए थे.
अच्छा, एक काम करें, मैं थोड़ा स्लाइड शेयर करके देखूंगा ना.
जरूर सर, निश्चित रूप से सर.
Okay, just a moment, because they last moment कोई problem ना हो. So let me stop your screen.
हम लोग बहुत दिनों के बाद मिल रहे हैं सर.
हाँ, sure.
और मेरा ही है काम आपको इंट्रोड्यूस करना सर.
Just a moment. Okay, can you see my slides?
नहीं, अभी तक नहीं हुआ है सर.
अभी नहीं.
नहीं हुआ है, नहीं दिखाई.
Okay.
Yes, sir, it's visible.
Visible?
Now it's not.
Okay. How about now?
No.
No. Why some problem is coming in between? It should. Just a moment. Let me try once again. To stop share your entire screen. Share.
Yes. अब आने वाला है. आगे.
And then I think height, and if I see my presentation, where it is.
सर स्लाइड को ओपन कीजिए तो एक बार सर.
Just a moment.
Your screen is shared. Yes.
अब स्लाइड ओपन कीजिए सर.
Just a moment.
स्क्रीन शेयरिंग हो गया है सर.
Okay.
So
आ रहा है सर, फुल मोड में. यस सर, हो गया सर.
now is it okay?
Yes sir, thank you sir.
And slide is also moving, you can see.
Yeah, now it is location and location.
Okay.
Yes sir.
Okay, now I got it. Okay, so I will do in this way.
हेलो हेलो, हाँ हाँ बोलो. नमस्ते भाई.
यस सर, अभी तो आपका ही पिक्चर है, बाद में जब भी आप स्लाइड शेयर कीजिएगा. सर स्लाइड शेयर करके छोड़ दीजिए सर, फर्स्ट पेज. हाँ हाँ सर. सभी कोई अपने स्थान पर बैठ जाए. सभी स्टूडेंट्स और फैकल्टी से निवेदन है कि जल्दी से अपना स्थान ग्रहण कर लें. अगला सेशन शुरू होने वाला है.
के बाद बिठाओ.
पार्टी जी नहीं आए ना. Sir, we are waiting for the chairperson to arrive.
Okay, no problem, no problem. Go ahead.
Sir. Please maintain silence. Hello. With permission of the chairperson of this session, technical session, Professor Ansari sir. Now it is my great privilege to introduce you the keynote speaker of this session, Dr. Shyam S. Pandey, Associate Professor at Graduate School of Life Sciences and System Engineering, Kyushu Institute of Technology. It is a formal occasion, but I can't remain formal because I have a lot of informal sessions with him. पहले तो फॉर्मल इंट्रोडक्शन जो कि सभी जगह होता है। गोरखपुर यूनिवर्सिटी से पढ़ाई करने के बाद ये नेशनल फिजिकल लैबोरेटरी पुणे से पीएचडी किए और उसके बाद पोस्ट डॉक करने के लिए जापान गए। फिर वहां पर पोस्ट डॉक करते हुए आज वहीं पर असिस्टेंट प्रोफेसर बन के अब एसोसिएट प्रोफेसर तक की सीढ़ी को पा गए हैं। वहीं क्यूसी इंस्टीट्यूट ऑफ टेक्नोलॉजी में जहां से कि सौभाग्य से मैं भी वहीं से पीएचडी किया और जब पीएचडी कर रहा था तो हमारे साथ ही ये हमारे सीनियर थे। वैसे तो जो भी और फॉर्मल इंट्रोडक्शन में हो सकता है, लोग 10, 20, 50 पब्लिकेशन करते करते थक जाते हैं। अभी करीब 2 सेंचुरी पब्लिकेशन का हो चुका है, इतने सारे पेपर्स और करीब 30 से ज्यादा पेटेंट्स हैं इनके हाथ में। और आजकल यहाँ के स्टूडेंट्स उतने अच्छे से नहीं जान पाएंगे, लेकिन पब्लिकेशन के बाद भी और एक होता है H इंडेक्स और I इंडेक्स, कि वो पब्लिकेशन तो किया लेकिन कितना अच्छा वो कितना इम्पैक्ट किया है और लोगों के ऊपर और भी साइंटिस्ट के ऊपर, उसमें भी बहुत ही हाई इंडेक्स दैट इज 35 H इंडेक्स एंड 132 I इंडेक्स। और इनका पब्लिकेशन किया हुआ लोग जो साइटेशन किए हैं 5,500 लोग इनके कामों का साइटेशन करते हैं। इनके बारे में एक इनफॉर्मल वर्ड से ना कहें तो मैं अपना काम नहीं पूरा कर पाऊंगा। फिजिक्स से शुरू की, सबसे पहले हमारे आपके जैसे ही बहुत ही छोटे से गांव से शुरू की जिंदगी और गोरखपुर से होते हुए दिल्ली होते हुए आज जापान में जाकर के भारत का झंडा लहरा रहे हैं। फिजिक्स की पढ़ाई करते हुए आज हमारे साथ केमिस्ट्री में जब थे तो केमिस्ट्री वाले को भी केमिस्ट्री पढ़ा सकते हैं और फिजिक्स वाले को तो फिजिक्स जरूरी पढ़ा सकते हैं, और इससे भी ज्यादा जापानीज लोग को जापानीज भी पढ़ा सकते हैं, इतना वर्सेटाइल है। और इनके रिसर्च वाले फील्ड को देखेंगे तो बायोचिप सेंसर्स, प्रोटीन को लेकर के हम लोग बहुत ही माइन्यूट से माइन्यूट सेंसिंग कर सकते हैं। फिर उसका सोलर सेल्स के साथ किस प्रकार से सोलर सेल्स की एफिशिएंसी बढ़ा सकते हैं, इन सब के ऊपर उन्होंने बहुत रिसर्च किए हैं। आज हम लोग के पास वो उनका टॉपिक है immense solar energy harvesting by photosynthetic mimics of dye-sensitized solar cells। मैं श्याम पांडे सर को इनवाइट करता हूं उनके प्रेजेंटेशन के लिए। थैंक यू सर। सर keep it little bilingual if it is possible sir।
Bilingual? Okay, चलिए कोशिश करता हूं मैं। अब आपका अनुरोध है तो हिंदी में भी थोड़ा कोशिश करूंगा कि कुछ बात करने का। So anyway, thank you very much for kind words and very nice introduction. And I hope many of students are there. So I will not go into the very finer detail and difficult parts. So I will try to simplify so that students can enjoy the lecture. By the way, how much time do I have? Time for my lecture?
25 minutes for your lecture, sir, and then we will have 5 to 10 minutes for your
5 minutes is too less. Anyway, let me try. Okay. So, thank you very much. So, as it was introduced that today I am going to talk on immense solar energy harvesting by photosynthetic mimic dye-sensitized solar cell, plenty of rooms for chemists. Because many of students, you are of chemistry background. So in spite of talking too much physics, I will talk more on chemistry. Before starting my talk, just briefly, as you can see, this is a map of Japan and world map, and you can see Japan is in the center. And in the south part of the main island, Kyushu Island, our institute is located. We have 3 campuses. Currently, I am in Wakamatsu campus. First campus was established, Tobata campus, around 110 years ago. Then Ichika campus was established in 1989, and this campus started 2001. I came here in this campus 23 years ago. Now this new campus is located in Science and Research Park of the Kitakyushu city, where the major university, they have made their graduate school. I want to make it clear that it is purely engineering institute like IIT, where we have all the engineering branches. And this red dotted highlighted, this building is our graduate school. We have maximum capacity of the student in 1 year, master student, MTech 140, PhD 40. So total maximum we can take 180 students. Faculties are there 70. So ratio of teacher and students is almost 2:1. Anyway, after that, as my lab is related to organic photofunctional materials and device, 3 major areas of the research where our lab is working. One is the next generation solar cell. Another is the organic electronic devices. And the third major area, or the thrust area of the research of my lab, is bioimage sensing. Today I will talk one area, next generation solar cell, and one part of that. The flow of my talk today is energy demand and solar cells, dye-sensitized solar cells, current status, need, design and development of NIR dyes, and application potential of DSSC. Many of you might not have heard about this kind of solar cell, but I hope after this you will be well aware. So to begin with, the first topic, energy demand and solar cells. As you know, we are very lucky that on this earth, we are benefited by the mother nature. We have water, wind, light, land, and they constitute the life form living being. क्योंकि हम सभी लोग जानते हैं कि क्षितिजल पावक गगन समीरा पंच तत्वते रचे शरीरा. So in nature, these inorganic part, non-living part, they have a very nice cooperative existence to make the life. And to sustain the life on this earth, it's very key process. All the students might have studied the photosynthesis, Prakash translation. And the best example of this cooperative existence is the plant and animal living cooperatively. And 2 major processes, photosynthesis and respiration. And see how beautifully both cooperate each other. Plant need carbon dioxide for photosynthesis and produce the food what we eat and oxygen. And we use that oxygen during respiration to produce carbon dioxide, what plants need. Such cooperative existence is one example. In fact, in nature, there are this cooperative existence at atomic level, molecular level, and even the process level. Only it is we, whether we can realize or not. One example as a dye-sensitized solar cell, I will give you all that how scientists learned from the nature to make a solar cell. So when we think about the solar cell, immediately what comes? Okay, it is a kind of machine that use light and make electricity. And this is very useful also, because I want to quote the very famous statement of Nobel laureate Richard Smiley, that on this earth there are huge many problems, as highlighted, energy and population. They are one of the biggest problem on this earth. Why? Because population and standard of life is increasing. Means it needs more and more energy. And when we talk about energy, I am sorry that if I use bilingual, it will take a more long time. So that's why I am continuing in English only. Sorry, because if I have a longer time, maybe I can speak in Hindi and English both. But bear with me. I will try to speak slowly and give the highlights. So we need, in front of us, we have a terawatt challenge. Terawatt means 10 to the power 12 watt. How to visualize this? As you can see, many of you are using laptop. It uses 1 watt. In the morning, you use toaster to toast, to make a toast. That uses kilowatt. You travel by aeroplane using megawatt. With nuclear reactor, we produce gigawatt. And on this earth, we need terawatt energy. As I told that, this energy and population, they are very well related. As you can see, the population in 2005, world population was 6.5 billion. At that time, it was expected, projected, that in 2050, it will be 8.9 billion. But it has increased with more faster rate, because as on today, the world population is 7.88 billion. So expected to be more than 10 billion by 2050. The nutshell of the story is world population is increasing steadily. So, and standard of life also. If we see the available resources, we have two categories. One is non-renewable energy, which cannot be replenished with the same pace, same speed at the rate of it is being consumed. They are fossil fuels, coal, nuclear, natural gas, and oil. We are using it, but we must know that it is very precious, because once finished, it takes millions of years to make it. Another option is renewable energy, like geothermal, tide, wind, solar, hydroelectric, and biomass. Actually, this energy, demanding energy, is very challenging to us. As you can see, in 2001, 85% of energy was coming from the fossil fuels like oil, gas, and coal. Less than 10% were nuclear and renewables. You can tell, oh, this is a very old story. But new 2015 data of world energy consumption also suggests that the ratio is same, around 85% is coming from the fossil fuels. In the fossil fuel, using is okay, but we all know that it is leading to the greenhouse emission, global warming. That has been verified by theoretical calculation and experimental data since last around 100 years. And in geographical scale, this 100 years is nothing. Another option is energy gap. Currently, we are using 14 to 16 terawatt in 1 year. In 2050, because population is increasing, we need around 28 terawatt. So it means we have to produce our energy double and more than 3 times by 2100. From where this huge energy will come? Still many of places we are facing energy crisis, electricity crisis in developing countries. Now the second option is, and fossil fuels, as we know, as I said that, they are limited. By this yellow curve, you can see the highest energy we are getting from the petroleum or oil. Its peak is expected to be 2037, and calculations suggest that it will finish by 2080. So my question is, after 2100, maybe our grandson are going to face a big problem. From where that energy will come? Another option is, can we have capability to get that much energy from renewable sources? Calculation by Caltech, California Institute of Technology, suggests that if biomass is all burnt, we can get maximum 5 to 7 terawatt. Hydroelectric 1.2 terawatt, geothermal 1.9 terawatt, tide ocean 0.7 terawatt, wind 14 terawatt. You combine all them, even they are not going to complete around 20 terawatt or less than 33 terawatt. Only hope is the solar energy, that is 10 to the power 5 terawatt. So it means, and we need around 20 terawatt in coming even 10 years later. So it means solar energy has a capability. To gauge this capability, sun in 1 hour emits 14 terawatt. What we need in 1 year. Sun is such a huge source of energy. And we know that we can make a solar cell. Now commercial solar cell are 15 to 18% efficient. The cheap silicon solar cell that based on amorphous silicon, they are 10% efficient. I am taking one example. If we use in cheaper solar cell based on amorphous silicon with efficiency of 10%, and if we cover this land area 0.16%, which is a part of the desert only, it will produce 20 terawatt power. What still we don't need. We are using 14 to 16. Otherwise, to get this energy, we have to make 20,000 nuclear reactors. Means 1 nuclear reactor every day for coming 50 years. And we know they are dangerous. We have not forgotten the Chernobyl nuclear accident. And to clear and completely demolish the Chernobyl nuclear plant is expected to be, it will finish in 2065. It takes a time. More recently, in 2011 in Japan, there was also meltdown, Fukushima nuclear plant. And it is going to take 25 to 30 years to completely decommission. So nuclear energy is not a viable option. And solar energy has a big hope. This is the reason, because solar cells are very fascinating. Because we can use immense solar energy. No pollution. Wide power handling capability means now we have the solar wattage from a small wristwatch to we have mega solar plant. And nevertheless, directly we are getting electricity from the light. That's why they are more attractive, and worldwide it is catching up. I don't go in much detail, but one thing I want to tell that The breakthrough in the solar cell came by the Bell Lab, United States, in 1954, when they found that by controlled doping, that was accidental discovery of the silicon, it increases its photosensitivity, photosensing behavior 1,000 times. And they demonstrated 6% solar cell very fast. And that was the beginning of modern solar power technology. And very soon they make 6% solar cell. And it was first used in Sputnik 3 Russian satellite as a power source. Many of you are science students, but majority of you are chemistry. Typically, these inorganic, currently commercial silicon-based solar cell are traditional PN heterojunction. It is a P-type semiconductor and N-type semiconductor fused together. And it works as a solar cell. The one thing, just only I want you to keep in mind for the students, inside the solar cell, the light absorption, after once light falls on the solar cell, charge carrier, electrons and holes, they are generated and they move in P layer and N layer. So the solar cell does the two jobs at one time. Absorbing the light, one job, carrier generation, two jobs, and carrier transport, three jobs. That is the reason very high purity of individual P and N type semiconductor is level, and you people don't know the purity should be more than 99.9999999%. If you see the sunlight, it is consisted of ultraviolet, visible, infrared radiations. And at the bright sun, full sun, the maximum intensity energy power is coming 1 kilowatt in 1 meter square. So, I will just request, if I have remaining just around 5 minutes, please tell me so that I can make it faster. Otherwise, I will go a little bit slowly.
You have 10 minutes, sir.
Huh?
10 minutes.
10 minutes. Okay, okay. So let me go it faster. So anyway, what I wanted to tell that in 1 meter square, 1 kilowatt. To give the students an idea, if we can make a solar cell of 1 meter by 1 meter, and if efficiency is 10%, you are going to get 100 watt. What to do? Second, it suggests that we need its large area installation. And the efficiency of solar cell is calculated by this relation, power out by power in, which is 100 milliwatt per centimeter square. And this is a photovoltaic curve consisted of short circuit current density, open circuit voltage, and fill factor. As we can see here, the solar energy scenario was 0.002% of the total energy utilization in 2001. Even we increase, we can see everywhere solar installation, but it's still in United States, such a developed country like US, only 0.6%. All the governmental organizations are promoting, but still its usage very less. Why it is less? The answer is the cost. For example, $1 consists of 100 cents. So to produce 1 unit energy, 1 kilowatt hour, coal, gas, and oil, they need only 1 to 5 cents. On the other hand, solar energy harvesting needs by solar cell needs 25 to 50. This is the region we are bound to, so cost is driving the utilization. And you can see here the champion efficiency, the silicon solar cells are there, but they are very costly. And to make them as a singular use, they have to use a large area. And this is, considering this, the new kind of solar cell, we call the next generation solar cell, they become or came in limelight after 2000. There are 3 categories: DSSC, dye-sensitized solar cell, polymer, and perovskite. In my group, we are working on all, But today I will take one aspect, DSSC, dye-sensitized solar cell. Now for a student, when we come dye-sensitized solar cell, immediately reflects in our mind is a colored molecule or dye molecules. Many indigo or other colored material, many of chemistry students might have seen. So this is a kind of solar cell which uses colored molecule or dye molecules to absorb photons and convert into the electrons, like make electricity from the light. This kind of solar cells, they are inspired from the natural photosynthesis. Because in natural photosynthesis, colored molecules like chlorophyll, they absorb the light and convert this energy into the chemical energy like a glucose during photosynthesis. And so this solar cell inspired by photosynthesis. It takes the help of electrochemistry for redox reaction. But using this process, the solar cell was although discovered in 80s, but efficiency was less than 0.1%. Later on, during 2000, when nanotechnology came into the picture, since time is less, I don't want to go to much detail, efficiency was enhanced to 8%. And this came into the limelight. So since it uses light, use electrochemical process, that's why such solar cells are also known as photoelectrochemical solar cell. As you can see, photosynthesis you have studied. That light comes, there is light reaction, dark reaction, you have all studied in your books. But what is the message hidden in the photosynthesis, we forget. You can see here the famous G scheme of the photosynthesis, and you can see the chlorophyll, the photosystem 1 and 2, these chlorophyll molecules absorb light, excite electron from their valence band to conduction band. And then this electron is taken by the electron transport chain. Unlike the traditional silicon solar cell, in photosynthesis, the role is divided. There is a division of labor in nature. That's why system works very well. So dye-sensitized solar cell was inspired by this. Second, like different colored molecule, pigments are there, we can use natural dyes. And India is a tropical country. We can use this kind of colors from the flowers, roots, fruits to make a solar cell. To make a solar cell, what you need a suitable dye, an electron acceptor, hole transporter, hole acceptor, and electrode. For example, the dye has a duty to just boost electron from the valence band to conduction band, and then there is electron acceptor like titanium dioxide or tin dioxide or zinc oxide, that takes electron and electron moves. And this hole created is filled by the electrons from the hole transporter. So electron comes here, hole moves like this. So this is hole transporter. And if we use two electrode, they will collect electron and holes and solar cell will work. Another, these electron and hole acceptors are colorless. So the color of the solar cell is the color of the dye. This differentiates them from the silicon solar cell. This is transparent, colorful, beautiful. So no need to only on rooftop. They can be used on the windows of the house to give them not only the beauty, but also allow them for energy harvesting. Anyway, this is just a general composition that this is transparent conducting glass onto the titanium dioxide nanoparticles. We coat the monolayer of dye, and then we have another electrode, counter electrode, with catalytic layer like platinum or some other catalyst material like conducting polymer we can coat, and then these two working and counter electrode are joined together to seal them by putting the electrolyte. And when you shine the light, the dye molecule has their duty. They take electrons, boost to conduction band, inject into the electron acceptor, goes to the external circuitry, and oxidized dye is regenerated by electrolyte, via redox reaction from the electron coming from the external circuitry. In this way it works. Since it uses cheap raw material, simple coating and printing, we can make them cheaper. Unlike silicon solar cell needing a clean room, high temperature, sintering around 2000 degrees Celsius to making single crystal, wafer formation, purification, junction formation. That's why that is costly. Well, these are some of the, in last 20 years, you can see the best kind of solar cells approaching efficiency around amorphous silicon solar cells. If we see the spectral, since you are the chemistry student, if we want to increase efficiency, we have to increase the open circuit voltage, fill factor, and short circuit current density. But to increase, we must know that how VOC is controlled. So VOC is controlled by the electron transporter's energy level conduction band, like in the case of titanium dioxide, -4 electron volt. In the case of redox electrolyte, iodine base, -4.9 electron volt. So we can get maximum 0.9 volt. That is the voltage. On the other hand, so if we want to increase this VOC, either we have to use some electron transporter like TiO2 with higher conduction band energy, or some redox electrolyte with a deeper redox energy level, so that we can increase the VOC. For that, chemist has done a lot of things, like we can use different complexes to make redox electrolyte based on cobalt, thiolene, spiro, etc., to with a deeper energy level, so that we can increase the VOC. Another factor is the JSC. The current is controlled by the how much photons has been absorbed. That is controlled by the dye molecules. So it depends on their color, whether if it is like yellow color, 500 nanometer, you can get only this much current. If you absorb up to 900 nanometer, you can get high current. So current is controlled by the optical absorption window. Visible light is only 45%, and the good thing is that even with the visible light, right now we are getting efficiency more than MR for silicon solar cell. So this gives us the good hope. As you can see, they absorb only the visible light. Even efficiency 13%, 12% is there. This gives a good hope that state-of-art technology for making this kind of solar cell is perfect in the last 20 years. What is lacking is a suitable dye, that is NIR dye, which can absorb efficient light after 700 nanometer. So, and this gives the practically achievable efficiency that using a fill factor 0.75, VOC 0.75, if we absorb mainly visible light up to 800 nanometer, we can practically achieve efficiency 14 to 15%, and which in fact achieved. Now we don't have the dye. So I say the ball is in the hand of chemists. So if they can develop some good NIR dye up to 900 nanometer, we can make 18% solar cell, 1000 nanometer, 20% solar cell is not too far. By going to the higher wavelength light, we need an IR light. You all know, because of lack of time, we can use porphyrin, cyanine, phthalocyanine, squarines dye with the extended pi conjugation, so that their band gap become lowered and we can absorb light in the high wavelength region. Of course, all the colored molecules are necessary, but they must fulfill certain criteria like this to work as a sensitizer. The question is, now the science has become modular. For example, this dye gives 12% efficiency, but a chemist need to make in such a multiple synthesis, multi-step synthesis. So now the science has become that we do computational molecular design. We calculate on computer to whether our material is fulfilling all these criteria or not. If fulfill on computer, then we ask chemists, okay, make this material, this has a chance to work. And once it is made, it works also. Just because of lack of time, for example, I can show this molecule, this gives 6% efficiency, and computational data gives the electron density distribution. And maybe some other occasion, if I have a time, I can talk in detail, but we can calculate the energetic match as well as their electron density distribution to justify whether they can be used or not. In that, I will just miss The most reliable calculations are based on the solution of Schrodinger wave equation, and you might be university student, you know how much difficulty it is to solve for one electron system hydrogen molecule ion. For such a big complex molecule multi-electronic system, it is beyond the human brain. So there is a need of a logical compromise of the calculation, algorithm, system, and computation. We have demonstrated that using, for example, comparing the experimental data with the HOMO means balance band energy and absorption maximum, if we use a proper algorithm during theoretical calculation, we can predict more accurately. On the other hand, to define that how much minimum energy gap is needed to inject electron into TiO2, we designed several molecules, and by that we proved that minimum 0.15 electron volt gap is needed to harvest the light. Similarly, we designed the novel molecules, and by that to get the minimum driving force for regeneration of the oxidized dye. And by that we proved that 0.1 electron volt, 0.12 electron volt is necessary. By that we came to the conclusion that, please allow me 2-3 minutes more. I will conclude very soon. So by this our analysis, we proved that the dye with the NIR dye until 1.17 electron volts, that is 1060 nanometer, can be used to make dye-sensitized solar cell with titanium dioxide as electron acceptor and iodine base I minus I3 minus as a whole transporter or electrolyte. Our idea is to use, because we are mainly focusing on NIR dye, because visible dye has been done, and then the couple them together to make, for example, 10% visible, even 5% NIR dye is there, we can make 15%. But some may ask a question that whether really 1 plus 1 is 2. It's possible to have a summation of the efficiency. In that case, we have demonstrated using our yellow dye, orange dye, D35, and blue dye developed in our lab, squarine 110, and you can see their absorption complement very each other. Energy also complement very well, and we demonstrated in mathematics we say 1 plus 1 is 2, but in science and philosophy it is not always true. 1 plus 1 may be less than 2 or more than 2 also. We justified that if you see this blue dye alone gives maximum efficiency 2%. With orange dye alone gives maximum efficiency 3.6%. When we mix together in 1:4 ratio, orange is to blue, it gives 2.5% decreased. But if you just opposite 4:1, it gives 7%. So in science and philosophy like a success and failure, in science, summation or deletion depend are detrimental effect. Based on that, you can see we have developed a very recent dye, cyan colored dye gives 4.5% efficiency, mainly in far red, efficient photon harvesting, very beautifully green colored dye making a green solar cell with efficiency 6%. We have recently demonstrated these kind of solar cell are colorful and beautiful, so they have different kind of application. Now worldwide, big panels of this kind of solar cells are being installed outside to check their long-term stability. Company has also started its production non-glass metal foil-based flexible dye-sensitized solar cell, and now they have commercialized also. They are in the market. You can buy like a backpack, bicycle pannier, remote control, keyboard, etc. Based on that, I would like to acknowledge the efforts of the students of our past and present, and financial supports from the governmental organization, Japanese government, and you people who are listening my lecture and given me the chance to speak in front of you. Thank you very much. If any question or comment, most welcome.
Thank you, sir.
I'm sorry if I am a little bit delayed in my presentation. I tried, but...
No No,
It
sir.
might have little bit of.
It was our pleasure to listen to you, sir.
Thank you.
You have given us a perspective from global perspective to the molecular perspective about the present energy problem and solutions, and from the solar cells, which are being researched upon by your team. I have a small question in this. You have emphasized that your dye-sensitized cells are for visible region and infrared regions, and
Yes.
not for UV regions, because UV intensity is quite low inside our atmosphere. Can we think of dye-sensitized solar cells for UV region for to be used in space exploration, sir?
Okay, thank
UV intensity will be very high, and energy density in UV region is very high. So any amount of efficiency will be great efficiency, sir. Please, sir.
Okay, thank you. Thank you very much, Var. Good question. But the thing is that, as you also know, that UV region, of course, it is a narrow, but it has a very high energy. So that destroy the dye molecule. So now the photocatalysis people, they are using like a UV light to clean water or degrade organics from the sea. So the basic idea is, if we are using, the cell will not be very stable. Our organic dye will be destroyed. That's why we try to avoid the UV region and compensate that in the IR region.
Okay, sir. Thank you, sir.
Okay.
Now, since we are exceeding our time, I request Professor Ansari to come and give a vote of thanks for our keynote speaker.
Many thanks, Dr. Shanis Pandit from Kyushu City, Japan. How beautifully and in lucid manner and simple manner he has explained the need of solar energy and conservation of energy, because sooner or later we have to face it. He has also explained nearly 2050 we need much more energy than we require now. And all the options are there, but they are not sufficient. Like hydroelectricity and solar energy. He has beautifully explained the need of photosynthesized life, cyanide, phthalocyanine, naphthalocyanine, and others. Once more, I thank him and wish him all the best for his future. Thank you, Dr. Shyam.
Thank you. Thank you very much.
Sir, before you go offline, a personal note, हमारे बच्चों के लिए जहाँ तक मैं जानता हूँ, पांडे सर वहाँ पर बहुत ही अच्छे रिसेप्टर हैं हमारे स्टूडेंट के भी। भारतीय स्टूडेंट जो कोई भी आउट ऑफ इंडिया एक्सप्लोरेशन करना चाहते हैं, तो वहाँ पर बहुत अच्छे होस्ट बन जाते हैं। और जो कोई भी थोड़ा सा ट्राई करे अपने केमिस्ट्री को मजबूत करके, यहाँ पर तो केमिस्ट्री ही, वहाँ फिजिक्स और केमिस्ट्री दोनों मजबूत करके, तो सर आपसे आशा रहेगी कि हमारे स्टूडेंट को थोड़ा सा आगे चल के थोड़ा सपोर्ट मिल जाए सर, इसके अलावा भी प्लीज सर।
जरूर। सबसे बड़ी बात तो ये है कि कोई जगह छोटी बड़ी नहीं होती। कुछ लोगों को होता है कि हम जेएनयू के पढ़े हैं, हम दिल्ली विश्वविद्यालय के पढ़े हैं, तो हम कोई तीर मार लेंगे, ऐसी कोई बात नहीं है। क्षमता हम सब लोगों के भीतर है। मैं भी गोरखपुर विश्वविद्यालय से पढ़ा हूं, ऐसी कोई बड़ी यूनिवर्सिटी नहीं है, लेकिन तो मेरा ये कहना है कि आप सभी लोगों को भीतर क्षमता है, वो छिपी हुई है, हम उसको ला नहीं पा रहे हैं। रही बाहर प्लेटफॉर्म की, आप अगर कोशिश करेंगे, मेहनत करेंगे, तो सफलता जरूर मिलेगी और हम कहीं भी रह के कर सकते हैं। ऑफ कोर्स ये चीज जरूर होता है कि हम उस बड़े लेवल का फैसिलिटी के अभाव में रिसर्च न कर पाए, लेकिन आइडियाज या सोच को तो हमारे कोई नहीं रोक सकता। वो हम कहीं भी रह के कर सकते हैं। दूसरी बात, आप लोग मन लगा के मेहनत करें और पढ़ें। और जहां तक रही सहयोग की बात, तो मेरा ईमेल एड्रेस होगा, और कुछ लोग अगर एक्सप्लोर करना चाहते हैं भविष्य में कि बाहर जाना है या राय लेना चाहते हैं, तो बेझिझक मुझे कभी भी ईमेल कर सकते हैं। जितना मुझसे होगा मैं अवश्य सहयोग करूंगा। हाँ, बाहर रहने के नाते एक मैं भी विदेशी हूं, ठीक है, मैं परमानेंट रेजिडेंट हूं, अलग बात है। मैं हिंदुस्तान नहीं आ सकता, ये कमी है, लेकिन ये तो जरूर कोशिश कर सकता हूं कि अपने जैसे भाइयों को ट्रेंड कर सकूं, उन्हें और क्या कह कि और सुधार सकूं, कि हिंदुस्तान को सौंपूं। और मुझे अभी भी खुशी है, मेरे बहुत सारे विद्यार्थी हैं जो हिंदुस्तान लौट के बहुत अच्छा कर रहे हैं। जैसे मेरे एक अभी विद्यार्थी हैं हमारे वहां से, उन्होंने एमटेक और पीएचडी किया, और वो आईआईटी इंदौर में एसोसिएट प्रोफेसर ही नहीं, हेड ऑफ डिपार्टमेंट भी है आईआईटी में। तो एक बार एक प्रॉपर ट्रेनिंग दी जाए तो जरूर संभव है। और इस तरह की पॉसिबिलिटी के लिए जहां तक मेरा सहयोग होगा, मैंने कहा ना कि मैं पूरे डायरेक्टली तो मैं अब हिंदुस्तान मेरा लौटना थोड़ा सा मुश्किल लगता है, लेकिन हाँ इनडायरेक्टली मैं जितना सपोर्ट हिंदुस्तान का कर सकता हूं कोशिश जरूर करता हूं और आगे भी करता रहूंगा। तो आप लोगों में से कोई भी लोग अगर ये चाहें कि किसी सहयोग की जरूरत है, एकेडमिक सहयोग की जरूरत है, किसी और एक तरह से कहिए राय जानने की जरूरत है, पॉसिबिलिटी एक्सप्लोरेशन की जरूरत है, सो प्लीज डोंट हेजिटेट, सेंड ईमेल टू मी। Certainly I will try to support you all as much as I can. Thank you very much.
Thank you, Shyam sir. This is Siman Srivastava. Thanks for accepting our invitation. Thank you, sir.
Thank you.
Thank you, sir. Now we move on to the second speaker of this technical session, Dr. Raghuram Mani Singh Ning Auzan. He is scientist
Thank you.
at Harvard Academic Research Center, Mumbai. He completed his master's from Manipur University and PhD from IIT Kanpur in the field of magnetic and superconductivity of metal nitrides. He was a Dr. K.S. Krishnan Fellow, and later he joined as a scientist at BARC in 2006. From there, he has been associated with many of the scientific communities, National Science Academy, Maharashtra, and he has been awarded many awards in this field, Scientific and Technical Excellence Award by Department of Atomic Energy, Young Achiever Awards from the Solid State Symposium. Now, he is with lot of achievements in publications and book chapters in the books, 150 papers and 7 chapters in different specialized books. Now he'll be speaking to us on the topic rare earth doped phosphors for light emitting display, light harvesting and its bio application. He is another person who we can chart out like coming out from one of the remote areas of our country and now shining brightly in the field of science. From Manipur, eastern part of Manipur to the western part. And now once again, speaking to us, Dr. Ning Auzan.
Okay, thank you. Thank you for introductions. Can I share my, can I share?
Yes.
Hello?
No, sir, not yet.
Yes. Not sharing?
Yes, yes, sir, it is.
Is share?
Yes.
Okay, just I cannot see, just a minute. Okay, what happened is, okay, under the mute. No, just a minute. Okay, just I share again.
Yes, it is visible to us and audible to us also.
Can I share again? Because I could not see myself. Yeah. Stop sharing. Okay, just a minute. Yeah. Okay. Okay. Okay, this share?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
This share?
It is clear.
Okay, can I start speaking now?
Yes, sir. Please.
Okay. So anyone want to stop, somebody just call me, okay? So no problem. Okay, thank you. Yeah. Good afternoon. I'm very happy to give my share of my works in this interesting conference. Today my topic is this layer DOF innovation for light emitting display and light harvesting and security in and temperature sensor and biosecurity applications. I belong to chemistry division, Baba Atomic Research Center, Mumbai. So I gave this talk. This was very happy that today given in my chemistry department of the Rajit Narayan Mithira University, Davangar, Bihar, and advanced in the chemical science this today. And I thank Dr. Simon Srivastava and his team member to invite me for a talk in this conference. Today, I will discuss the following. They are DOF innovation for the light emitting application, and they are DOF innovation for the light and energy harvesting and temperature sensor and optical switching and security in. They are DOF innovation for the biosecurity applications. Already my previous speaker, S.K. Pandey, has speaking about the light harvesting and this one. This is similar, some of the similar will be there. But I am using only their DOF system, how to do light harvesting. So there's some of the similarity was there. So actually, most of the that luminescence pattern is based on the because of the rare earths, means lanthanide compound. Okay, why? Because they have very sharp transition. Okay, so this sharp transition because of they can use that the ion have to use for the blue or green something. So the lanthanide compounds such as the europium oxide, the sponson carbonate, some oxide, the terbium nitrate are very sharp fit in emission, but poor luminescence. Okay, this is considered quenching effect. As also this because of FF transit the purity forbidden. Okay. Usually, how to this consider quenching reduce? Usually people drop lanthanide ions in semiconductor. Okay, semiconductor means that doping and they can reduce the cross relaxation among lanthanide ions. This one of these usually people used to do 1 or 2% or ppm prevented doping, okay, so that they can enhance the luminance enhancement. Advantage lanthanide ion doping in semiconductor. Large number of photons can be absorbed through the band gap of semiconductor because band gap has a valence band, conduction band can absorb light, and during this many electrons from valence band can be brought to the conduction band. Many horns are created in the valence band. Electron horn recombinations may give rise to the emission. If the emitted light from the semiconductor could be absorbed by the nearby dopant, the lanthanide ions, you can get the emission from the lanthanide very high because of energy transfer from semiconductor host to lanthanide ions. So this we have to remember one of the Nobel Prize this Nobel Prize given in 2014 in physics from Japanese group. One is Akashi and Amano and Nakamura. So they are working in 1990. This one, Akashi and Amano, and Nakamura is working in 1990s. They have discovered that how to produce a light emitting diode. So light emitting diode is actually now today we see light emitting diode using is because of the many contribution from many people, but only thing the main contribution is for 3 Japanese group. Okay, but they are preparing the compound gallium nitride. Okay, and from they produce a blue light emitting. Okay, but question is like that: whether only gallium nitride based system solve the LED is no. It is answer. In it, there are ions to produce a white light or any colors. So this luckily in 2014 was Nobel Prize given, and we written one review article in published in Focus Material Science with my PhD guide in Gatsby, and we published this paper in 2015. But original work paper was completed in 2014. We show important gallium nitride in this paper. Okay, but luckily we found that this our gallium nitride is published in this Focus Material Science, and also they're considered for the Nobel Prize as well. Okay, so this now gallium nitride produces blue light, and it is covered with a yellow light, like rare earth doping, serum doping in the garnet.
Sir,
Then you can get the white light. And this one of the, you see, two types of luminescence. One is actually down conversion, one is the up conversion. Okay, what is down conversion? Suppose light absorbing from the ground to excited state, and excited state electron goes to the some trapped event, and then it can emit these locus. So,
excuse me, sir.
yes, but
Sir, the slides are not moving, sir.
you don't moving? Okay, sorry, I can again. What happened is I don't know. Okay, just a minute. I don't just there's some problem was I don't know.
Yeah, it's okay now, sir. Yeah, please put in.
You have seen? You have seen? Okay, I just again do. What happened is not seeing. I don't know.
Please put in a presentation mode, sir.
This occasion.
Yes, sir. Now it is okay. Yes, sir. Now it is
okay.
Now change.
And I just see one by one by. See, you can see it?
Okay.
You can see it?
Yes, sir.
Huh? Okay. No, I want to say one by see. It's okay?
Yes.
Okay. Okay. Thank you. This two types of luminescence you can see. What is luminescence actually? Luminescence is nothing but you excite light and it can produce the emission. Okay. So this, if you use light of the light, you can photoluminescence. Okay. So the down conversion is nothing but you excited light in a ground state or excited state and come to trapped event. From that emission occurs. Okay. So light absorbed light energy is more than of the emission energy. This is called down conversion. Okay. So energy some losses. In the case of the up conversion, what happens in the up conversion case? Just the opposite came. What happened is light absorbed from ground state to excited state. Okay. Before coming down to ground state, another electrons hit that excited electrons and goes to the excited state E2. Okay. So ground state E0 to E1, E2. Okay. From E2, emission occur. Okay. This is called up conversion. So this both are opposite. Okay. So this will be energy in most of the working in any kinds of the luminescence. Okay. So down conversion, I talked to you some simple down conversion. Now they are top inhabitants. You see the valence band, the symmetric having valence band electrons go to excited state event in conduction band. This whole conduction band go to the trapped event, and then you can get the energy transfer to the excited state of the electron ion. Then you can get the emission for the electron ion. So you can enhance luminescence from the near Earth. You see, I told you that time of the pure European bauxite or electron ion are highly quenching, luminescent quenching. So this because consider quenching effect. This you see here European bauxite, this absorption band or you can say excitation spectra. You see this band you see in the arbitrary in EBC 20 around 20. Okay. But when it's European 1% to 2% dropping in SN2, you can get the enhanced this absorption across section, okay, around 100. Okay. So this is the what happened is if you drop in the system, you can enhance absorption cross section. This is called section quenching if we reduce. This is one of the why we are dropping this amount. Okay. So we have prepared many compound in our lab, and I give you an example. Wow, GGBF4 that doping, dispersion doping. Okay. You see this absorption band or excitation band, you can see 100 oxygen transfer band around 310, and the gadolinium nitride is gadolinium emission occurs at 270, absorption occurs 270. The dispersion absorption occurs in the very weak. Okay, so this you see expansion, you see around 354 dispersion absorption occurs. Okay, now I by this excitation, if I use different excitation from the gadolinium 270 or if I take the 100 oxygen transfer 310 or 354 direct excitation, I got maximum emission from the 310. So meaning that what happened is 4 by 270 and 354. What is meaning that if you absorb light by a hose and the hose you can energy transfer to the dispersion, you can the luminescence enhancement occurs. Okay, this is the one of the that why you have hose using. Okay, so to get the more energy absorption and energy transfer to the real rod. So we have many compounds with PPR, YBF4, GGBF4, okay? You see the dysprosium dop, europium dop, samarium dop, thorium dop, okay? So you can see many light you see here, green and red and the blue something. So now we are making this, fluorescence system we are making for the life science application. And in the case of the thin film, we are making this film we're making, okay? So different you can use for device purpose. So now you know the nanoparticles. Nanoparticles having surface defect, you know. This is a dangling bond. This how to reduce this. So now this, the particle size so small, then surface defect increase. So to reduce this, we are making the silica coating. Okay. So silica coating, luminescence can be enhancement. We saw in this emission spectra. Okay. This is the published genometric chemistry. And now you know there's one of the quantum dot. Quantum dot is one of the challenging PPR quantum dot because most of semiconductor you want to get a quantum dot, the particle size should be less than of the exciton voltages. So to get this actually, particle suppose SNO2 is semiconductor. I want to prepare the semiconductor the quantum dot SNO2. It's really difficult to prepare. Why? The exciton voltages is around 4 nanometer. So it is difficult to prepare particle size less than 4 nanometer in the SNO2. So but only thing that how to make quantum dot SNO2 around 5-6 nanometer particle size SNO2. This actually, if you put the SNO2 in the silica matrix, silica having dielectric medium atom, so you can prepare another even particle size of 4-5 nanometer more than the size voltages. You can prepare quantum dot SNO2. So exciton formation you can see here, and when they heated, this paper sample is around here less than 200 or 300. If you heated, exciton voltages increases. This quantum dot size is increasing. You can get the exciton voltages also shifting to the longer wavelength. This is the one of the experiment I want to say. You want to make quantum dot, particle size will be less than exciton voltages, but you want to bring in quantum dot in the same size. Then you have to disperse, or you have to make chain with another dielectric medium. So for other quantum dot, I want to tell you one of the quantum dot PBSC quantum dot. You know that we prepare quantum dot by hot injection method. So we have people, why this PBSC? PBSC why very interesting because they absorb light of the UVC, BZ1 near infrared, okay? And this PBSC quantum dot, they had the voltages around 15 nanometer. So that particle size less than 15 nanometer, it may become a quantum dot, okay? This is one of the wonderful, this one, okay? So exciton voltage, we prepare this compound at 100 degrees silicate, PB and styrian interact, okay? And 100 degrees silicate, this is hot injection method. And 30 seconds, 2 minutes, 15 minutes, 60 minutes, that solution will remove, and we do the emission we check. Okay, so we see the emissions is shifting the peak in the longer wavelength with the increase of particle size. Now, how to see quantum dot is how to define quantum dot. You get the absorption spectra. Okay, absorption spectra. You see here, blue is the absorption spectra of PBSC quantum dot. You see the lowest energy variance band to conduction band at E0 is around occurred 1450, but you see the mini discrete energy level is there, mini discrete energy level, okay? So quantum dot, you want to define that quantum dot should have this discrete energy level, okay? Then it is called quantum dot, okay? Otherwise it not happen, okay? And but emission occurs, see that emission occur around 1500 something. So it means this is actually what happened is quantum dot shows emission only one peak, but absorption we have mini discrete energy level. This is how we can define the quantum dot or not, okay? So now different shape of size, we star shape, you prepared, and then the nanorod prepared, and then many aspect ratio of the nanorod we are preparing, okay? And also we are preparing quantum dot spherical particle, 3 particle size, 5 particle size, 7 particle size, nanometer particle. Monocysts is plus minus 1 nanometer difference between the particles, okay? So how see this actually now my previous speaker, Professor Pandey has speaking about the light harvesting in the near infrared. He used the ruthenium based complex, you know. But here I am using quantum dot, okay? The quantum dot you see here or solar spectrum you see 250 to 2500 nanometer. This wavelength you see the highest absorption around 500 solar energy. But you remember we energy loss less UV region around 3 to 5 energy loss. But you know the near infrared we lost 55. So this near infrared energy lost so much energy. So to conserve this energy or harvesting something, we see we are using quantum dot. Different sizes we have put together, and we can harvest this. Let's see that we can prove how to prove this energy. We do the photoconductivity. What's the photoconductivity? Light absorb light, then we produce current. This is called photoconductivity. Okay, by using light and produce current. So you see here. This PBSC quantum dot, we put some polymer, MESPBP. We see here this polymer in the cases of dark and the light, it doesn't absorb it doesn't produce current, okay? But in the dark condition, in the blue you see here, the current is produced, okay? But in the presence of light, in the visible light, we see that again more current. So what is meaning? That PBC absorb near light in the dark condition. There's a photocurrent occurs. This is we prove in this. Okay. Now, so one of the important in the light harvesting is the improvement in the blue light or white light emission. Because if you produce white light, blue, you can get a white light. Or if you're having white light more intensity, you can get a many odd colors like blue, green, red, anything you can get. Okay. So you see here, we do the YPF for 2% dice% doping. We can get a SP plus sample blue light, but when the 509 heated sample, we get a white emission. So this is one of the return doping, improve the luminance intensity. And now see is another was that see in the case of the calcium fluoride, calcium fluoride is actually this is the cubic structure, and calcium is surrounded by I-fluorine. Okay, but it have the calcium is having the this inversion symmetry. So europium is europium doping in calcium fluoride. So whether europium is going to the calcium side or not, something or surface going. So how to prove this actually? This is the one of the paper we published we published in organic chemistry. How we prove this actually? Sorry, the GPC we published. How we prove this actually? Now what happened is we do the europium doping in the calcium fluoride. Okay, but this luminance enhanced by the manganese doping. But how to prove? This is a calcium site occupying a lot europium. Okay, so now we excite europium oxide transfer 240 excited. We get magnetic dipole and electric dipole. Okay, magnetic dipole occurs around 590. Electric dipole occurs 615. But if we 240 excitation, electric dipole is more. Okay, and but if we excited 394 excitation, direct excitation europium, we getting opposite. Okay, what is meaning? But if you see this electric dipole more means the europium not occupying to the calcium site. But you see the directly excited 394, we find that the europium is occupying the calcium site. So you want to prove that actually that you want to prove in the symmetric nature of the compound in the symmetric nature of the ions, you have to direct excitation is necessary. So europium cases 394 excitation is important. Okay, and just question 354. So like that they have to excite their direct excitation. Another was the decay fitting. Many people has fitting in the luminescence. What you see one is question one, monoexponential fitting, and the second one is bi-exponential fitting. One is the diffusion coefficient we have put here. So many people put fitting by monoexponential, bi-exponential. Even some kinds of energy transfer occurs in the system. So this long, if you want to direct excitation, no problem. You can use the mono on a bi-exponential. But if you having some kinds of energy transfer occurs, so this diffusion mechanism energy transfer process, G term has to come. This we published in the report in our data transfer as a photonic inorganic chemistry. This report you can see more details. Now, the luminescence, Lanthanum Bernadette, what happens is many people say, that what happens luminescence enhancement in case of tetrahedral phase, a computer monochrome phase or hexagonal phase. So why they say all the time in the paper, many people written that tetrahedral phase is more luminescence monochrome or hexagonal phase. But we found opposite happens. Here you will see here this is happen. You see the left right is a monochrome phase more, but compared to the tetrahedral phase in the compound. Okay, but we found monochrome phase more luminescence than tetrahedral phase. So why this happened? This actually this is nothing to do in this this one. This is actually nothing but in the case of the monochrome phase, if you having some sensitizer like bismuth, I put a bismuth doping system. Bismuth absorb in the UV light around 280 280 absorption. Then you get more luminescence. It's nothing to do in the tetragonal monochrome phase. Okay. So the what bring it into this inorganic chemistry paper published that it doesn't necessarily that is the system or not. It depends upon how sensitizer doping. Okay. So another was this is another found that the energy transfer for sensitizer to the activator. What is sensitizer? Absorb light. Activator means produce the emission. Okay. So like cerium say is absorb light, produce the emission from terbium. Okay. Terbium shows a green emission, but cerium absorb light in the UV light. Okay. See cerium absorb in the UC around the 300 around something. Okay. 280 something. Okay. Absorption. Okay. 280. But why do you put in terbium? You see this. You can see this here. This one. We are putting terbium peaks, but when cerium amount increases, this the luminance enhancement occurs. Okay, because energy transfer increases. Okay, but I put a cerium peaks. Okay, but terbium amount increases. I found a cerium emission decreasing, but this decreasing means energy transfer is increasing. Okay, so this is the one of that serum to turbine emission or turbine energy transfer occurs. This is published as a photonic. Using this concept, we another denser force we pick up serum and turbine system. What happened in this system? I put a potassium permanganate. Okay, the luminescence again disappear. What if this disappear compound? If we put a metal, we put again in ascorbic acid, luminescence again recover. So this is what happened. Is actually one issue. The cerium. See this cerium, the cerium 3+ is actually 4F1. This 4F1 actually when they're putting the potassium permanganate oxidize, okay, at the cerium 4+. So cerium now no longer 4F electron, okay. But when I put the cerium 4+, is that you put ascorbic acid, reducing agent, and then cerium 3+ again come back. So this one express that cerium when the cerium 3+ that cerium absorb 4F2 5D transition, then energy transfer to turbine, you can get emission, turbine emission. But cerium 4+ that you excite to 73, whatever thing, cerium doesn't absorb anything, okay? Because it doesn't have the energy, Gaussian energy, okay? So no energy transfer to turbine. So this CC. This type of this you can do that. This cyclic means on off you can do it 4-5 times, okay, without any losing the emission intensity. Without this idea that cerium doping, luminescence enhancement in the system, but whether it happen in other system, we take the YP4 system. What happens in the system? The cerium and bismuth doping. You see here, luminescence instead of luminescence increase, the luminescence almost disappear. Okay. And this why this happens, I want to explain you. But when heated in a 900 degrees centigrade, luminescence again recover. So what happened is actually this YP4 European system. Actually, this is without cerium doping and bismuth doping, the tetrahedron phase. Okay. We get the luminescence here. You see here red. Okay. But when cerium is ionic size and bismuth ionic size is bigger than Y, that happens because of this the tetrahedron phase and the hexagon phase. Okay. Because of this and the hexagon phase changes, the hexagon phase is stable only in case stable only when water content. Okay. So water is actually absorbing. Okay. When the cerium and bismuth doping. Okay. Instead of increasing luminescence, the luminescence decreasing. So this is actually then how to prove this actually. We do prepare compound. What is D2O medium? Deuterium water medium. So D2O medium where luminescence is enhanced. Okay, because of the D2O having the they have the this phonon vibration very weak. So compared to water. So this is the luminescence. This we published Jack's paper 2010-11 without any review. This paper, okay, this published, okay. Now this actually how this I want to extend more. See, this is you see hexagonal phase, and this water is sitting in the pore. And you see, this in the nanoparticle you are preparing some system. Is a pore in the hexagonal phase water is there, but in surface water you cannot avoid this because you are preparing nanoparticle is normal ambient pressure or then water absorbing in surface. Okay, so keep in mind in ambient pressure or water medium, water is one molecule. Water is surrounded by 4 water molecules. Okay, this water molecules happen, but in the pore, water doesn't have a proper hydrogen bonding. Okay, in the surface. Water can have 4 hydrogen bonding, but in the pore, water doesn't have hydrogen bonding. Maybe 1 or 2 hydrogen bonding only. Okay. So how to prove this? I will prove you. You see this on decrease of freezing temperature of water even down to 215 K by NMR. So it's NMR. So how to prove this? Actually, you will see the room temperature NMR we have that. Okay, and surface water around 4 to 5, we get ppm level. Okay, but when the temperature decreasing, the different decreasing, we see this peak, another extra peak will coming, okay? And this peak is actually pore water, okay? And this particular, this actually we are using spinning otherwise, the magnetic dipole interaction, this we don't see peak. But if it doesn't use spinning, this pore water is actually freezing. Okay, sorry, for surface water freezing, pore water is not freezing, okay? This is the proof. But we cannot do more than down to 15K, minus 50K we cannot do because NMR tube cannot work. And this we prove by the theoretical experiment and by the neutron refraction we prove that this the white pore having the trigonal pore and hexagonal pore, okay? We prove by the this neutron refraction, okay? And this theory and experimentally. So that I will not spend too much, but I told you how prove by again experimental how prove the trigonal and the hexagonal. You see here water molecule, this white paper hexagonal phase. Here water is here, one water is a hexagonal and one water in the trigonal. Okay, here. trigonal, okay? You see here proof, in YPO, this hexagonal phase, we hit it, surface water is removed up to 200, above 200 degrees centigrade. But again, the trigonal and hexagonal water is coming out, okay? This is the one of the beautiful that we probe NMR, so NMR, as well as the TG analysis, and also neutron refractory probe. And this original work from BRC, Mumbai. I want to explain you finding of water molecule in the pore of they are phosphate by TG mass spectroscopy, and also distinguish the water molecule in the pore and surface water particle by the source NMR, and also stability water molecule up to 90 degrees centigrade. Or what I?
Yeah, time is short. So can you condense?
Yeah, but excuse me. Actually, this the previous our speaker is occupying my space. You know.
Okay.
So I give you again 5-10 minutes, okay? Because already I started 12:40, 45 I started, okay?
I understand, sir. Just request you to condense it.
So 5-10 minutes I do, okay? Yeah. Okay. Thank you, sir. You have seen this slide? Okay. Okay. So stability water up to 100 degrees centigrade. Decrease of freezing temperature of water down to -50 degrees centigrade. Finding of water molecule in the pore, trigonal, and hexagonal phase, they are phosphate by neutron refractory. This is the origin of the work from BRC. So upconversion of particle, you know, I told you the luminance, what is we have published in a suspect nanometer in the 2019. This one we published this sodium fluoride Arabian YP drop system. You see here, right? You see green emission. If I excite 980, okay, get your green emission. Okay, you see 980, so you cannot see by eye, but you can see in the visible light. Okay, what is meaning? The sodium fluoride YP irridium, that actually in the absence of 980 laser, you cannot see this luminescence. Okay, but when 980 laser excitation, we can green emission. Okay. So this explanation I will give mechanism. This actually outcomes actually that this absorb light 980 and energy transfer. Okay, sequential energy transfer. Okay, then you can see green emission. Okay, and also that emission also shows, but I don't see here. Here, one interesting was here. What is this upconversion particle? Okay, this green emission. But our particle surface plasma absorption, okay, surface plasma absorption occurs around similar to 530, 540. This green light of this the upconversion particle, okay, absorbed by the outer particle, which produce light, produce a heat, you know, they produce around 40 to 40 degrees centigrade. This one photothermic heating, okay. So this light heating again in the cancer cell. This is one of the photothermic heating you can do. And this, so I will not see temperature sensor. I will not speak because of time limited. Similarly, we now recently we published outcomes in particles, super bright red conversion. You know, this is the one that published in the recently. You see the red emission, you know, without any green, any light. You know, this is one of the interesting that you can see that because this is very important that 980 laser excitation, you can penetrate depth of the body can be more, so you can get the red emission. Also, this biological window. Okay. Also, YPO for European Arabian, we also published recently 2021. So I will explain this today, and so that I want to tell you that you can you can use a temperature sensing something, but I will explain this time. And now this the upconversion nerve particle, you know, not only the mini nerve particle preparing this, this for security. Sometimes light is not in the dark condition. How to see light, you know? So we have prepared many things for the blind people. How to use this, 100 rupees, 200 rupees. How to check something. We have carried out in our using our nanoparticles. Okay, and so you see many things. You see ABC. You can light in the absence of 980 laser. You can see normal light is visible. You can see light. Okay. So 1901 Nobel Prize. This one. Nobel something. So it can be written by using nanoparticle. Okay. But in the absence of 980 laser, you can see this. Okay. So this is invisible in the visible light. Okay. Biological application. I just give you an example and give you example that we are preparing persistent luminance. What is persistent luminance? You light excite, or either the UV light, okay, light excitation, UV light, or any kinds of the, gamma ray or something, okay. So then this absorb light and can emitted produce few hours, okay. So this EV can be used in the case of the imaging purpose, okay. This you see what imaging happen you see here. One of the that we mice, this mice particle is using the mice. And what happened is before that, UV light excite this nanoparticle, persistent luminescence, they inject the tank, and this nanoparticle goes searching for the tumor region, okay? So 2 more region, or maybe going to the other part of the, you know, the river, and that is, or maybe going there. So we can tracking this, okay, few hours. How the nerve particle going to this, or the targeting the cancer cell something. So those things, this is just already I taken from the slide from some, this one, but for the internet, but you can find from other my paper also working in this direction. Okay. Now another was the dominant sense nerve particle can be used in imaging. How to internalize? Okay, this YPF4 European and YPF4 this one, this system epitropol, we are using international. Okay, how does cell international? How do? Okay, V160 we have done. So I am not explaining. Time is limited. This we can do international. We can see the particle interact. Okay, so you see the European is a red emitter. You can see how the cell international. Okay. And this attractive treatment, is one of the most common form of the slowly progressive and systematic. This this was inflammatory disorder of the synovial point, which affect 2% and 4%. This will be how to solve this problem. Okay, arthritis. Okay, how to. So one of the example we have taken how to many treatment was surgery many times. Okay, now it is coming up. Vitare can be used to eliminate this arthritis. Okay, this was the one of the we have done. You see here epitropal nerve particle, but agglomerate particle. And this agglomerate particle, we are absorbed layer rod. Okay, residual sort of layer rod. This residual sort of what residual sort of Jaria 90, Homium 66, that person. These are residual sort of the produce vitare and few hours. Okay, this vitare then inject to the this way we inject to the this red blister. Okay, we inject to the one of the knee joint. Okay, then you can see emission up to 72 hours. Okay, this means this study happened is there can be vitare emission. Vitare is the nerve particle can do not go in the other part of the body. I can see that treatment can be arthritis. Okay, this will be published Journal of Material Chemistry B. This purpose. Okay. For conclusion, and the use of the radar dot in different areas are mentioned briefly. Display and right harvesting, and identification of inversion symmetry, all of switching, and stability of the water up to 100 degrees centigrade, decrease of freezing temperature down to 215 K, temperature sensor, security in, and cancer therapy, and imaging through the optical and neuronuclei, and arthritis treatment using the beta ray. So acknowledgement, I thank Dr. Eketiagi, our chemistry division head, as well as his associate director now, and Dr. P. Hassan, my section head, and also I thank Rasmi Joshi and BP Singh. Other many students and collaborators, they have contributed a lot in this today. Without their for their contribution, I am going to give talk in today in front of you. Thank you for your listening my talk. I am waiting for your questions.
Thank you, sir.
Yeah.
Now I request Dr. Ansari to thank you, Dr. Nimpojan, our education. How effectively and simple manner you have explained your topics to our students, online and offline. Once more, I thank again for one thing. What your lecture is all like to our students online and offline. See how from northeast state, from Manipur, you have there and work hard to reach to IIT Kanpur, and from IIT Kanpur to our Atomic Research Center. For our students, it is the milestone. Get the encouragement. Nothing is impossible. Napoleon has told that impossible is that word which is found in the dictionary of fools. You can make it possible. Just you have to have the guts. Himmat honi chahiye. So you have done it, and it is milestone of our students of our land. They can do better also, and they get inspiration from you. Thank you, Dr. Nimpojan. Thanks again.
Thank you. Yeah. Thank you. Yeah. Thank you.
Thank you, sir. Now we move on to the next.
Thank you, Raghuman. Thank you.
Thank you, sir. Dr. Simon, thank you. Yeah, for your nice introduction. Yeah. Thank you. Yeah. Okay.
So
Okay.
now we will move for the next session.
Okay.
Oral presentation session and
Yeah.
poster presentation session.
Okay. Thank you. Yeah.
Who want to present poster go outside with their respective posters, and participants who are connected for poster session, we will call their name one by one, and we will assign. We have assigned 3 minutes presentation time for each. Dr. Amul Saraswat.
Yes, I am audible?
Yes.
Okay. Okay, thank you very much. Welcome. First of all, I acknowledge Honorable VC Sir, Pro VC Ma'am, and our HOD Sir for providing me this opportunity for presenting my oral presentation. So I am now sharing my slide.
Share your slides.
Is it visible? Hello? Is it visible?
Go ahead. Yes, go ahead.
Okay. First of all, I am introducing myself. I am Dr. Apur Saraswat, working as an assistant professor in the Department of Chemistry in RV College, Damsing Sarai. So my topic of presentation is effect of doping agent on electrochemical performance of industry conducting polymers of aniline. So before we come to the introduction and what are the effects of doping agent on the electrochemical performance, we will study how these electrochemical properties may be affected by doping the some other type of doping agent we have used like perfluoric acid. So before introducing, I am using my topic, starting my topic on the topic, the application of electrochemical properties. So why we have used this electrochemical performance on the polymerization and why we have performing this doping agent. So due to the changing economic climate condition and need to pursue greener chemical route, electrochemical technology represent a frontier of opportunity. Secondly, electrochemical process is one of the cleanest technology according to the path. So the electrochemistry may be considered as the one of the prototypical green technology for the future. So actually what we are doing is that we are synthesizing a polymer, and this polymer is prepared by the modern technology, which is this electrochemical method. And why we have choose, because some of the basic reason, as in electrochemistry, the prototypical green technology, the main elements that are involved is that bring about the cleaner reaction profile is that the electrons are involved as an intrinsically clean agent. That is, the electron can be removed or added during the course of reagent. Simultaneously, we have employed the various use of green solvent. The reagents are stoichiometry electrogenerated. They may be carried out room temperature. Real-time monitoring may be possible during the electrolysis, and the high yield of atomic condition are also being obtained through this electrochemical method. So, why we have taken this conducting polymer? Because as we see that the polymer which we are incorporating the nitrogen molecule in the molecule. Whenever any heteroatom is introduced in any conducting polymer, it brings about the chemical flexibility. Secondly, this polymer have receive great intention due to the environmental stability, easily prepared, exciting electrical and optical properties. These also have a very application in biochemical sensors, rechargeable batteries, and in protective coating. So, however, the common usage of this material are generally restricted because of due to the extended conjugated double bond. So, to improve this possibility, we have carried out the electropolymerization of aniline with different substituted aniline using cyclic voltammeter. So how this is performed? So we will take some basic instruments like electrolytic cells are taken, electrolytic medium are taken, electrodes and reagent. In the figure we are using this. This is basically what? This is a cyclic voltammetry. in which the rapid voltage scan technique is applied by reversing the direction of voltage scan, which will be utilized in the synthesis of copolymer. The electrolytic cell which is employed there comprises of three electrode cell, mainly the working electrode, counter electrode, and the saturated calomel electrode. So how the experiment goes on? If you look out at this figure, we have taken the two equimolar ratio of hello. Yes. Okay. If you look at this equation, we have taken the equimolar ratio of aniline and the substituted aniline. Here we have taken on the substituted aniline, we have taken the NaCd. And in the electrochemical cell, in 1 cell, using acetonitrile as its organic solvent, lithium perchlorate as the supporting electrolyte, and perchloric acid as a proton donor. In this oral presentation, I am focusing how this perchloric acid, when they added in the solution, they affect the electrochemical performance. So for this electrolysis is just what they are controlled potential electrolysis. That means that the potential are controlled during the course of reaction. So how this goes on this? When we perform this experiment in the electrochemical cell, we obtained a graph which is a cyclic voltammetric cell, in which if we look at this graph, we get two electron transfer oxidation reduction mechanism, and we get two peaks, two oxidative peaks. If we look at this, yes. Okay, I am concluding. So if we look at this two oxidative peaks, we are getting two oxidative peaks followed by two reductive peaks. So if we look at this mechanism, generally this is what an oxidative coupling mechanism is reaction, in which the first peak corresponds to the formation of radical cation, and the second oxidation peak combines to the coupling of radical cation to form the chain polymer of copolymer of aniline with NaCd. So what are the effects we have noticed during this synthesis is that, so when the doping agent is used, doping means what? An external impurity material that are added to the material to enhance their materialistic properties. So what are the properties they are noticed? So when we use the perchloric acid, so if we focus, what is perchloric acid? Perchloric acid is the strongest acid. So when since they rapidly ionize in the acetonitrile and drive the polymer to release more and more electrons to the cathode. So what happens? Our oxidative potential gets decreased and our electrolytic is enhanced. Secondly, during this reaction, we have taken the NaCd, which has a mesomeric effect, which also makes the reaction very fast. Third reason, when we use perchloric acid, so this chlorate ion incorporated within the molecule may enhance the solubility. And fourthly, when we have carried out the scanning electron microscope of this copolymer, if you look at this cell of the image, you see that two types of pores have been created, having diameter of 20.57 nanometer and 402 nanometer. But still, the formation of pores in copolymer, the reason behind is still under investigation. So on concluding this my part, we have highlighted the effect of perchloric acid employed as a doping agent during cyclic voltammetry. Secondly, during doping, the implication of electroactivity, reaction rate, and the enhanced solubility was noticed. Since the reaction was carried out using electron as a sole reagent, so the greener reaction profile is noticed. So we have eliminated the toxic chemical, and the reaction is environmentally benign. And thirdly, since this whole reaction is carried out by the electrochemical tools, so this is useful to those who are not a trained electrochemist, but they can unleash this galvanic potential in the synthesis and the transformation of organic compound. This my work has been published in the synthetic matter in Elsewhere, having impact factor 3.266. Thank you very much.
Thank you, Dr. Apur Salsar. Dr. Apur Salsar is Assistant Professor in RT College, Samastipur. He is a very good teacher. Now next, Anamika Kailawat, Lovely Professional University, Punjab. Anamika?
Yes, sir.
Amika, sorry,
Amika, sir. Amika. Good noon, all of you. I'm here to present my topic, nanotechnology, an emerging field for future energy generation, and overview. I will discuss about the introduction of nanotechnology, what is the nanotechnology, and what are the nanoscale materials and approaches in building small objects like top-up and bottom-up approach. The applications of nanomaterials we will discuss, also the hydrogen energy with the help of nanomaterials and the production of hydrogen energy and its storage and the possibilities for future. Nanotechnology helps a lot in future in nanorobotics. So let's start about the nanotechnology. Nanotechnology, we can control the shape, size, and materials at nanoscale with the help of nanotechnology. It is the design, production, and application of materials and devices and systems at nanoscale. Nanoscience is the understanding of matter at the nanoscale, at nanometer scale, like 1 nanometer is equal to 10 raised to power minus 9. Nanotechnology is a creative and transformational technology on our needs. Nanoscale materials contain nanoparticles, and by using nanotechnology we can synthesize very small diameter particles, that is having less than 100 nanometer dimensions, and thin films can also be synthesized at, by the help of nanotechnology. Nanoscale materials have nanoparticles. These nanoparticles have at least thin dimensions, even less than 10 nanometer. They have tiny size, lightweight, incredible surface area per unit mass, and are very strong. There are several approaches to create nanomaterials, like top-down approach and bottom-up approach. In top-down approach, we synthesize nanomaterials by bulk materials, and in bottom-up approach, we make use of precursors containing molecules and then ionization, formation of ions, radicals, electrons, etc., forming a clusters. Nanoparticles can be synthesized, and there are various applications of nanomaterials in energy generation, in conversion of energy, like in photoelectrochemical splitting of water. We can synthesize the perovskite nanomaterials, which helps in hydrogen generation by splitting of water. 1D, 2D, 3D nanomaterials can be synthesized. These are also helpful in superconductivity, insulating materials for energy transmission, in energy saving devices like smart windows, nano refrigerators, in batteries for energy storage. Supercapacitors are also made up of nanomaterials. Overall, we can say that nanomaterials have wide applications in energy conversion, generation, storage, transmission, and saving. Particularly, at present, hydrogen energy is of great concern because at present we are mainly dependent on fossil fuels for energy consumption. But there is a problem with fossil fuels that they cause pollution and are also depleting day by day. So, hydrogen energy is a renewable source of energy, which is the primary form of stored energy for mobile applications and load balancing, etc. Promising form of energy storage and efficient processes. Yes, sir?
Please conclude. Please conclude. We have
Okay, sir.
15 minutes.
Then storage of hydrogen energy can be easy with the help of nanomaterials, and there are the possibilities for future. Nanotechnology make it possible to manufacture lighter, stronger, and programmable materials that requires less energy to produce conventional materials. And in conclusion, at last, we can say that nanotechnology is of great concern in production of lightweight particles, which are helpful in hydrogen production and energy storage. Thank you. Here are the references.
Now, Dr. Anita Sharma.
Thank you, sir.
After you can start the presentation.
Yeah, sure.
Time allotted is 3 minutes.
Okay, sir. I think I am visible now.
Yeah,
Your slide is visible.
Yeah, sure. Thank you, sir. And as you know, today I am going to deliver my talk entitled Photocatalytic Disassembly of Tertiary Amine-Based Dendrimers to Monomer and its application to catch and release of a dye in aqueous solution. As we are knowing that dendrimers are highly branched molecule having a spherical structure, and these are the unimoleculars. And dendrimers are generally unimolecular, means consisting of one or involving single molecule, and these are the macromolecules. It have the core in the and several and branching points, and on the periphery it have different functional groups like hydroxyl, like amines, functional groups. It have assisted with a variety of applications like encapsulation, light harvesting, supramolecular chemistry, cross-linking, host gas interaction, biomedical, and chemosensor. In this work, we will be focusing only on the encapsulation studies, how these dendritic molecules are helpful for the encapsulation of small molecules. These are the structure of some dendrimers which I have been synthesized. This is known as polypropyl ether tertiary amine dendrimers. This is the first generation having 4 functional groups, second generation dendrimer having 8 functional group, then 16, and then so on. This is known as first generation, second, third, fourth, fifth generation, starting from the water. And after the synthesis of these dendrimers, our aim is to the cleavage of these dendrimer, because we want to focus our study for the encapsulation study. Therefore, since tertiary amines are having very low ionization potential, therefore they can easily react with a sensitizer, means we have chosen 9,10 anthraquinone as a sensitizer in acetonitrile, and undergo photolysis to these 3 products, means we have been observed CO and CN cleavages, and this study has been concluded by using the NMR spectroscopy. We can easily see that as the time passes, this peaks disappears, and we focus at this C point, and we see that around after 8 hours the complete dissociation takes place. Now we have chosen two sensitizer. First is a 9,10 anthraquinone. After that we have chosen another sensitizer, riboflavin tetraestate, which is a vitamin B2 analog. And the reason for selection of this is the electrode potential of these 2 sensitizer are nearly equivalent. After this successful full cleavage, we focused on the encapsulation study. Encapsulation study, we have taken this dendrimer and a small molecule like Sudan first molecule we have been encapsulated, and it will undergo photochemical cleavage to give back our encapsulated molecule. Before starting this study, we have to check whether this Sudan is stable under experimental condition or not, and we have recorded the spectra, absorbance spectra, and we can see that it's stable. Then we have checked where the combination of Sudan and this sensitizer is stable, and it's stable. After that, we have encapsulated this small molecule into the dendritic molecule, and we saw the significant enhancement in the solubility of Sudan. Then we have cleaved this molecule and recovered. It has been observed that the solubility increases around 90 times in first generation, around 200 times in the second generation, and the around 275 times in the third generation dendrimers. And we have also recovered this dendrimer, and around 70% of recovery has been obtained. Therefore, in conclusion, we can say that aliphatic tertiary amine-based dendrimers undergo photolytic cleavage by using a sensitizer like anthraquinone or riboflavin tetraacetate, and we have used this methodology for the catch and release process of a small molecule like Sudan. Thank you, sir.
Thank you, Anindra. Dr. Anija Philip. Dr. Anija Philip.
Yes, sir. Hello. Am I audible to all of you?
Yes, yes, you are audible.
Yes, thank you. I'm going to
You
start
are
sharing
3
my
minutes,
screen.
Aditya, 3 minutes.
Can you all see my screen properly?
Yes, yes.
Yes, thank you. Okay. So I'm Dr. Anuja Philip. I'm an assistant professor with Department of Chemistry, Hislop College, Nagpur. Today, I would like to share with you a piece of my work, doctoral work that I did with Dr. Ramesh Ramapanikar in Department of Chemistry, IIT Kanpur. That is asymmetric synthesis of ferricinyl amino acid. As we chemists, we have all heard about ferricin, at least one. So what is the speciality of ferricin? Ferricin is a very special molecule which seems like defies even the rules of chemistry. It is a sandwich molecule which has its ferrous ion sandwiched in between two cyclopentadienide ions. Okay, so it has very special properties like it is soluble in almost all organic solvents, but it is insoluble in water. It is stable even at 400 degrees Celsius and at room temperature. So ferricin also shows several applications in industries like petroleum industry, plastic industry, textile industry, and metallurgy. It also shows certain biochemical properties like it is cytotoxic, it also is anti-anemic, it is anti-tumor and anti-malarial properties. So in order for us to explore all these biological properties, we should be able to solubilize it in water or make it compatible with the physiological conditions. So the best way to do it is to conjugate it to a biomolecules. How do you do that? You can either attach it to the C terminal or the N terminal of a peptide, or you would have to make a amino acid from ferricin. That's what I have done. So what I have done is I have taken a ferricin carbaldehyde, which is commercially available syndrome, treated with propane dithiol with iodine as a catalyst to form ferricin diethane, which is then treated with this iodide electrophile obtained from glutamic acid or aspartic acid in the presence of butyl lithium at minus 40 degrees Celsius to form the coupled product. This coupled product can now be either oxidized back into the oxo product or completely reduced back into the alkyl product. Once you have this, the protection of this corresponding functional groups of the acid group and the amino group would give you a free amino acid. One more thing that I would like to take your attention to here is that you can see here that the stereo center that is here is remains intact. It remains unaffected. Okay, so you can actually make stereo sender having an amino acid that is having a correct stereo sender that you require. So we also try to explore its stability in the liquid phase peptide synthesis, where we have coupled on the C terminal side the dipeptide alanine phenylalanine was coupled onto the C terminus by using standard peptide coupling conditions. We also try to couple it to the N terminal by using alanine phenylalanine dipeptide under standard conditions and found that in both conditions the peptides are stable, or the amino acid, the ferricinyl amino acid that we have synthesized as stable. I must say that the yields are moderate and the reaction conditions should be extremely dry. So I would like to conclude that we have explored the properties of ferricinyl diethane in synthesis of C-linked ferricinyl amino acid. We have also proved that this can be explored in liquid phase peptide synthesis. Thank you. I would like to thank all the organizers for this opportunity and also for IIT Kanpur and Hislop College. Thank you.
Thank you, Anuja. Thank you.
Thank you.
Professor Preeti K. Nagpuri. Professor Preeti Nagpuri. Are you connected, ma'am?
Am I audible, sir?
Yes,
Hello.
yes, ma'am. You are audible and visible. You can
Yes, sir.
continue. 3 minutes, ma'am.
Yes, sir. A warm good afternoon to all the dignitaries present over here. I am Preeti Nagpure, Assistant Professor in Department of Physics, Dhote Science College, Gundia. Today I am going to discuss regarding the study of structural and electrical properties of LaDOB NiCO nanofarads. Just a minute, sir. I am sharing the screen. Is it visible, sir? Hello?
Yes, visible.
Okay. So, what are ferrites? Ferrites are nothing but ferrimagnetic materials and basically insulating semiconducting metal oxides. Magnetite was the first magnetic material known to mankind. Magnetite is also known as lodestone. In the present work, Sol-Gel microwave assisted autocombustion technique has been used for the synthesis of LaDOB NiCO nanospinel ferrite. It is a unique combination of Sol-Gel process and combustion process based on the gelling and subsequent combustion of an aqueous solution, including the salts of desired metals and some organic fuels. This is the schematic of the synthesis of the sample. Here, the nitrates are taken in proper molar ratio with urea as a fuel. It is dissolved in double distilled water to make sol. This sol is cooked on a magnetic hot plate for nearly 4 to 5 hours at 80 degrees Celsius to convert it into dark brown gel. That gel is kept into a specially designed microwave for firing, and the ash of the sample has been collected and it is grounded in fine powder to get the final product. The molecular formula of the compound has been given here and they are labeled as A1, A2, A3, A4, A5 respectively. For structural study, the X-ray diffraction pattern of all the samples of LaDOB NiCO nanoferrite has been done. The XRD is shown here. It has been done by Bucher AX-SD8 advanced X-ray diffractometer with a monochromatic X-ray source. The powdered X-ray diffraction pattern confirms the formation of cubical single-phase spinel structure with space group FD3M. The scanning electron microscopy has been done for morphological study, and this images reveals that the particles are distributed uniformly, and the histogram plot shows that the range of the nanoparticle is from 10 nm to 30 nm. HR10 study shows that the actual particle size is nearly 27 nanometers, which is slightly higher than the slightly higher than the particle size obtained from X-ray diffraction pattern. The electrical conductivity study has been done with the help of impedance analyzer. In this study, the variation of electrical conductivity with temperature has been done to calculate the variation of activation energy. The plot of log of conductivity with inverse of temperature is plotted here. From this graph, we can conclude that the DC electrical conductivity of all the ferrite composition was measured by the two-probe technique in the temperature range 303 to 1200 Kelvin. The room temperature conductivity for all the compounds are found to be in the range which varies between 10 raised to power minus 8 to 10 raised to power minus 7 ohm centimeter inverse. At room temperature, the electrical conductivity decreases with an increase in La3+ concentration. The activation energy has been calculated at two different regions in this graph, one in a paramagnetic region and another is in ferromagnetic region. From the activation energy calculation, we can see here the activation energy for paramagnetic region is greater as compared to the activation energy in ferromagnetic region, which shows that the ferromagnetic region is more ordered as compared to paramagnetic region. So from this work, we can conclude that with the Sol-Gel microwave assisted autocombustion method, LaDOB NiCO ferrites were synthesized successfully. The X-ray diffraction analysis shows that sample exhibits FCC structure. Same analysis shows that the particles are almost regular and homogeneous, regular in shape and homogeneously distributed in the range of 10 to 30 nm. TEM analysis shows that the particle size is 27 nm, which is slightly higher than the crystallite size estimated from XRD. Electrical conductivity increases with the increase in temperature, which shows the semi-conducting nature of the sample. Also, electrical conductivity at room temperature decreases with La3+ concentration. And these samples has been used in microelectronic devices. These are the references. Thank you. Thank you very much. Thank you, sir.
Thank you, Professor Master. Dr. Vipin Chapur.
Yes, Siman, can you hear me, Siman?
Yes.
Okay, thank you. So good afternoon, everyone. Today I'm going to talk about the synthesis of deoxygalactonogeremizine and deoxyaltronogeremizine. So my name is Dr. Shibin. I'm from Department of Chemistry, Hislop College, Nagpur. So you may be thinking what is mean by altronogeremizine or deoxygalactonogeremizine. Before going into the details of the structure of nogeremizine, I want to tell you that sugars can be classified into 4 categories. One is carba sugar, imino sugar or rasa sugar or oxo sugar or thio sugar, where the hetero atom here, it is replaced with carbon. Then if it is called carbon, it is called carba sugar. If it is nitrogen, asa sugar. If it is oxygen, oxo sugar. If it is sulfur, it is thio sugar. So you can see that with nitrogen, with amine, NH, you can see wide varieties of natural products. So this is one of the important compounds, or which is drug which is used for treating type 2 diabetes mellitus. So then the another one, N-butyl deoxynogeremizine, which is used for treating Gaucher disease, which is a lysosomal disorder. So there are many natural products which is also existing. You can see that the stereochemistry of these hydroxy groups varies along the ring actually. So when you count 1, 2, 3, 4, 5, you can see that the stereochemistry, the orientation of the hydroxy groups varies. Okay, so let me tell you how we synthesize this compound. So we have used the proline catalyzed aminoxidation reaction. You may be wondering what is proline catalyzed aminoxidation reaction. So proline catalyzed aminoxidation reaction was used, to introduce the hydroxy group to the alpha position of carbonyl compound. So we can use the aldehyde or ketone and treat with the D-proline as a catalyst, and nitrosobenzene, you can get the hydroxy group incorporated stereoselectively. So enantiomerically, if you are having another stereosym, then you can say diastereoselectivity. But the beauty of this reaction, when you are using L-proline, you will end up having the different stereochemistry. And the aldehyde, you can functionalize later. This aldehyde is not participating in the reaction. So you can later functionalize, you can reduce it, or you can oxidize it, or you can do a Wittig reaction. Okay, so let me take you to the synthesis. So we have used the aldehyde which is commercially available. So took the D-proline and nitrosobenzene, successfully incorporated the hydroxy group, followed by the aldehyde was subjected to the Wittig reaction. You can see that it's an alpha beta unsaturated ester. Okay, so then the diastereoselectivity was 99%. So you can see that. So later what we have done, the hydroxy group was protected, because if you want to convert this double bond into single bond, then this ester and hydroxy group can undergo lactonization. It will form 5-membered ring. To prevent that, we have protected as the OBN, benzylated, followed by Upjohn dihydroxylation reaction. You can see stereoselectively we have incorporated the hydroxy group with a 92% G. Okay, so then later we have done the ester reduction into OMS and converted into the altronogeremizine. Okay, so the same chemistry was used in the L-proline to get the deoxyaltronogeremizine. So with this, I would like to conclude that proline catalyzed aminoxidation reaction was used for the synthesis of altronogeremizine and galactonogeremizine. And I would like to thank Dr. Ramesh Ramapanikar, the Department of Chemistry, where I have done my doctoral studies. Thank you for the organizers for organizing the virtual event, and especially Simant and the head of the department, or all the organizers. So thank you. Thank you once again.
Thank you, Stephen. Thank you.
Thank you.
Dr. Subhangi Nate, Science College, Gondia.
Yes, sir. Hello. Hello.
Yes, you are audible, ma'am.
Okay, sir. Just 1 minute. I am sharing.
You are not visible, you are audible.
Hello, good afternoon, sir. Can I present the presentation, sir?
Hello.
This is
Hello,
Madhu.
I am presenting here. Okay. Hello, everyone. Am I audible now?
Yes, yes, continue.
Okay, sir. Okay, I am continuing. Hello, everyone. This is Dr. Shubhangi Narde from Dhote Bandhu Science College, Gondia. And today's my topic is application of nickel zinc ferrite as photocatalyst. The present study reveals the photodegradation of methyl red dye solution using novel cubic spinel mixed metal ferrite NiXZn1-X Fe2O4 X is equal to 0.4 as photocatalyst. The ferrite was synthesized by Sol-Gel autocombustion method at pH 7 and the characterization was done using XRD, FTIR, SAME and TAME techniques. The photocatalytic study was carried out in the presence of short-wave UV light for the azodimethyl red, and it was observed that for 0.4 gram of ferrite per 10 milligram per liter dye sample at pH 2 for 120-minute contact time, the maximum photocatalytic activity was observed. This is the introduction of my topic. Then synthesis of ferrite. The ferrite samples were synthesized by using Sol-Gel autocombustion method, and here the metal nitrate precursors and citric acid was used for the preparation, and the molar ratio of the metal ion precursors to citric acid was kept at 1:1 and the reaction was carried out at pH 7. The citric acid and nitrate ions act as fuel and source of oxygen respectively. The solution was then stirred continuously and slowly heated on a hot plate magnetic stirrer at 80 degrees Celsius till gel was formed, which was ignited and burnt in a self-propagating combustion manner to obtain loose powder, and it was finally annealed at temperature 800 degrees Celsius for 2 hours in a muffle furnace. And this is the diagram synthesis of ferrite in the laboratory. This is the flow chart of my method. Then XRD study was carried out to show the structure, to prove the structure as single phase cubic spinel ferrite. This is the XRD data, XRD spectrum of my material. Then FTIR study was also supporting the cubic spinel structure of the ferrite. Then SEM study was carried out. Elemental analysis by EDX method was done. Transmission electron microscopic study was carried out, which also supports structure. And then photocatalytic application of this ferrite against the removal of methyl red dye from aqueous solution was carried out. And the effect of pH on the photocatalytic degradation of the methyl red was studied for the pH ratio to 10. Initial concentration of dye was 10 milligram per liter and catalytic dose was 0.1 gram per 100 ml of dye solution. And it is found that the maximum photocatalytic activity at pH 2. These are the diagrams in this study. The effect of photocatalytic for 0.05 to 0.4 gram per ml of 10 milligram per liter dye solution time, and it is found the removal of the dye increases from 23% to 97.22% with increasing catalytic doses from 0.05 gram to 0.4 gram. Then the effect of initial dye concentration was also studied for 10 milligram to 50 milligram per liter, and it is found that the dye removal was found to decrease from 97.22 to 42.12% for 10 milligram per liter to 50 milligram per liter. Then the conclusion that zinc substituted nickel ferrite with compositional formula Ni0.4 Zn 0.6 Fe2O4 was synthesized successfully using Sol-Gel autocombustion method, and the ferrite nanoparticles were successfully employed for catalytic degradation of methyl red dye under and the maximum photocatalytic activity of spinel ferrite of ferrite for 100 ml dye solution at pH was contact time. These are Thank you, sir.
Dr. Anand Mohan Jha, MIT College, Saharsa.
Yes, I am audible, sir. Yeah, myself, Dr. Anand Mohan Jha, Department of Chemistry, MLT College, Saharsa. My screen is visible, sir. I am audible, sir.
Yes, you are audible. Go ahead.
Yes. Now I start my topic. Methyl-proline complex catalyze Michael reaction of mercaptans to chalcone in aqueous medium. In present work demonstrates synthesis and antibacterial property of new pyrazole derivatives. In this context, I have prepared a new curcumine-based dihydropyrazole was synthesized and objective to evaluate their antibacterial properties. After that, I have completed the next synthesized the pyrazole analog and 1H NMR, 13C NMR mass spectroscopy and IR techniques were characterized using this pyrazole analogs. And after that, they were screened for their inhibitory activity against 4 different bacterial strains. Curcumine, a boon from the nature for mankind. Turmeric is a flowering plant named Curcuma longa of the ginger family, Gingiberacea. Turmeric has been used in Asia for centuries and is a major part of Ayurveda, Siddha medicine, traditional Chinese medicine, Unani, etc. Importance of turmeric from various perspectives. In turmeric powder, we see that 60 to 70% carbohydrate is there, 6 to 13% water, 6 to 8% protein, 5 to 10% fat, 3 to 7% dietary minerals, 3 to 7% essential oils, 2 to 7% dietary fiber, and 1 to 6% curcuminoids. It is color in yellow, color of turmeric due to curcumine. It also contains an orange colored volatile oil. This is the keto and enol form of tautomeric form of curcumine. We see here that color of curcumine in acidic and alkaline solution. We see that yellow color is acidic solution and alkaline solution. There are both types of solution. Here we have designed the hybrid curcumine molecule. We see that designing of this synthesized molecule. This is turmeric and this is the curcumine. And after that, we have in laboratory, we have synthesized the molecule. We have see that this is the scheme of dihydropyrazole analog. Next, we have different types of molecule here. We have seen dihydropyrazole library. This is the data. We have collected analytical data for the compound. NMR, we have done a mass spectroscopy. We have done UV, everything we have done in different forms. This is the pharmacological analysis we have seen here. And after that, antimicrobial assay, MIC50. And in result, we successfully synthesized and characterized a dihydropyrazole library with an objective to evaluate antibacterial activity. Next, we see that antibacterial activity of synthesized pyrazole. And in conclusion, in the summary, we have designed and synthesized curcumine, chalcone, which were further converted to dihydropyrazole. Synthesized pyrazole analog after in vitro screening against 4 different gram-positive. And at last, we acknowledge Honorable Vice Chancellor, Honorable Pro Vice Chancellor, LNMU Darbhanga, University Department of History, LNMU Darbhanga, MLT College Saharsa for providing place to work, IIT Patna and Central University Gujarat. Thanks to everyone. I am so much thankful to all the University Departments of Chemistry, LNMU Darbhanga. Thanks to everyone.
Dr. Sanjeev Kumar Jha, MIT College, Saharsa.
Yes, okay, thank you. Sir, am I audible?
Yes, you are audible.
Yes, sir. Okay, sir. I am presenting my screen, sir. This This is highly accurate protein structure prediction with the AlphaFold. Myself, Dr. Sanjeev Kumar Jha, Department of Chemistry, MLT College, Samsa, Chemistry, Madhepura.
Are you want to share slides?
Yes, sir. Yes.
Not visible. Your PPTs are not visible. Please share.
One minute, sir. I am sharing, sir.
वहाँ से कंट्रोल हो उसमें नहीं होगा।
Please.
Dr. Sanjeev.
Yes, sir. Yes, sir. Sir, it is visible. My screen. It is visible, sir. Yes, sir. Yes. Protein are essential to life, and understanding their structure can facilitate mechanistic understanding of their function. Through an enormous experimental effort, the structure of around 1 lakh unique protein have been determined. And but this represents a small fraction of the billions of the non-protein sequences. Structural coverage is bottlenecked by the month to year of stacking effort required to determine a single protein structure. Accurate computational approach are needed to address this gap and to enable large-scale structural bioinformatics, predicting the 3D structure that a protein will adopt based solely on its amino acid sequence. The structure prediction component of the protein folding problem has been an important open research problem for more than 50 years. Despite recent progress, existing methods fall far short of atomic accuracy, especially when no homologous structure is available. Here we provide the first computational method that can regularly predict the protein structure with homologous structure is available. Here we provide the first computational
Thank
method.
you, Dr. Sanjeev. We have this with us. Thank you.
Okay, sir.
Dr. Madhu Kumar Gupta. Dr. Madhu Kumar Gupta. Dr. Madhu Kumar Gupta.
Yes, sir. I'm here, sir. Present, sir. Am I audible, sir?
Share your slides.
Am I audible, sir? I'm going to present my presentation.
Yes.
Good afternoon, everyone. I am now talking about micronutrient copper and its toxic effect on the growth of mung plant at higher concentration. In this research work, I have just find out what is the effect of excess copper concentration. Sorry, is there any problem, sir? Do I continue, sir?
Let's continue.
Okay. I continue, sir.
Yes, continue. Go ahead.
Copper is an essential micronutrient for plants. Key role in photosynthesis and respiratory electron transport system. Copper concentration is very essential in order to have various metabolism in plants as well as in animals also. But right now I'm talking about for the plants. It is essential for the photosynthesis process, for the enzyme purpose, and also for the ethylene sensing system in order to ripen the fruits. Similarly, cell wall metabolism and other oxidative stress protection is also requiring the copper in their activity. Lack of this element causes various type of malfunctioning in the metabolism of plants. Besides this, if there is a larger concentration of this copper in soil, this will result in adverse effect on the growth of different plants. In this experimental work, I have used cupric chloride dihydrate as a chief constituent in order to find out the effect of copper. Further, we have the methodology is based on the seed was soaked in water first and then it was transferred to different concentration of copper. First we have washed it with water and then with different disinfectant, and further we have soaked in the respective solution of the copper compound with different concentration. After soaking it for 4 hours, we have transferred it to get germinate in dark for 24 hours on cotton beds containing the required concentration of the copper salt. Further, we have tested its growth. Sir, 1 minute, sir. I will conclude, sir. For different, we have tested for after 48 hours and then for 24 hours. That means 72 hours, and we find out that after 48 hours, the growth will get reduced to 50%, that means 48.5%, and after 72 hours 68.8% when we compared it with the control and concentration of the CuCl2 2H2O with 500 micron mole concentration. This was my conclusion, that with excess of copper concentration in the soil, by the use of different chemicals on soil, we can reduce the growth of different plants. Thank you, sir.
Thank you, ma'am. Thank you. Dr. Gautam Kumar Shah.
Yes, sir. Yes, sir.
Continue.
Respected sir, my dear colleague and student, myself, Dr. Gautam Kumar Shah from CM Science College, Darbhanga. Now I am presenting my research on topic mechanical and same study of silicate polymer matrix composite by grafted polymer matrix. In this topic, polymer, that means polymers having properties like it will be added to some nano level and macro level filler, and this nano level and macro level filler will enhance the properties of polymer. In compared to virgin material, there are many enhancement of properties in polymers. Polymer properties, and with the help of morphological properties, I can interpret them and then can find out the properties of polymer will enhancing. In the present work, I taken polypropylene and grafted malic anhydride and macroclic composite with the help of melt compounding using twin screw extruder is the technique of extrusion process. In this process, melt compounding will take place, and this compounding process will enhance the filler properties and polymer properties. The important phenomena is dispersion. Dispersion is the phenomena in this polymer material will disperse and it will get increase and improve the properties of composite. In this study, there are many nanocomposite papers. I studied them. On the basis of that paper, I am achieved my work with mica silicate particle. In this particle, the experimental part material I will taken typical polypropylene from Reliance Industries India Limited and grafted material from Ipson Mobile India Private Limited. The percentage of grafting is 0.70%, 75% of injection grade, because this injection grade will helpful for the polypropylene virgin material properties, and mica silicate from Sai Limited India. And melt compounding, instrument for the melt compounding process are ZE25 Bristol high performance co-rotating, because co-rotating will forward the material, melt compounded material in forward direction, and it will extrude from the extruder, and this compounded material will cut in the fillet form. In this condition, temperature is the important parameter, because with the help of temperature will increase the melting process. And there are two types of process. One is melting temperature, another one is processing temperature. And filler having composite having high temperature range in compared to our virgin material. On that temperature, polymer matrix will completely dispersed with the filler, and it will enhance the properties of polymeric material. In this work, I have to maintain SQ speed and temperature. SQ speed means it will mix properly and disperse filler materials. The testing equipment for tensile test is Japan machines from Synthesis 250 KN and Flagrant stem from Lloyd instrument and TGA for Elmer and DSC from Elmer and same Leo from England model. They are very advanced lab, and this facility provided to me Central Institute of Petrochemical and Technology.
Please conclude.
Yes. In this data, here 95% that is 90 is our polymer matrix and 5 is grafted polymer and 5% is filler. It will enhance at the percent virgin properties of virgin data is 316, but at the 5% mixing of filler, it will enhance 397. That is a very big difference between virgin material data and our compounded.
Please conclude. Please stop. Please. These
are the. Yes, sir.
Go to the final slide. Please go to the final slide.
Okay, final. I'm concluded in just 1 minute. Here, these are the data of tensile properties, and these are the graph here. So 95.5. The composition will shows that here is increase of tensile strength and tensile modulus. These are the properties. On the basis of these properties, I compare many papers and on polymer composite papers and assemble them my composite material properties also is definitely increasing their properties, and this grafted material play a very vital role in increase of this polymer with our composite, and this composite material is applicable in many applications in automobile industry and electronics industry. And same analysis also proved here 5% composite filler will enhance the polymer composite, and here there are many same diagrams here, and the diagram of surface topography of same actually shows the surface topography, and with the help of this surface topography we can resemble the dispersion of filler with polymer matrix. But these are the same diagram on.
Please stop. Dr. Sir, please stop.
Okay, sir. These are the properties enhanced by the property transformer and automotive.
Yes, sir, I am present.
Thank you,
Yes, sir. Am I able to show my screen, sir?
You are audible. Please share your screen.
Right, sir.
Rupsi Bharadwaj, we will take you in next session.
Sir, am I able to share my screen?
No, you are audible. Anupmanjali, so present in next session 3 to 5. Okay. Anita Sinha. Okay, start. Anupmanjali, start.
Am I audible, sir?
Anupma.
Am I audible?
Yes. Start, you are audible, visible, go ahead. 2 minutes to 3 minutes.
So, good afternoon, everyone, and thanks the organizing team for giving me an opportunity to present something here. So, welcome to my presentation on green catalysis
for efficient organic synthesis to combat environment problems. So here is an overview of my presentation. Starting with the introduction, green chemistry is the most demanding topic to overcome environmental issues like toxic waste, cost and energy, and which is very challenging for the chemist. And the way we are dealing with such current issues are inappropriate to combat the concern of contamination to air, water and land. In recent years, green chemistry has attracted tremendous attention from the synthetic community. So silica supported catalysts for green catalysis. Silica supported catalyst proves to be a very promising synthetic tool. In recent years, it is a very synergistic effect with immobilized catalytic species. It is bound to have strong hydrophilic interactions between the substrate and the catalyst surface. So the present work is based on silica-supported acid catalysts. This is a single-pot multi-component reaction leading to the formation of quinazoline derivatives. In the starting material, different varieties have been used. Upon silica gel, chlorosulfonic acid is bind, it gets absorbed. Then the absorbed chlorosulfonic acid is used in the reaction as a catalyst. Later on, it is filtered, then separated. Then again, the second reaction is done and workup performed. So in this way, the catalyst is used multiple times. If the aromatic aldehyde not absorbed on silica, then during the reaction mixture when washed with water, it might have slipped out. So solids are used for catalyst binding. The solid phase catalyst was recycled and its efficacy was tested. So this is the graphical representation showing recycled catalyst. Some amount of silica sulfuric acid during workup was lost, so the same efficacy of catalyst was not achieved. Some quantity of catalyst reused 5 to 6 times and got sufficient amount of product. So the catalyst can be recycled, reused, which is a part of green chemistry. This is the mechanism of Biginelli reaction in which silica sulfuric acid releases H plus ions during the reaction, which reacts with a cyclohexanone, which further on proceeding in the final step condenses and fuses to form the quinazolines. The compound prepared in lab here compliances with this data. Data also detect this compound. This is the proton NMR data. This is the mass data and this is the carbon data. So coming to the outputs, the fused ring quinazolines are biologically active actually. Several activities of it have been reported, that is antifungal, antibacterial. So it is a multi-component reaction. The number of steps have been reduced, taking silica sulfonic acid leading to quinazolines. It is a 100% green methodology because product formed is biologically important. It is solvent-free, neat reaction. Solid support, recyclable, reusable catalyst is used. So we have considered here the aspects of green chemistry. So I would like to acknowledge my PhD supervisor, Dr. Nisha Saxena, and thank you everyone for listening to me. Thank you.
Next three presentations we will have in another after this technical session. Now I hand over this session to Dr. Nisha Saxena and Dr. B.N. Jha to chair this session.
Very chill good afternoon to all. Right chill, you know, we can't hear. Now I would like to introduce my head of the department, MRM College, who will be the chairperson of this session, Dr. B.N. Jha sir. You all know him, a very known face in Darbhanga, and if you were the student of Darbhanga from chemistry, then you must be knowing him. I'm very sure. He was in GRF from UGC and completed his PhD from NMU itself. His research is based on bioinorganic coordination compounds He has several papers, books, and projects from UGC. So he will be the chairperson of this session. Our guests, Dr. Souvik Samanta and Dr. Narendra Mishra. So I will call upon, I would like to request Dr. B.N. Jha kindly take over the session and introduce Dr. Souvik Samanta, who is the speaker of this session.
Thanks. Thanks a lot, Dr. Lisa Saxena, for inviting me. Now, I'm going to invite a very smart, energetic, and a young, talented chemist, Dr. Souvik Samanta, who completed his PhD from IIT Kanpur in 2015 in the area of asymmetric synthesis including isomer. He was awarded as Erasmus Mundus postdoctoral fellowship at University of Warsaw, Poland during 14-15 and as Claude Leon Foundation postdoctoral fellowship at University of Cape Town, South Africa in 2016-18. There he worked on asymmetric synthesis based on chiral auxilia. Currently he is working as an SD3 medicinal chemistry postdoctoral fellow at University of Cape Town, South Africa on the topic drug discovery, research and tuberculosis and malaria. He has published many papers in international academic journals of high repute. The topic on which Dr. Samanta is going to deliver his lecture is overview of drug discovery. Actually, sometimes the problem like pandemic creates some opportunity, and one of this opportunity I think is we are meeting with Dr. Samanta. So please, I don't want to make any hindrance between you and the speaker. Thank you. And I invite Dr. Samanta to join the lecture. Thank you.
Thank you very much. Thank you for this kind introduction and giving me this opportunity to talk in this forum. So I hope you can see my slides and I am also audible to you.
Yes.
Okay. Thank you very much. So I'm again going to thank you all for inviting me, and also good afternoon to everybody. And still it is in Cape Town, it is still good morning. And at this part of the globe, this is winter now. So here I'm going to give an overview of drug discovery. So which is basically an interdisciplinary field where you need some expertise of organic synthesis as well as some idea of biological knowledge. So before going to the topic, let me show you this picture of University of Cape Town. This is a beautiful campus under this mountain. This peak of the mountain is called Devil's Peak, and you can see here the Atlantic Ocean. And here in this building is the Department of Chemistry building.
Sorry, your slides are not visible.
You can't see my slides.
No.
Just a second. Okay, let me share it again. Can you see it now? Hello?
Okay, go ahead.
Okay, now you can see it, right? Okay, now I am going forward. So this is the campus, beautiful campus of University of Cape Town, under this mountain, and this building. This is basically the Department of Chemistry building. And on the top floor of Department of Chemistry building, we have Drug Discovery and Development Center. In short, H3D. This is the autonomous organization within this institute. So he is Professor Kelly Chibali, the founder director of H3D. He has been named as world's 50 greatest leader, according to the Fortune magazine in 2018. And need to mention that he was the only scientist in this list. Other people are like Bill Gates, Mukesh Ambani, etc. So he founded H3D back in 2009 with 5 of his organic chemistry postdoctoral researchers. Now we have a strength of 50 plus staff.
Sorry, your slides are not changing.
Oh.
Can check once check the start. Check your slides. Not checking. Yes, ready. First slide. We are able to see first slide.
You can see my first slide only, right? You can see this slide.
Yeah, your S3D slides, first slide is simple, not next one.
Introduction of H3D slides.
No, not changing.
I don't know what is going on.
Yes, now changing.
Let me again.
Yes, changing. Introduction to S3D, changing.
Okay.
Yes, now changing.
Now you can see, right?
I'll change one more, then you will confirm. Change next one.
Can you see?
Yes, introduction to S3D. Now change one more.
So you cannot see those animations.
Sorry, please go to the side here and share from there. Yeah, in the top. F5. Or F5.
Just a second. Can you please repeat what?
Just press F5 so that you will be in the slide share mode.
FY.
F5.
F5. Okay. Yes.
You will be in the slide share mode. Isn't it? Or sometimes you can reopen it. No issue. Just cross the window and reopen it. It might be possible you should not.
Can you please tell me what I have to do?
Sir, manually you can select the slideshow option by going to the PPT.
Okay, yes.
After sharing the screen, you need to start the slideshow. After sharing the screen, you need to start the slideshow by going to the presentation. By going to the PowerPoint.
After sharing the screen?
Yes. This way it works in Google.
Okay. Okay. I'm going to share my screen. Now you can see my slides.
No. Your screen is not shared. Yeah, it's going. Yeah, yes, coming with us. Yes. Yeah. Now go to the option slide share at the top of this window. You can see.
Here.
Left side.
Savik, I think it's normal PowerPoint presentation. Just it will work.
Yes.
I think it will work, Savik.
It is the normal PowerPoint presentation, right?
Yeah. Just present it so it will automatically pop up.
Yeah. So now what I have to do? I can.
You go to the slide share option at the top. Where you find the
Pop-up?
Where you find the file option, at that same there will be an icon slide share.
My side share of the icon is at the bottom. I am from where I am presenting. I already shared my slide. Can I quickly send the slide to anybody of you via email so that Can I send the slide to Simon?
Sorry to interrupt, sir. Sir, at the top there is no file, home, insert, design, transition, animation, and beside that there is slideshow. Just you need to click on that. Yeah.
Yeah.
Yes. And then from beginning or like from the current slide you can start. It will work.
Okay. Now you can see my slides.
Slides are in the.
Is it?
Yeah, it's not full screen actually.
You need to select from current slide option. There are different options below.
Okay.
Yeah.
Just 1 second.
Hello. Hello.
Yes.
Close the slide. Beginning process. Firstly, the select the content option. Hello.
Yes.
सर आप जो है ना पहले आप जो कंटेंट ऑप्शन पे जाइए वहां पर 2 विंडो खुल जाएगा एक विंडो और एक इंटायर विंडो का बिल्कुल सेट करेगा फर्स्टली आप शेयर को स्टॉप कर दीजिए
Savik, I think what you have to do when you're sharing, you go for share complete window, not a screen. So when you're sharing the screen, you will have this issue.
No,
okay,
sir. Sir, sorry to interrupt. Just select the option at the top. Only there are different options from beginning, from current slide. Just click on from current slide. It will work. At the top only there are different options coming. No, below slideshow. From current slide. Yeah, it will work.
So we can mail me your slides. We will manage from here. Okay.
So is it changing now? Yeah, yes, I'm emailing you the slides. Yes, I have sent it to you.
Okay.
Did you get that one?
In the meanwhile, I would like to introduce him again. Is the Erasmus Mundus Postdoctoral Fellow at University of Warsaw College, 2014-15. And then he was the George Leon Foundation Postdoctoral Fellow at University of Cape Town, South Africa, in 2016-18. He worked on asymmetric synthesis based on chiral observations. Currently, he is working on H3D Medicinal Chemistry Postdoctoral Fellow at the University of Cape Town, South Africa, and his topic of research is drug discovery in the area of universal tuberculosis and malaria, same as mine. He has published many papers in international referred journals of high reputed journals, and today he is going to talk about overview of drug discovery. So there must be a very interesting talk. Okay, sir. We got your presentation and you can start now.
Okay, thank you very much, and sorry for all these technical errors and everything. So can you please go to the fourth slide directly? Yeah, you can. Okay, I can give a quick introduction to the ACE3D. So he is Professor Kelly Shivali, the founder director of ACE3D. So please click one more. Yeah, so ACE3D was founded back in 2009 with 5 organic chemistry postdoctoral researchers. Now we have 90 plus staff members. And this is the only one drug discovery center in Africa. And our research areas are mainly malaria, tuberculosis, antimicrobial resistance. And recently we are going to start COVID-19 research. So far our achievement, greatest achievement, can you please hold on? Can you please hold on the slide 3? Yes. So our greatest achievement is one of the anti-malarial drug candidate goes to phase 2 clinical trial in Ethiopia. Yeah, so you can go forward with the next slide. Yeah, so drug discovery and development process is a quite straightforward process. Look like it is like you have to identify a disease, followed by you have to identify some biomolecules which are basically known as the target, and you have to then identify some chemical molecule which can bind to the targets and inhibits the target, and then you have to modify those chemical molecule which is called as optimization of lead compounds. Then you basically do the animal study, then human study, then you get the drug. Please go forward. Okay, so but this drug discovery process is not that simple. So first you have to, after target validation, you have to identify some chemical compounds which is known as the hit compounds which can hit the target. Then from hit compound, we have to generate some lead compounds, the new compounds, a few hundred new compounds, which can basically lead the program. And some of those lead compounds need to be optimized further. This process is called lead optimization. Then it goes to the animal study and human study as well. So first 3 steps of this process is known as the drug discovery process. So once a candidate comes from the lead optimization to the preclinical development, this is known as drug candidate. So if you start from a 10,000 new compound in the discovery phase, only 250 lead compounds can go to the preclinical development, and this process takes like 6 years. Then among these 250 lead compounds, only 5 drug candidates can come to the human trial. In phase 1 human trial, it is basically done on a few number of healthy volunteers to check safety and doses. In phase 2 clinical trial, is done on a few hundred patient volunteers in the hospital to check the efficacy, side effect. And phase 3 clinical trials are basically done on few thousand patients to check other effects. And this process also takes around, on average, 6 years. And then after that, one click more, please. After that, starting from 10,000 compound, only one drug can be approved and come to the market as a medicine. And this approvals take almost 2 years. So you can see this is a long process. Takes almost 14 to 15 years, and the success rate is also very low. And that is not all. After coming to the market, this medicine will be monitored for next few years to check long-term side effects. And of course, this process is very expensive. It takes billions of dollars to get one single compound or single medicine in the market. Next slide, please. Next slide. Yeah. So now from this slide onwards, I will be talking about the first 3 steps, like hit identification to lead optimization, which is known as the drug discovery. So to know the drug discovery, we need to understand the target product profile, which is basically the objective of the project, which we all the scientists and the stakeholder need to have clear vision, and we have to work keeping the end result in the mind, going backward. And there are some key factors to consider, like which disease we are going to treat, what should be the route of administration, like whether it will be a oral dose or a injection, and what will be the desired potency, like whether we are going to kill the bacteria, parasite or virus, or we are going to act as a co-drug, or what will be the safety or tolerability, and of course the stability, like whether they will be room temperature stable or we need a refrigerator. Then pharmacokinetics means how long and how often the treatment would be given. And if there is already a therapy, then our therapy should be more efficacious. There should be less side effect. Then the important thing is population, which will be our target population, whether they are rich or poor. And depending upon that, we have to decide the cost and also the timeline. We should have a strict timeline. Next slide, please. Okay, now quickly I'm going to give a description about the route of drug administration. When an oral drug is taken, it comes to the digestive system. Through intestine, it goes to the liver, then the right side of the heart, then lungs, then left side of the heart. Then it goes to the rest of the body, and if needed, goes to the brain. And this way the cycle goes on. But if an injection is given, it is directly either come to the vein or muscle, or inhalation directly come to the lungs. So the more distance a drug covered, the more it faces problems. But still, oral drug is the best drug because it is cheap, easy to take, and it is easy to store. Next slide, please. Okay, now coming back to the drug discovery process again. The hit identification is basically done by mainly three screening process. Phenotypic screening is basically wholesale screening, which is a cheap option, but you don't have any idea of mechanism or pathway or something like that. So there is a chance of failure in later stage of drug discovery. So people rely on target-based screening, which is where we need to know the target. Then we develop some biochemical assay. Then we also assume the pathway or mechanism, etc. And fragment-based screening is basically, this is a newer technique where people just identify some small fragments which can bind on the targets in different parts of the targets. Then basically tethering the fragment and make a new hit compound. One click, please. Please go forward. Yeah. So for a good hit compound, the hit compound need to have a good potency and selectivity. It should have drug-like properties. For example, Lipinski rule of 5, that means less than 5 hydrogen bond donor, less than 5 hydrogen bond acceptor, and molecular less than 500. Then this compound should have some synthetic accessibility and versatility. That means we can easily derivatize those compounds to a newer compound. Then there shouldn't be any undesirable group like acid chloride, which could be toxic within our body. And of course, these compounds has to be new. That means there should be some intellectual property space. Next slide, please. Next, please. Yeah. So in any drug discovery process, that process goes through different types of screening cascade. Like in this designer synthesis is basically done by organic chemist or medicinal chemist. Then it goes to the biology, pharmacology, and DMPK guys, who basically do the other biological testing, and the result comes back to the medicinal chemist, and they again design, redesign, and resynthesis, and this way the process goes on. I'll not go through this all screening cascade, but there are some screening cascade, basic screening cascade for all these drug discovery research, up to this mouse PK, the middle row, up to this mouse PK or in vivo efficacy model. So I'll briefly discuss some of them. Please go forward. Okay, so DMPK or ADME is one of the most important factors in drug discovery. DMPK stands for drug metabolism and pharmacokinetics, and ADME stands for absorption, distribution, metabolism, or excretion. Absorption means when an oral drug is taken, how it is going to be absorbed within our body. Distribution means how it is distributed throughout the body. Metabolism means how it is getting broken down, mainly in the liver, and excretion means how it is leaving our body. So when a drug is taken orally, it absorbs through the gut wall, but there are some efflux effect which basically try to avoid those foreign particle absorption. But after overcoming the efflux effect, it goes to the liver for metabolism. Metabolism is basically liver try to make those compounds water soluble so that it can be excreted through the liver, through the kidney. After overcoming this metabolism, drug come to heart, then blood, And in the blood, there is plasma protein binding. After overcoming those things, those plasma protein bindings, and then blood-brain barrier, tissue distribution, etc. Overcoming all these factors, a drug can hit to the target. So all these factors we need to consider when we are going to design a drug. Please go forward. Okay, so in vitro test for in vitro testing, like in the laboratory, it is quite straightforward. Whatever dose you give, you can get the effect. But in animal model or human model, there are different factors like absorption, clearance, plasma protein binding. After overcoming all these factors, it comes to the biophase and shows the effect. So depending upon all these factors, we need to decide the dose. So an early lead compound can have a good potency, but a drug candidate which can have a less potency than early lead compound, but it should have a good balance of all the potency, safety, absorption, metabolic stability, solubility, etc. Please go forward. Okay, now I am going to talk about solubility. Next slide, please. Okay, solubility is one of the important factors. Poor solubility leads to poor absorption of the compound, and solubility also changes within the pH, within the different pH of our body. And there are some improvement strategies for the improvement of solubility. Physical methods like salt formation, supramolecular techniques like co-crystal formation, and chemical techniques, of course, like ionization group addition, addition of hydrogen bond, addition of polar group, reduction of molecular weight, etc. Next slide, please. Okay, now I will be talking about microsomal metabolic stability. Next slide. Okay, so as I already mentioned, metabolism is mainly happened within the liver. There are two types of metabolism, phase 1 and phase 2. In phase 1, metabolism is basically polar modification of the molecular structure with oxidation, reduction, or hydrolysis, etc., to making the molecule water soluble so that it can be excreted through our urine. And next slide. Yeah, and phase 2 metabolism is basically addition of polar group to the compound and making this molecule polar so that it can be left out from our body. Next slide, please. Okay, so there are some structural modification strategy for improving the metabolism. First one is the blocking with fluorine atom at the metabolic site, or including some steric hindrance, or removing levyl group, cyclization, changing of ring size, changing of chirality, etc. Next slide, please. Now I will be talking about permeability. Next slide, please. Okay, so permeability is the measurement of the velocity of drug at which the drug passes through the membrane. As you all know, membrane is made of lipid molecule. So we need to maintain the lipophilicity of the compound so that it can pass through the membrane. And also when we are going to introduce some lipophilicity of a compound, the water solubility of the compound decreases. So there should be a balance between lipophilicity and hydrophilicity. So there is a structural modification strategy for introducing lipophilicity, like adding ionizable group, increasing lipophilicity, isostatic replacement of polar group, esterification of carboxylic acid, etc. Next slide, please. Now I'll be talking about toxicity. First is the cytotoxicity. Next slide, please. Cytotoxicity is basically the killing of healthy cell. So when we are going to give a drug to treat a disease, then it can also kill some healthy cells as well. So there should be always a selectivity of killing healthy cell over killing the disease cell, and that selectivity index should be always greater than 100. This CHO, HG2, Vero, these are some cell lines based on what the cytotoxicity is basically determined. Next slide, please. Then I will be talking about cardiotoxicity. Next slide. So cardiotoxicity, in our heart, basically there is a potassium ion channel. A compound can block this potassium ion channel, which is basically known as HARC inhibition or HARC activation. So at the below you can see the normal heartbeat. There is a Q wave and a T wave. When a HARC is activated, there is a prolongation between Q and T wave, which can cause the heart attack. So there is some structural modification strategy to overcome the heart, like reducing the basicity of the amine group, reducing the lipophilicity, introducing polar group like acid moiety, etc. Next slide, please. Okay, now I'll be talking about pharmacokinetics, which is basically mouse PK model. Next slide. So the compound or the drug candidate is given to a healthy mouse and to check different parameters. So in the left side graph, you can see there is a graph between plasma concentration and time. This is basically the concentration of drug within the blood plasma. So when an oral drug is given, the concentration gradually increases during the absorption phase, then it reaches to the maxima, then at the elimination phase is reduces down. But when an injection is given, it directly comes to the blood plasma. So starting from the maxima in distribution and elimination phase, the concentration reduces. So at the right side of curve, there are several important factors we can get to know from this PK model, oral PK model. So Cmax is the maximum concentration after giving the oral drug. Tmax is the time when the Cmax is reaches. Then T-half is the elimination, half-life of the elimination. Clearance is the rate of the drug at which the drug is eliminated to the body. Then volume of distribution, area under the curve, oral bioavailability. There are several factors to consider. Next slide, please. So absorption is basically depends upon permeability, efflux, and aqueous solubility. Elimination depends upon renal excretion, biliary excretion, and metabolic stability. Distribution depends upon protein binding and tissue binding. So based on absorption and elimination, the bioavailability is determined, and based on that, we determine how much dose we should be given. And based on the clearance and volume of distribution, half-life is determined. That means how often the drug should be given. Next slide, please. Okay, lastly, I will be discussing about in vivo efficacy. Next slide. This is basically a disease model. So first the mouse is given to the exposure of the disease, particular disease which we are going to treat. Then we basically treat the mouse with our molecule. Based on that, we will basically form the proof of concept or the mechanism, and also we predict the human dose. So in the left hand side curve, you can see there is a plasma concentration versus time curve. So there are 2 points. MEC means minimum effective concentration, MTC means maximum tolerated concentration. Above MTC, that compound is toxic. Below MEC, that is ineffective. So as long as that in between this 2 point, that is therapeutic region, and as long as the drug candidate is within the therapeutic region, it is going to cure the disease. So as we cannot be treated just one tablet, we have to take those medication for a period of time. So throughout the therapeutic throughout the treatment, that concentration always should be in the therapeutic region at is shown in the right hand side graph, and this concentration is known as steady state concentration. Okay, next slide, please. So I am going to end this topic with a comparison between 2 drugs. So first one is the itraconazole from Janssen. Second one is fluconazole for Pfizer. Both of them are antifungal agent. So first drug has an in vitro potency 300 times better than the second drug. But if you can see the market sale in 2001, second drug found to be much better drug from the first drug. So why it is so? If we check the pharmacokinetics parameter in man, then the half-life period of both the drug is same, but the bioavailability of the second drug is 100%. That means 100% the drug get absorbed. Then the plasma protein binding is only 11%. That means 89% drug is available to hit the target, whereas the first drug, only after plasma protein binding, only 0.2% drug is available. Then the solubility of second drug is also better, which gives better absorption, and also the molecular weight, that is less than 500, which also follows the Lipinski rule of 5. So Pfizer basically compromised the in vitro potency, but After all the parameters, they found a better drug. So in drug discovery research, there is no best drug. There is basically a best compromise drug. So that's how I conclude my topic, and thank you for your kind attention. And again, sorry for all these technical mistakes and technical problems. And again, I'm going to thank you for giving me this opportunity. Yeah, thank you. Thank you very much.
If you have any query, you can write us. You can write Dr. Souvik on his email ID. We will provide that. And thank you, Dr. Souvik, for an excellent talk. And I think he covered all the aspects of drug discovery. Nothing is left behind. So perhaps you will be getting a lot of input in your drug discovery program, which are going on here also. So for the next speaker, Dr. Narendra Mishra. Yeah. Dr. Narendra Mishra, and
yes.
I will invite Dr. B.N. Jha, sir. Welcome, Dr. Narendra.
Yes, I'm here.
Yeah, of course, sir. Dr. B.N. Jha, sir, will introduce you, and I would like to invite Dr. B.N. Jha for the introduction of Dr. Narendra. So please come.
Thank you, Dr. Nissan. Hello, everyone, and welcome to this third technical session. Today's third technical session. The speaker is Dr. Narendra Mishra, who has completed his PhD from Indian Institute of Technology, India, under the supervision of Professor Sandeep Verma, in the field of bioinorganic chemistry. Fortunately, I have the same field, and it is also a field of interest of mine. In 2016, currently he is working as a postdoctoral fellowship at University of Copenhagen, Denmark. He also worked as research chemist, PCG Life Science Private Limited, 2007 to 2009. He was awarded prestigious Inspired Faculty Award by the Department of Science and Technology, New Delhi, in January 2019. He has published more than 25 papers in international reviewed journals of high impact factors. He is passionate and motivated synthetic chemist, having experience in synthesis of complex small molecules, peptides and peptide oligonucleotides conjugates. This interest stems from immense thirst to understand fundamental biological problems with an aim to find a way to challenging tasks developing peptide and chemically modified protein based therapeutics. Dr. Narendra Mishra, please join me.
Narendra, you are not audible. Narendra, you are not audible.
You are not audible.
Unmute, unmute.
Unmute yourself, please.
Yes, am I audible right now?
Yes. Continue.
Super. Thank you very much, Professor Jha, sir, for such a wonderful introduction, and I must appreciate the organizing committee for giving me this opportunity to be here today, to interact to all of you through this online e-conference. So before going to talk about the chemical approaches in the development of a smart insulin, let me describe with brief description of my research work at University of Copenhagen. So my research work at Copenhagen University is quite interdisciplinary, and it is comprised of two different domains. First one is about the nanoscale architecture, where I'm controlling the self-assembly of biomolecule through the covalent and the non-covalent approach to build a new quaternary architecture. Second is about the responsiveness, where I'm conjugating a small molecule to the biopharmaceutical to improve their in vivo performance. And my today talk is all about the second part of my research, responsiveness, where I'm going to talk mostly about the diabetes and insulin. So as you all know that diabetes is a metabolic disease that results from insufficient insulin production due to destruction of the beta cell in case of type 1 diabetic patients and decrease in sensitivity in case of type 2 diabetic patients. So malfunctioning of insulin secretion not only result into the increased blood glucose level, but is also responsible for several other complications. So the only treatment for the type 1 diabetic patient is insulin therapy, where they have need to take a combination of long-acting and the short-acting insulin analog to control their blood glucose level. On the other hand, so due to the individual problem of a particular patient, and of course due to the mismanagement of the insulin therapy, there is always there is swing in the blood glucose level of a type 1 diabetic patient, and sometimes it is too varies from 10 millimolar to 30 millimolar. So in that case, the type 1 diabetic patients suffer from several other complications, as I mentioned before, and sometimes they also feel hypoglycemic attack. It could be more dangerous if it is coming in the night, because in that condition, type 1 diabetic patient cannot take the necessary medication. So it is always important to develop a new insulin where it can shortcoming can be avoided. On the other hand, type 2 diabetes is a lifestyle disease, so it can also be controlled by controlling the lifestyle of particular patient. But of course, there are some medications are available where this where they can control the blood glucose level of type 2 diabetes patient as well, like metformin, sulfonylurea, and GLP-1, etc. But it has been estimated that the efficacy of this drug will be diminished with time, and type 2 diabetic patients also require insulin to control their blood glucose level. And again, there will be individual problem of a particular patient, and mismanagement of the insulin. There is always demand of a better insulin, and that could be possible only if there is development of glucose responsive insulin that has been termed as a smart insulin as well. So I would like to briefly talk about the insulin structure and function. So as you all know that insulin is a peptide hormone which regulates the carbohydrate and fat metabolism in our human bodies, and of course in some of the mammalians. So it is composed of 51 amino acid residue, and it's having two long chain, A chain and B chain, and both chains are connected to each other by two intermolecular and one intramolecular disulfide bond. So insulin produced and stored in the beta cells of the pancreas in hexameric form, but the active form of the insulin is monomeric form. Insulin is a very small protein with very long journey. It has been discovered exactly 100 years ago in Canada in 1921. And from 1921 until 1981, insulin isolated from the pancreas of the bovine and porcine has been used for the treatment of the type 1 diabetic patient. But after the advent of the recombinant DNA technology, insulin production has been increased, and it makes better life of type 1 diabetic patient up to some extent. But the problem was that human insulin is not a very useful injectable drug, because it neither provides a basal profile and neither provides the bolus profile. So in that condition, insulin had been modified either by altering the amino acid sequencer, either by chemical approaches, by conjugating the small molecule or abiotic ligand to improve its pharmacokinetic profile. So in this way, several insulin came in the market. Some of them as termed as a short-acting analog, and some of them have been termed as a long-acting analog. The meaning of the short-acting insulin is that patient need to take the insulin just before meal to control the blood glucose level, while the meaning of the long-acting is that patient need to take it when they are in the fasting stage. So of course, the chemical approaches are important to improve the pharmacokinetic profile of the insulin by different means. But it's also important that how they have been formulated in the vial and how they are going to work when they have been subcutaneously injected. So this is the overview of all the insulin which are available in the market right now. So the first insulin, Degludec, which is one of the blockbuster selling medicine, Degludec is a long-acting insulin. So in the vial, it has been formulated as a hexamer, but when it has been subcutaneously injected, the ingredient will be split out, and it will form a multimer of the hexamer, and that will reduce its absorption. Since it's having the long aliphatic chain, so it will bind to the albumin and further prolong the duration of action. Insulin glargine is designed in such a way that it has a low solubility at physiological pH. So when it has been subcutaneously injected, it will precipitate out. And from there, it will, due to the molecular crowding, reduce the surface area, and absorption become very high up to the 30, become very slow, and that will prolong the duration of action up to the 36 hours. Insulin glargine U100 also work in the same way. D-dimer is having the same concept of the degludate because it's also having the long aliphatic chain, but its duration of action is less. On the other hand, all the short-acting analog like insulin, Lispro, Spot, glulicine, fast-acting, they all have been designed in such a way that their dimer dissociate very fast and their absorption occur very quickly within 30 minutes. So, but there is always problem of this hypoglycemic attack and excess weight gain in type 2 diabetic patient. So even though there's a lot of insulin came in the market by the different companies, but still there is a demand to avoid all the shortcoming of the insulin, and most important, hypoglycemic attack. And this could be solved only if the glucose responsive insulin can be developed. So there are two approaches to make the glucose responsive insulin. First is about insulin embedded in a matrix. So currently most GRI system being explored in the literature containing polymeric biomaterial, where insulin is embedded in a matrix, and that matrix contains glucose responsive elements such as phenolic boronic acid, concovalin, and glucose oxidase peroxidate, which can regulate the insulin release rate by change in the structure and function of the polymer. But the feasibility of this method is really a matter of question by the pharmaceutical companies. So another method is that GRI through covalent conjugation approach, where insulin can be modified by the glucose bonding element and work as a glucose responsive insulin. But insulin is small protein. It cannot tolerate a lot of modification, and sometimes it's lost its receptor affinity. So, but still some modifications are available in the literature to improve its in vivo property, and also is to work as a glucose responsive insulin. Two main approach is there in the literature. First is from the Novo Nordisk Denmark, where they have conjugated insulin with the phenolic boronic acid containing the polyol moiety. So it will boronic acid will interact with the diol to make a very complex structure. But the problem was that it required a very high concentration of the glucose to break that complex, and that is not possible in physiological condition. On the other hand, second method, which came from the MIT Robert Langer group, where they have conjugated insulin with this long aliphatic chain boronic acid. So one of the common approach of this both this method was that they target the diol moiety of the glucose. So here we report a fundamentally new concept that exploits the fact that glucose in solution primarily exists in two forms, alpha D glucose and beta D glucose via open chain aldehyde form. So here we conjugated a small molecule on insulin which will target the aldehyde part of the glucose instead of targeting this alpha or beta D glucose. So the basic idea about here is that after the subcutaneous injection, GRI will go into circulation, and it further will bind to the albumin since it's having a long aliphatic chain, and it responds only when there is a threshold increase in the glucose concentration more than 10 millimolar, and then it will control the blood glucose concentration. Well, the concept here, the chemical concept is here is that this insulin have been conjugated with this cleavable linker, and this cleavable linker is further conjugated with the long aliphatic chain. So after the subcutaneous injection in the first equilibrium, it will bind to the albumin, and when there is increased concentration of the glucose, water will help to break down this cleavable linker, and further this active part of this cleavable linker will react with the aldehyde form of the glucose to work as a glucose responsive insulin. So what is the structure of GRI? Our GRI is having three components: insulin, core structure, and lipid. The core structure is the most important part because it is the only who is going to react with glucose. So we have developed two different kind of core structure. First one is hydrazone, and second is about thiazolidine. So here we demonstrate that aldehyde form of the glucose will target here the hydrazone and thiazolidine and cleave it off. So the reaction between hydrazone and thiazolidine is a reversible feature which has been used in dynamic material chemistry for exchange of hydrazone with the new aldehyde if the new aldehyde is present in excess, and the same applies in case of thiazolidine. So let me describe something about here chemistry of this two core structure. So here in the first equilibrium, it will be clipped up and to make hydrazide. And the same in case of thiazolidine, in the first equilibrium, it will clipped up and will make the cysteine analog, corresponding cysteine analog. And the second equilibrium, it will react with aldehyde part of the aldehyde form of the glucose to make hydrazones and thiazolidine. So here we have control the activity of these hydrazones and thiazolidine by adding electron withdrawing and electron donating group. So with this concept, we have synthesized around 85 core structure, and from there we have chosen some of the core structure for the lipidation and followed by insulin conjugation. So first of all, I would like to just describe that how we started our project. So we are having several, first we synthesized several core structure, as I mentioned before, and further we determine their glucose responsiveness with different equivalents, like the glucose low concentration means 10,000 equivalent, glucose high means 20,000 equivalent. And from there, we have also calculated how much conversion is happening in their corresponding hydrazones. And same we have did for the thiazolidine derivative as well. So I'm just here showing here just some of the structure, but we did a lot here to make glucose responsive insulin. So from there, we have chosen some of the structure for the lipidation and followed by the conjugation to insulin. And it is based on the three main parameters: low background hydrolysis and a shorter half-life at high than low glucose concentration. So here you can see that we have synthesized several core structure, several insulin glucose responsive insulin, but I'm just going to present the data for GRI1 and GRI2, where one of them is glucose responsive and another is not glucose responsive. So this is the full structure of the GRI1 and this is the full structure of GRI2. So finally, a series of in vitro and vivo experiment has been carried out to access the receptor affinity and also to see their efficacy in terms of getting glucose responsive insulin. So first of all, we have incubated GRI1 of different concentration from 0.5 to 10 micromolar with 1 molar glucose concentration. And here we have found very nice receptor affinity, but we don't know whether it is going to work as a aldehyde responsive or not. So to know about this, we have done a control experiment. We have added their GRI1 with 1 millimolar glyceraldehyde. But here the real receptor affinity is coming exactly the same as for the glucose responsive insulin without any aldehyde. So from here we came to know that this conjugate is not working as a glucose responsive insulin. While in second thiazolidine based GRI, which is having this benzene and thiazolidine group on the lysine B29 position. So first here we have taken a 1 micromolar of GRI2 and incubated in two different conditions, 100 millimolar and 1 millimolar. And in both cases, we found the receptor affinity. And you can see that with 1 molar, its receptor affinity is better than the low concentration. So it means that it's working as a glucose responsive insulin. But again, there was a question that whether it is working as aldehyde responsive or not. So to demonstrate that, again, we have incubated with glyceraldehyde here. And again, you can see there it's having the aldehyde responsive potency. So from there, we know that out of these two hydrazones and thiazolidine, only thiazolidine based GRI is working as a glucose responsive insulin. So from these two experiments, one thing is clear that pre-incubation with low equivalent of the glucose don't have any potency with GRI, while pre-incubation with high equivalent of the glucose are decreasing the concentration from 50 micromolar to 0.5 micromolar, definitely working as a glucose responsive insulin. So to further understand this, we did the in vivo experiment where we have determined first the insulin tolerance test. So insulin tolerance test is a medical diagnostic technique. Hello. Insulin tolerance test, and we are determining the glucose lowering effect. So here we have chosen only those mice whose glucose concentration is more than 10 millimolar. So you can see here that after the subcutaneous injection, glucose lowering effect is up to 480 minutes in both cases. But after the 480 minutes, mice have been again refeeded to avoid the hypoglycemic attack. But again, when it is reaching up to 660 minutes, there is no glucose responsiveness in GRI1. But in case of GRI2, something is going decline again. So it means that GRI2 is working as a glucose responsive insulin. So to further reveal about the glucose responsiveness, it is essential to measure the glucose infusion rate in both normoglycemic condition and also with hyperglycemic condition, and further compare the glucose infusion rate in normoglycemic condition and hyperglycemic condition. And from there, we can determine whether it is working as a glucose responsive insulin in physiological condition or not. So we did the clamp study, and again we have injected GRI1 for 113 nanomolar per kg, and GRI2 also 113 nanomole per kg. And in normoglycemic condition, you can see the glucose infusion rate for the GRI1 is a little bit higher than the GRI2. But in hyperglycemic condition, it is almost similar to the for both of them. So further, we increase the concentration of the GRI2 up to 226 nanomole per kg. And in this case, glucose infusion rate in normoglycemic condition exactly similar to the GRI1, and glucose infusion rate in hyperglycemic condition is increased up to some extent. So which clearly indicate that our system is working as a glucose responsive insulin in physiological condition as well. So this is just a statistical approach to represent the data, and you can see here that at 113 nanomolar per kg, glucose infusion rate for the GRI1 is a little bit higher than the GRI2, but in hyperglycemic condition it is almost similar. But when we increase the concentration of the GRI2 to 226 nanomole per kg, the glucose infusion rate in normoglycemic condition is quite similar to the GRI1, but in hyperglycemic condition, it is increased by 15%. So with this, I would like to summarize that overview of different analysis of the glucose responsiveness. So we have designed our project in 3 different phases. First phase is about the UV HPLC working equivalents, where design the core structure and determine their half-life by using the UV method. But there is a limitation that we cannot go more than 20,000 equivalent. And second phase was about determining the half-life, determining the glucose responsiveness through the CHO cells, where we have increased the concentration of the glucose but decreased the concentration of GRI. And we have, in that condition also, we seen the glucose responsiveness. But in physiological equivalents, where in our body, the insulin concentration is in picomolar range and glucose concentration is very high. But in that condition, we have reached up to 190 nanomole per kg, and we are still working to improve the glucose responsiveness up to the 90% to get the better result in physiological range. So with this, I would like to thank you again, the organizing committee, for giving me this opportunity to be here today. Thank you very much.
Thank you, Dr. Naresh, for an excellent insight on the topic chosen, smart insulin. Your research is really fascinating, and I feel the disease must declare the global emergency. Don't you feel so? Okay, so let's move for the closing ceremony of this session. And I would like to invite Dr. B.N. Jha, chairperson of this session, to please come and give vote of thanks to both the speakers. Please come.
Dr. Mishra, there is a saying, wherever there is a love for medicine, there is an art for medicine. Is love there is also a love for humanity. So art for medicine is directly related to the love for humanity. Dr. Mishra, you have, sir?
Yes, I'm here. Yeah.
Purposes. Our 2 core purposes you have, sir. One, you have just given us a hope that the diabetic is not going to be so life-threatening as it is now in the near future. and other, a young, smart scientist, dynamic scientist, is going to interact with the future scientists who are our PG students. So thank you for a nice presentation, and hope we shall hear you in the near future. Thank you.
Thank you very much, sir. Thank you very much.
Hello.
Hello.
Shamik Samanta, I would like for your nice presentation. Thank you. Thank you very much. We allow you. Now we will move for next session, oral presentation session. Rupsi Bharadwaj. Rupsi Bharadwaj.
Yes, sir, I'm here.
Start your presentation 3 minutes. 2 to 3
Yes,
minutes.
sir, sure. So good afternoon. Rupshi Bhardwaj here. I'm a research scholar from Lalit Narayan Mithila University, Darbhanga.
From the MIT Robert Langer group, where they have contributed long and fatty chain folic acid. So one of the common approach of this
Sir,
targets the diarm of the group. So here we refer a fundamentally new concept. The next slide.
shall I go ahead? Good afternoon, everyone. I'm Rupshi Bhardwaj, a research scholar from Ellen Mithila University, Darbhanga. Thank you to the organizers for providing me an opportunity to present this literature review. So my topic is combining machine learning and computational chemistry for chemical systems. So the very first thing is, what is machine learning? Like we humans, we can learn everything automatically from experiences. Right. Similarly, machines, they can also learn from the past data. If we have a like a data set, machine they can also learn with the help of machine learning. So this machine learning works on data and algorithms. So what are algorithms? It is just this set of step-by-step procedure, or we can say a set of rules to complete a specific task. So this machine learning, like in our day-to-day life, we see different applications. Just take the simple example of spam emails in our mailbox. So how it is filtered, how this filtering is done, it is the application of machine learning. So how this machine learning works, like we have different like data already available from different experiments, literatures, computational data. So that machine learning algorithm, it is applied, and a machine learning model is decided that can be used for a particular thing, and the new data is processed in that, and finally we get the output. So how it works, like we have different challenging thing in different areas of science. Maybe we can say mechanical material prediction, or designing a material, or different computational problems. So we already have the databases and different literatures that whatever we have till now, and we have the different experimental data and the simulation data. So all those data, they are pre-processed and machine learning is applied. We have like different machine learning models that is decided that which model will be used, and finally we get the result, we can use it. So we have different selected application in specifically in chemistry. If we take, so molecular and material design, in that optimization is the issue, but machine learning can help us with that. Then in catalysis, in retrosynthetic technologies, and in drug designs also. So, how machine learning work for drug discovery? So, as we have a wonderful session from Dr. Souvik on drug discovery, so machine learning can help us. Machine learning and computational chemistry, if we take both intersection of both the field, it can help us in the drug discovery. So, finally, I would like to conclude that we need to have expertise in both the field, machine learning and the computational chemistry, and finally it can just help us with the different challenging situation in the research. Thank you so much.
Thank you, Dr. Anita Sinha. Dr. Anita Sinha. Dr. Anita Sinha, NPS. Pradeep Kumar, Science College, Purnia. Pradeep Kumar. Pradeep Kumar. Kunjan Kumari. Kunjan Kumari.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. मेरी आवाज जा रही है?
हाँ, आ रही है।
जी सर, मैं गुंजन कुमारी मधेपुरा से हूँ और सर मैं स्क्रीन शेयर नहीं कर पाऊंगी क्योंकि लैपटॉप मेरा थोड़ा खराब है सर। एक बार मैं फिर कोशिश करके देख रही हूँ स्क्रीन शेयर के लिए। एक मिनट सर। हेलो सर। हेलो सर। सर हमारी आवाज जा रही है सर?
आपको आवाज आ रही है? आप क्या क्वेश्चन करना चाहती हैं?
हाँ सर। सर स्क्रीन शेयर नहीं हो पा रहा है लेकिन मैं ये प्रेजेंट कर रही हूँ। मेरा टॉपिक है सर टाइप 2 डायबिटीज के लिए है मेटफॉर्मिन बेंजोथाइजोल डेरिवेटिव्स। A number of broader social trends shaping the chemical science due to aging population, growth in demand, medicine to prevent, treat, and control age-related condition will be key future for chemistry. The chemical science have the potential to solve many of the world's greatest challenges in health, energy, and climate changes. In world level diabetes, especially in India, it is in alarming situation and challenges for chemists to prevent to cure from health problems. In this regard, ships based off metformin and their metal complexes will be very useful to help prevent type 2 diabetes. This present paper is based off the metformin benzothioneol derivatives and their metal complexes are very effective as anti-diabetic activity, which shows decreased glucose level to significant extent at different interval of time. Metformin complexes with cobalt has maximum potency to reduce blood glucose in hypercondition. First of all, 6-base ligands of MTF with benzothioneol were prepared by mixing aqueous solution of MTF per 1 minute and benzothioneol, then complex of cobalt 2 was prepared. Complex was analyzed with the help of IR, NMR, etc. biological activity of cis-base, and their complexes were tested as anti-diabetes, which was very effective against diabetes. Thank you, sir. Thank you.
Thank you, Kunjan Kumar. Dr. Arun Kumar, KS College. Dr. Arun Kumar. Dr. Arun Kumar. Dr. Arun Kumar, KS College. Dr. Arun Kumar, KS College. Mohammad Sarfaraz Alam. Mohammad Sarfaraz Alam. मोहम्मद सरफराज आलम, पुष्पा कुमारी, डॉक्टर पुष्पा कुमारी, यूनिवर्सिटी डिपार्टमेंट ऑफ केमिस्ट्री LNMU, डॉक्टर पुष्पा
जी सर,
कुमारी।
जी सर, जी सर, सर, सर,
अनम्यूट कीजिए अपने आप को।
देखो देखो इसको आवाज म्यूट कैसे करेंगे, आवाज कैसे आएगा? हेलो,
हाँ आप ऑडिबल है, प्रस्तुत कीजिए।
हाँ क्या पुष्पा कुमारी?
हाँ सर, श्रीमान
सर
सर
मेरी
मेरा
आवाज आ
नंबर
रही
नहीं
है?
आया।
हेलो,
हाँ सर 2 मिनट रुकिए, पुष्पा जी के बाद आप आइए, अभी आपका नाम मैंने बुलाया था। 2 मिनट वेट
हाँ सर,
आप प्रेजेंट करिए।
हाँ मैं पुष्पा कुमारी। सर मेरी आवाज जा रही है आप लोग को? हेलो,
अच्छे से आ रही है आवाज, आवाज आ रही है।
हेलो सर, मैं पुष्पा कुमारी।
आपकी वॉइस आ रही है, आप प्रेजेंट कीजिए।
हेलो सर, मेरी आवाज जा रही है? सर मेरी आवाज आप लोग को सुनाई पड़?
अनीता मैं अनीता सिन्हा बोल रही हूँ। हेलो,
वेट करिए 2 मिनट। अरुण कुमार सिंह, केएस कॉलेज।
अनीता सिन्हा प्रेजेंट।
हाँ 2 मिनट वेट कीजिए। अरुण कुमार सिंह, केएस कॉलेज। अरुण जी अनम्यूट कीजिए।
अनीता सिन्हा सर, अनीता सिन्हा है प्रेजेंट।
हेलो
अरुण कुमार सिंह जी आवाज जा रही है मेरी? हाँ आपको प्रेजेंट करना है, प्रेजेंट प्रॉब्लम पड़ेगा।
मेरा आवाज हेलो हेलो हाँ अब जा रहा है तो बता।
फोटो के
चलिए नेक्स्ट अनीता सिन्हा। अनीता सिन्हा।
यस सर, अनीता सिन्हा प्रेजेंट सर।
प्रेजेंट करिए अपना।
सर मैं अपना
आप कुछ प्रेजेंट करना चाहती हैं अनीता सिन्हा जी? सुनील कुमार, सुनील कुमार, केएस कॉलेज। सुनील कुमार, सुनील कुमार, केएस कॉलेज। सुनील कुमार, केएस कॉलेज। निधि झा, सीएम साइंस कॉलेज। निधि झा, सीएम
हाँ
साइंस।
सर, good afternoon sir, I am here to present.
आप प्रेजेंट करिए निधि झा जी। सुनील जी वेट कीजिए 2 मिनट। निधि झा जी।
Give me little bit span sir. Okay sir, my topic for the presentation is, first of all, it is very little span of time, that's why I am not able to give the detail about it. Very good morning to all of you, all my respected sir and all my colleagues and dear student. Dear students, just I am telling about my research that we are going to present here synthesis and antiviral activity of some new naphthazosinolines. Here we are spotting for the papaya ring,
as we know that the papaya is the third most economically and medically fruit crop, has social and economic importance also in tropical and subtropical region. More than 1.5 lakh productions decreased due to approximately 20 tons decreases in the this year. Due to these things happen due to the viral effect, viral disease. And viral disease represent a major sanitary problem, especially those transmitted by insect vector. That's why my research is on this to spot the viral activity, to spot such viral activity. As we are consuming, most of the people, we are consuming the papaya as our fruits in the morning, and we are looking at our tree that there is a lot of virus is detected there. For this, in the very little span, that's why I am telling about my experiment that I have done, taking the compound as a derivatives. As we know that heterocyclic compound, if you are taking the heterocyclic compound, and all the hydroxides are very much useful for the biological and antiviral activities. It is very important to research on that things. Most of the PG student in semester third also, they have their topic of heterocyclic compound. So I request them to look after this research, that if we are taking azagides or trizol or anything, they give the medical activities also and antiviral activities also. So here we are taking in the experiments, we are taking two compounds name as a derivatives, and that compound is first is 2 hydraquinone and 3 carboxyl acid, and second is 2 hydraquinone 3 acetic and acid esters. By combining these in the alkaline solutions, alkaline medium, we are getting the compound that is 3-hydroxy 1,4-dihydranaphtha-jacinolenes. These compound is very useful as we taking the analysis, our result. If you are taking some of the tree plants, taking only 3 or 4 leaves, and when we take it in the solutions, we deduct that some of the virus is spotted and that. And this is by taking the number of lesions or number of infected plant. There is also that this result show lot of activities when we are taking most of the derivatives, as we are taking methoxy, methyl, or
Hari Mohan Prasad Singh, Hari Mohan Prasad Singh, Anjit Kumar Thakur.
Yes, sir. Good afternoon, sir. Good afternoon, everyone. This is Dr. A.K. Thakur, Department of Chemistry, KV Science College, Uchait. Today's my topic is synthesis and characterization of heteroyl metal complexes. In this paper, 3 transition metal 2 complexes of the types Ml2, where Al is the uninegative heteroyl base, tridentate C base derived from thiosemicarbazole, and 2-acetylphene have been reported. On the other hand, transition metal in +2 oxidation state have been taken. The used transition metal for complexes with the above maintained heteroyl base tridentate C base are cobalt-2, nickel-2, and Zn2 salts. The ligands was prepared by simple condensation method by taking 2-acetylthiophene and thiosemicarbazole. The structure of the ligand was confirmed on the basis of melting point, solubility, color, elemental analysis, molecular mass determination, establishment of structure of the ligand. It complexation with transition metal 2 ion like cobalt-2, nickel-2, and Zn2 was completed by using the simple condensation method. The structure of the complexes were confirmed on the basis of physical properties like melting point, solubility, color, elemental analysis, and molecular mass determination, and spectral analysis like PNMR, CNMR, electronic spectra, and UV visual spectra of the complexes. The spectral data support the coordination site of the ligands are the thionyl group and imine nitrogen. Thus, the spectral data also confirm the bidentate nature of the complexes. The data also confirm that all the complexes contain of two equivalent of ligands and two chloride ligands. On the basis of above facts, six coordinated geometry
Thank
of
you,
all
Anjit.
the
Thank
metal two
you.
complexes were confirmed. Thank you, sir.
Sunil Kumar, KS College. Sunil Kumar. Sunil Kumar, KS College. Sunil Kumar, KS College. Dr. Anita Sinha. Dr. Anita Sinha.
Good afternoon, sir. My topic is organic synthesis. Organic synthesis is a special branch of chemical synthesis and is concerned with the intentional construction of organic compounds. Organic molecules are often more complex than inorganic compounds, and their synthesis has developed into one of the branches of organic chemistry. Synthetic organic chemists have the power to replicate some of the most intriguing molecules of living nature in the laboratory and apply their developed synthetic strategies and technologies to construct the variations of them. Such molecules facilitated biology and medicine as they often find uses as biological tools and drugs candidates for clinical development. In addition, by implying catalytic reaction and appropriately designed synthetic process, they can synthesize not only the molecule of their analogous, also many other organic molecules for potential applications in many areas of science, technology. एकदम पूर्ण नहीं ना हो से
आवाज नहीं आ रहा इधर से।
मेरा नंबर कब आएगा सर?
मेरा नंबर कब आएगा? हाँ हाँ सर।
मेरा नंबर कब आएगा सीमांत सर जी?
हेलो। हाँ। हाँ यहाँ पे नहीं आ रही है मेरे वाले में delete कर दिया। नहीं ये कहाँ पे म्यूट है
पवन कुमार सदा हैं पवन कुमार सदा पवन कुमार दूसरे यूनिवर्सिटी डिपार्टमेंट ऑफ नेशनल रेवेन्यू पूजा कुमारी संध्या
Yes, sir. Yes, sir. I'm here. Yes, sir. I'm here.
प्रेजेंट करिए स्टार्ट
Good afternoon. My topic is medicinal application of coordination chemistry. Medicinal application of coordination chemistry begins with a brief historical review and an introduction to the chemistry of D and F block metals. Coordination compounds play an important role in biological system, particularly in human and plant life. Many coordination spheres have been used in medicine containing metals such as platinum, ruthenium, palladium are used in anti-cancer drugs. Also, many of the coordination compounds are antibacterial. Only a reduced number of CO3 complexes can be mentioned as having biochemical properties. Vitamin B12, a natural organometallic complex of CO3. The blood oxygen carrier hemoglobin is a coordination compound of magnesium, essential for life and continuation of the life on this planet. These compounds are not only biologically useful, but also as a group of drugs like molecules and medicine. Nowadays, a significant interest in the development of metal complex-based drugs with unique research and therapeutic and diagnostic opportunities is currently observed in medical and inorganic chemistry area. Thank you for listening to me.
पवन कुमार सदा
तो लिखे चले हैं नहीं कुछ है संध्या कॉल किन को हम मधु एम हियर करने चलिए ना सर फिर क्या बदलिए
Respected authorities, respected teachers and students, and my dear friends. Today I am going to present the role of depth receptor in the recognition of metal ions of environmental relevance.
Yes.
So, next slide. Owing to their prevalence in medicinal and environmental and biological fields, recognition of metal especially has been increased in the recent years as an important field of chemistry. The colorimetric and fluorescent detection of metal ions have been achieved utilizing various machines photoactivity such as rhodamine, fluorescent, and chromatin etc. They also apply the gelator conjugation to an appropriate binding unit mainly through acid-base diazo and amide linkage. Rhodamine dyes are one of the most commonly used organic dyes and have been extensively used for chemosensing and biosensing owing to the higher molecular extraction coefficient. Excellent photostability also it has relative to other organic dyes. It has also high fluorescence quantum mix, which is very good for the water solubility also it has. Next slide.
मैम यहीं से बोल दीजिएगा।
Next slide. You can see that this is a unique property among the rhodamine derivative. Reliable common sensing property enhances selectivity and sensitivity with off-on characteristic fluorescence. This is a very unique property of the rhodamine in compared to other dyes. Next slide. Here we can see that that compound is not fluorescent, but here the compound has become fluorescent after the addition of the metal ions. That metal ions are in 3+ oxidation state, and this combines with the receptors that probe, and then it gives fluorescent, and also it is colorimetrically proved. So next slide. Here also we can see in the cartoons that colorimetrically and fluorometrically both in that receptor changes the color after the wavelength after absorbing the lights. So this is, thank you.
So Dr. Ning,
सुपरवाइजर दे दिए तो हो गया, सुपरवाइजर दे दिए तो हो गया ना। नेट बैठे हुए सामने तो बीएससी दे दे।
to respected guests and my delegates, the topic of my presentation is bismuth ferrite as an emerging light observer for photoelectrochemical water splitting. Next slide, sir. As we know that after combustion or burning, product of hydrogen gives only pure water. Therefore, hydrogen is able as clean energy carrier for future. It is also known as hydrogen economy. The production of hydrogen can be done by various processes like thermal, electrolytic, photolytic. Photoelectrochemical water splitting is one of the most important processes to produce hydrogen. In this process, photoelectrode absorb sunlight and split water into hydrogen and oxygen. Iron-containing metal oxides such as ferrites or bismuth ferrites having a small band gap used as semiconductors photoelectrode to drive redox reaction of water splitting. So, in water splitting, two molecules of water decompose into their elements, that is, two molecules of hydrogen gas and one molecule of oxygen gas. So the conclusion is there is a need to know the fundamental understanding of photoelectrochemical by discussing the current status of bismuth ferrite-based photoelectrode for photoelectrochemical water splitting and provide a perspective for major challenges, opportunity laid for trade. Thank you.
Sabina Parveen. Sabina Parveen.
Yes, sir, present here. Sir, Shabina Parveen present here.
Start presentation, Sabina.
Okay. Good evening, respected teachers and all present here. Myself, Shabina Parveen, research of LNMU. My topic is synthesis of substituted benzyl 6-phenyl 1,5-1,5 tetraethyl and 19% a variety of reaction in which hydrazide undergoes gives the different products which depend on the nature of hydrazide. Substituted phenyl is prepared for corresponding with better by response to other means. The substituted phenyl acetic acid was converted into their hydrazide by standard procedure, reacted with benzoyl chloride, and the product was heated with phosphorus oxychloride. Product was treated with hydrazine under a variety of conditions to to furnish a known pre-substituted benzyl mixed phenyl 1,4-dihydro-2,4,5 tetraazine. The structure of tetraazine was performed to carry out their synthesis in an alternative method. In alternate method, this consisted of putting the substituted phenyl in its corresponding like reacting
Samina,
with
your voice is
hydrogen.
not audible and you are not sharing any presentation. Thank you. Shivrat Kumar. Thank you. Shivrat Kumar. Are you there?
Yes, sir. Yes, sir. Good afternoon. My first topic is the anomaly of benzoating from the most important is growth in organisms and development, especially in liquid chromatography, high performance liquid chromatography. Feature of crown ether, the central to enzyme, the one is used to study the computation of this is and this of 200 at about from methyl from tetramethylsilane and other multiplate due to the ppm downfield from tetramethylsilane. The main reason for the depletion of the ether resonance in the chemical anisotropy of the group. However, comparing the views of the individual protons related to internal tetramethylsilane. Thanks a lot.
Sir, present sir.
बोले
Good afternoon.
जनाब सर बोले क्या जनाब सर बोले हम
Good afternoon, everyone. Good afternoon, everyone.
हेलो
I am audible, sir. Good afternoon, everyone. I am Mayuri Omeka, research scholar from Nagpur University. Today, my topic is bio-inspired reduced graphene oxide zinc oxide nanocomposite. Recent advances in the area of graphene-based nanomaterials have started increased attention in using its exceptional characteristics since they are widely used in fuel cell, medical sensors, solar cell, photocatalysts, and environmental applications. Graphene is a one atom thick planar sheet of sp2 bonded carbon atom. They have densely packed honeycomb like crystal lattice. Currently, graphene-based nanocomposites material gaining more attention due to its high conductivity, child mobility, thermal conductivity, transparency, mechanical strength, and surface area. Hence, all these features or properties made graphene and graphene derivatives ideal candidates for the diverse applications such as solar and fuel cell. There are the two processes involved in the graphene synthesis. First is top-down and second one is bottom-up. There are some challenges and strategies to overcome in the synthesis of graphene-based nanocomposite. Despite the distinct advantage of GO from irreversible aggregations, which limits its processability, this can be overcome by incorporating various inorganic metal and metal oxide nanoparticles in graphene matrix. Apart from enhancing the properties of graphene, the nanoparticles act as a stabilizer against the aggregations of individual graphene sheet. Chemical reductions involve high toxic nature of the reducing agents such as high-methyl hydrazine, hydroquinone.
सुनो एक और 5 मिनट इंग्लिश 10 मिनट बाद बात करेंगे अभी कुछ चेहरे पे चक्कर जरा बिगड़ा पागल है क्या हो
And metal hydrochloric acid. The presence of trace amount of such toxic agent could have detrimental effect for related applications. Problem can be overcome by using green nanotechnology by chemical modification of GO using various phytochemical obtained from different natural sources of plants are used as a reducing agent. Green
Thank you, sir.
Thank you. अरुण कुमार सिंह, KS
आ गया
कॉलेज। अरुण कुमार सिंह, KS कॉलेज।
स्टार्ट करें सर?
बिल्कुल स्टार्ट करिए।
Sir, I'm Vijay Kumar presenting here.
सर अरुण कुमार सिंह,
अरुण जी आप स्टार्ट करिए।
respected Honorable Vice Chancellor LNU, come Chief Secretary, E-Conference, Dr. S.P. Singh sir, respected Pro Vice Chancellor, Madam Dr. Doli Sinha, respected Registrar, Dr. Mustaq Ahmad, respected Dean of Science, Dr. Biblendu Shekhar Dhadi, respected Head of Department and Chief Guest, Dr. K.K. Dhar sir, respected Dr. Saman Ansari sir, respected invitee, all the speakers, respected Dr. Simant sir, Dr. Sanjay Chaudhary sir, Dr. Saman Ansari sir, Dr. Sasi Shekhar sir, Dr. Arun Kumar Singh, very thankful to give the opportunity to present my paper. My paper title is Green Synthesis of Novel 3 Substituted Coumarin and Pyrrole Derivatives. Multi-component reactions (MCRs) are now developing as an important tool for the synthesis of structurally diverse chemical laboratory and several bioactive heterocyclic compounds. Multi-component reactions show high degree of atom economy and operational simplicity, structural diversity, and complexity. These are the major advantages of associated with.
Next, Vijay Kumar.
Yes, sir. I'm presenting, sir.
Hello.
My topic of today's presentation is green
Hello.
chemistry, a new emerging. Hello.
Yeah.
Sir, I'm myself Vijay Kumar, sir. Hello.
Continue.
Sir, I'm presenting my paper today. Green chemistry, emerging trends in chemical sciences. The green chemistry, according to Dreyer Broch, green chemistry represents the pillar that holds up our sustainable future. It imperative to teach the values of green chemistry tomorrow. My topic regarding this, I'm concluding my topic because of less time. In the 21st century, awareness towards the environmental protection has increased. The needs of new laws and regulations are required to protect the ecosystem from the harmful chemical, which is more dangerous to the human health. That is the human health, which is thus the green chemistry is a new branch of chemical sciences is to introduce. In conclusion, green chemistry is not a solution to all the environmental problem, but the most fundamental approach to the preventing pollution all over the world. Government and industries are working with the green chemistry to transform the economy into the sustainable enterprises. Green chemistry may be.
Yes, sir. Yes, sir, I am present. Good afternoon to all of you. Myself, Noshi Number. I am a research scholar. Today, my topic is synthesis and 1 minute. Today, my topic is synthesis and antifungal activity of new dihydropyrazole of designed curcumin analog as heterocyclic compounds plays vital role in the medicinal chemistry. Most of the available drugs are heterocycles, so the synthesis of heterocyclic compounds are attractive choice for the synthetic chemist. Many drugs containing pyrazole nucleus are very effective in many diseases like silicozib are used for anti-inflammatory drug, CDPBB are used for antipsychotic drug, rimonabant is used as anti-obesity, phyzolamine are used as antidepressant. As pyrazole is one of the representative classes of heterocycles, and it was first reported by Ludwig Knorr in 1833. It is an attractive target for the chemist in the field of heterocyclic chemistry. As parazole nucleus possesses an essential place in the drug of discovery, so it is known to be most abundant pharmacophoric group in the synthetic as well as a natural bioactive molecule, as it is reported as a potent bioactive molecule and are known to be exhibit wide range of the pharmaceutical activities. So 1 minute, sir. Recently, a library of new dihydropyrazole derivative have been synthesized, which are wide role in the medicinal chemistry. For this synthesis, firstly, reaction of dehydroacetic acid with benzaldehyde leads to the formation of chalcone analog, and this chalcone analog and phenylhydrazine were mixed with 10 ml of ethanol in 100 ml of round bottom flask, leads to the formation of dihydropyrazole derivative. So conclusion is the synthesized dihydropyrazole showed that the potential inhibitory property against tested fungal strain with minimum MIC value. Thank you, sir.
राम केवल यादव, राम केवल यादव, राम इकबाल यादव, राम इकबाल यादव, राम इकबाल, अनम्यूट करिए, राम इकबाल यादव, राम इकबाल यादव, अनुपम विकास,
Yes, sir. Yes, sir. Present, sir. Regards to all respected members and thanks to the opportunity to present my oral presentation. The topic of my oral presentation is studies of mixed ligand chelate nickel second and copper second ion. Ski-based derivative from semi-carbonyl and aminoguanidine are reported for the formation of semi-carbozones and aldehydes and ketones dual metal complexes. The chemical derivatives as well as the semi-carbazide derivatives were prepared by the simple condensation method. After the formation of complex, metal chloride was treated with NH4.
राम इकबाल यादव, स्नेहा कुमारी, MIT कॉलेज, स्नेहा कुमारी, स्नेहा,
I'm present, sir.
स्नेहा,
Yes, I'm present. Good afternoon to all. My topic is hemicyanin dyes, synthesis, structure, and photophysical properties. The cationic hemicyanin dyes 3-ethyl-2,4-N and dialkyl aminostyryl benzoxazolium salt, 2,4-N and dialkyl aminostyryl, 1,4-iodobenzyl pyridinium salt, and 2,4-N and dialkyl aminostyryl, 1-methyl-6-iodo pyridinium salts were synthesized and characterized. The dyes were prepared by the condensation of 3-ethyl-2-methyl-benzoxazole salts, 1,4-iodobenzyl, 2-methyl-pyridinium salts, or 1,2-dimethyl-6-iodopyridinium salt with para-N and dialkyl aminobenzaldehydes. 3 groups of chromophores with the same acceptor group but with various donor group were obtained. The spectroscopic properties of the prepared dyes were determined in organic solvents. It is known from literature that the certain combinations of organoborate and an alkoxypyridinium salt with cationic unsymmetric cyanine dyes are also known to be the effective radical photoinitiators of polymerization in the visible light region. In this work, the synthesis and properties of 3 series of hemicyanin dyes are described. The effect of the dye's structure on their spectroscopic properties is discussed as well. The schematic presentation is here. Thank you.
कॉल जो है थर्सडे का अपना
मोहम्मद सरफराज आलम, मोहम्मद सरफराज आलम है प्रेजेंट, पुष्पा कुमारी, प्रेजेंट करना चाहती पुष्पा कुमारी,
जी सर, my topic is green chemistry sustainable for safer world. The green chemistry has an important role to play in the conflict on terrorism. When secure chemistry is practical degrees and unsafe materials that is probably stolen or diverted to be used in assault aren't made or utilized in huge quantities. The successfully exercise of green chemistry method, the chemical merchant merchandise do what they are imagined to do and are utilized in minimal quantities. With green chemistry substances and approaches which can be possible to bring about violent reaction, fires, excessive pressure, and different excessive situation are avoided. The use of probably unsafe auxiliary materials and flammable sustainable is avoided. Green chemistry minimize electricity consumption, thereby decreasing energetic high temperature textiles that is probably vulnerable to storage, with its emphasis on organic process in which applicable. Thank you.
हरिओम प्रसाद, हरिमोहन प्रसाद सिंह, LKVD कॉलेज, हरिमोहन प्रसाद सिंह, केशव प्रसाद यादव, कामेश्वर प्रसाद यादव, RBJ कॉलेज बेरा दरभंगा, केशव कुमार झा, यूनिवर्सिटी डिपार्टमेंट ऑफ नरेश कुमार, मंडल यूनिवर्सिटी, नरेश कुमार, पवन कुमार.
Yes, sir. Present here.
पवन कुमार, आवाज नहीं आ रही आपकी. पवन कुमार.
Present, sir. Present, sir. Present, sir. Present, sir. Author Sanjeev Kumar. Present, sir. Hello. Present, sir. Present here. Present, sir. Naresh Kumar. Author Sanjeev Kumar. No, sir.
Green chemistry potential for past, present and
Sir, present, sir. Naresh Kumar. Author Sanjeev Kumar. Yes, Pawan, sir. Present, sir. Respected Honorable Vice Chancellor Professor S.P. Singh, Chief Patron Vice Chancellor Professor Dolly Sinha, LNMU Darbhanga Chairperson Dr. Simon Srivastav, Reporters Dr. Abhishek Rai. Today is very important day for all the members of this e-commerce and recent advance in chemical science. I am Pawan Kumar, Research Scholar of University Department of Chemistry. Today my topic is green chemistry potential for the past, present, and future perspective. Abstract chemistry brought about medical revolution till about the middle of 20th century, in which drugs and the antibodies were discovered. The world food supply also increased enormously due to the discovery of healthy, improved methods of farming, better seeds, and use of insecticide and fertilizers. The quality of the life on the earth became much better due to the discovery of drugs, plastics, cosmetics, and other materials. Soon the ill effect of the chemistry becomes pronounced. Main among the being the pollution of land, water, and the atmosphere. The use of toxic reagents and reagents also make the situation worse. As of today, maximum pollution on the environment is caused by the numerous chemical industry. Therefore, the attempt has been made to design synthetic for the manufacturing process in which a way that the waste product were minimal. They will have no effect on the environment and their disposal is convenient. The expansion of the green chemistry over the course of the past decades need to increase at an accelerated pace if molecules estimate Thank you, sir.
Thank you. Ram Iqbal Yadav. Ram Iqbal Yadav. Pooja Kumari.
सर नरेश कुमार ऑथर संजीव कुमार प्रेजेंट सर.
Okay, Naresh Kumar and also Sanjeev Kumar. Okay, present.
जी सर प्रेजेंट सर.
Yes, present.
जी सर प्रेजेंट सर.
Present your work.
Good afternoon sir. Good afternoon. I am Sanjeev Kumar, research scholar of chemistry under BN Mandal University Madhepura. My topic of this lecturer is synthesis and characterization of multifunctional trinuclear complexes of selenium second and cobalt second. This is most important in modern chemistry. It is widely used in medicinal chemistry and industrial study. Ligand having sulfur selenium as donor group available in biological system. Organoselenium compound was considered to be antioxidant and was reported to be anti-carcinogenic. It also use antioxidant and use also chemopreventing or anti-cancer agent. This initial study of anti-inflammatory and antibacterial
Thank you,
activities of
Sanjeev. Thank
organoselenium
you.
compound have attracted growing
Thank you. Thank you, Sanjeev. Ram Iqbal. So now we will close this session, oral presentation session. At least after this conference, everyone should learn that for any oral presentation, for the research scholar or who is faculty working in the different colleges and different constituent colleges of this university and Bihar, any university of Bihar, should try to make PowerPoint presentation. He should learn how to present and make some PowerPoint presentation. Because of this, I invited you all students. You should learn this how to make a good presentation. That's why we divided this presentation in two phases. First was all of the assistant professors were working, and second one also was, you can see the difference. So everyone should learn how to present their works, and you are also going to become a teacher. You should learn how to read, how to teach, how to present our work. This is our main motivation of this conference, to encourage all the research scholar of this Bihar, any constituent college or any guest faculty who is working in different colleges, at least they make some effort for their presentation. Before that, they were hesitate. Before this, they were hesitating to come from the front, but they start at least talking and sharing a screen, and they are coming out and they are presenting. So we will improve day by day, and hope from the next conference, I hope that each research scholar of this under our Bihar universities, different Bihar universities and research scholar will make more effort to for the better presentation. We will expect and we will meet you soon again in September. Thank you all. So we will, after 10 minutes, our Pro-Vice Chancellor, Professor Dali Sinha will arrive, then we will close this session. We will have valedictory session, and first, second, third prize for the poster and oral presentation. We will announce. Stay with us. We will meet after 10 minutes.
Bye,
आप सभी का आज के इंटरनेशनल ई कॉन्फ्रेंस के अंतिम सेशन में आप सभी का स्वागत है। और आप लोगों ने इतने पेशेंटली या पूरे डिपार्टमेंट में दिया गया और सुना और ऑनलाइन प्रेजेंट है, सभी को धन्यवाद। हमारा इस कॉन्फ्रेंस कराने का एक ही मोटिव है, धीरे धीरे आप लोग इम्प्रूव करिए, पीजी स्टूडेंट हो, रिसर्च स्कॉलर हो या गेस्ट टीचर हो, सभी लोग धीरे धीरे अपने अपने स्किल को इम्प्रूव करें। और इसी कड़ी में यूनिवर्सिटी ये एफर्ट्स कर रही है और हम भी उसमें एक्टिवली पार्टिसिपेट कर रहे हैं। ये आप लोगों के लिए है, ठीक? इसी को करने से धीरे धीरे रिसर्च थिंकिंग, रिसर्च आइडियाज, कोलैबोरेशन इसी की कड़ी में बढ़ते हैं। हम सभी किसी भी यूनिवर्सिटी, स्टेट यूनिवर्सिटी, किसी भी स्टेट के उससे पीछे नहीं है। मोर ऑफ हमें थोड़ा और एफर्ट करने की जरूरत है, जज्बा लाने की जरूरत है। तो चलिए हम अंतिम सेशन में चलते हैं। फिर से हमारे ऑनरेबल वाइस चांसलर मैम का हम स्वागत है इस लास्ट सेशन के लिए। इस सेशन में हम फर्स्ट ओरल प्रेजेंटेशन दो कैटेगरी में थी, ओरल प्रेजेंटेशन और पोस्टर प्रेजेंटेशन। इसके लिए हमने फर्स्ट, सेकंड, थर्ड प्राइज डिसाइड किया है, तो नाम हम अनाउंस करेंगे। और हमारे जो पीजी स्टूडेंट है उसने काफी एफर्ट लगा के रंगोली बनाई, एंकरिंग किया, प्रोग्राम में पार्टिसिपेट किया, उनको भी हम सर्टिफिकेट डिस्ट्रीब्यूट करेंगे। सबसे पहले हम इन्होंने रंगोली बनाई और पार्टिसिपेट किया, उनका नाम बुलाते हैं और एक एक कर स्टूडेंट आएंगे मैम के पास, ठीक? दीपाली, दीपाली Dipali is the first semester student. Antara Pathak, पल्लवी कुमारी, एमआरएन कॉलेज, नेहा, यास्मीन इशरत, साइस्ता अकरम, अगला हमारा है पोस्टर प्रेजेंटेशन के लिए। पोस्टर प्रेजेंटेशन में थर्ड प्राइज है अमित कुमार कुंदर। सेकंड अंतरा पाठक, सेकंड प्राइज अंतरा पाठक। फर्स्ट प्राइज ओम प्रकाश। नेक्स्ट कैटेगरी है ओरल प्रेजेंटेशन। थर्ड प्राइज पवन कुमार सदा। सेकेंड प्राइज फॉर ओरल कैटेगरी डॉक्टर रविंद्र शर्मा, AFPSM कॉलेज बरौनी। Dr. Anitra. And first prize goes to Dr. Alija Morti Philip, Hosnov College, Nagpur. Thank you. So now I'd like to invite our Pro Vice Chancellor ma'am for some words to encourage us. Please, ma'am.
Very good evening to all of you. We have with us the head of the Department of Chemistry, Professor K.K. Jha, the convener of this program, Mr. Sriman Srivastava, the organizing secretary, Abhishek Rai, other faculty members, Dr. Nisha Saxena, research scholars, and my dear students. In continuation with what we discussed in the first session, I will emphasize again that chemistry is the most essential subject, and it is the common science which has linked both with physical sciences as well as biological sciences. And in today's context, in the backdrop of COVID-19 pandemic, we know biological sciences or life sciences is very, very important, and chemistry is playing a very big role there. I don't know whether you study biochemistry in your syllabus or not, but I am happy to learn that you are doing green chemistry in your syllabus, and many of you have prepared posters on topics related to green chemistry. I understand that you also had computational chemistry in your syllabus. There is a paper on simulation, that is the paper CC5 in physics, and the students of chemistry can also opt for that paper under PSC. So it is a second semester course, CC5, and that relates to simulation. I think if the students of chemistry will join for that course, they will be very much benefited. Green chemistry or environmental issues are a very important factor today. I also mentioned in my inaugural session address, and I want that all our students will be very sensitive towards the environmental issues, because without that we cannot leave good things for our future generation, and it is our primary duty to leave something for good living of the future generation. Now, green chemistry, I don't know whether it is also part of syllabus or not for the undergraduate students. Is it there? But I think the chemistry department can design a good course on green and environmental chemistry for the undergraduate students as well as for non-science people. And to my dear students, I have seen the posters that you have prepared, and I congratulate you for your effort, and under the helping guidance of your wonderful set of teachers, you are learning these things. Actually, whenever we conduct conferences, seminars, or symposiums, the basic objective is to share knowledge. And today, the digital medium is a very powerful medium, and this has enabled us to be joined to some of the very good researchers in different parts of the world. Today, you have been part of the deliberations given by various scientists from different renowned labs in the morning sessions. And I am confident that all of you are hugely benefited by those deliberations. You may not have understood many things. बहुत सारी बातें जो विशेषज्ञों ने बताया, हो सकता है कि आपको समझ में नहीं आई, आपके ऊपर से निकल गया होगा। ऐसा हुआ क्या? कि सब समझ में आ गया? नहीं समझ में, कोई बात नहीं। अगर नहीं भी समझ में आया तो मोटिवेटेड हुए कि नहीं? कुछ मन किया कि हम भी आगे चल के अच्छा काम करेंगे, अच्छा लैबोरेटरी में रिसर्च करेंगे, ऐसी बातें आई कि नहीं दिल में? तो दैट इज द पर्पस ऑफ कंडक्टिंग कॉन्फ्रेंसेस। इतना जो आपके लिए आपके शिक्षकगण ने मेहनत किया, उसका मेन उद्देश्य यही है कि आप मोटिवेटेड हो। बहुत सारी बातें पहली बार सुनने से समझ में नहीं आती है, लेकिन फिर हम बताएंगे कि हम कहेंगे कि ये डिजिटल माध्यम जो है इसका बहुत सारे बेनिफिट्स है। आज जो आपके डिस्कोर्सेस हुए उसके सारे यूट्यूब में मिलेगा कि नहीं? गणेश जी जो आपका काम कर रहे हैं, टेक्निकल काम कर रहे हैं, तो वो बता रहे हैं कि यूट्यूब में जाके आप कभी भी दोबारा जो है वो लेक्चर्स सुन सकते हैं। तो ये इसकी खूबी है। और आप जो जिस भी लेक्चर में इंटरेस्टेड हैं, आप उसको देखें, बार बार देखें। आपके पोस्टर्स में मैंने देखा आपकी अच्छी पहल है, लेकिन बीइंग ए पोस्ट ग्रेजुएट स्टूडेंट्स आप लोग को अभी बहुत कुछ सीखना है। These are just the stepping stones. I congratulate the department कि आपके लिए इतना बड़ा आयोजन उन्होंने कहा किया, और आप सभी स्टूडेंट्स भी इसमें अपना जो जिस तरह से कोऑपरेट कर सकते थे आपने अपना योगदान दिया। इसके लिए आप सभी जो हैं, आप सभी जो है अभिनंदन के पात्र हैं। हम सभी का बहुत बहुत अभिनंदन करते हैं। और हमें लगता है कि हर सप्ताह में कोई एक रिसर्च पेपर पे अगर आप लोग थोड़ा डिस्कशन कर ले, आपके टीचर्स बहुत एफिशिएंट हैं, तो सैटरडे आफ्टरनून में कोई एक रिसर्च पेपर पे अगर चर्चा हो जाए तो ये हमारे पोस्ट ग्रेजुएट स्टूडेंट जानेंगे कि रिसर्च पेपर को पढ़ना कैसे होता है। पहले से बता दीजिए, ऑनलाइन में भेज दीजिए पेपर। एवरी सैटरडे नहीं भी हो तो एटलीस्ट वंस इन अ मंथ इस तरह का डिस्कशन हम लोग कर सकते हैं कि रिसर्च पेपर को पढ़ना कैसे चाहिए। ये भी एक सीखने वाली बात होती है। आप सभी एमएससी कर रहे हो, आगे हम आशा करेंगे कि आप बहुत अच्छा करोगे। तो सभी को मैं एक बार फिर से अभिनंदन करती हूँ। आपका विभाग के जो हेड हैं और उनके सहयोगी शिक्षण कल के कारण ये सक्सेसफुली कंडक्ट हुआ। आई कंग्रेचुलेट यू ऑल वंस अगेन। थैंक यू वेरी मच।
मैं संजय कुमार चौधरी सर को बुलाना चाहूंगा जो बोर्ड ऑफ थैंक देंगे।
मैं अपने विभाग की ओर से मैडम को धन्यवाद देना चाहता हूं कि उन्होंने अपना बहुमूल्य समय इस विभाग को दिया और हमें बहुत कुछ नई बातों से अवगत कराया। मैं धन्यवाद देना चाहता हूँ विवेकानंद सर जी को कि उन्होंने सुबह से लेकर अभी तक हम लोगों के बीच में है और हम लोगों को उत्साह बढ़ा रहे हैं। मैं तहे दिल से उनको धन्यवाद देता हूँ। मैं धन्यवाद देना चाहता हूँ निशा मैम को, इन्होंने सुबह से लेकर अभी तक हमारे साथ हैं, अपने अनेक कार्य को छोड़कर हमारे साथ हैं और मैं उन्हें भी तहे दिल से धन्यवाद देना चाहता हूँ। मैं धन्यवाद देना चाहता हूँ विभिन्न रिसर्च स्कॉलर को जो इस सभा में आए, हमारे ये एक्टिविटी किए, उनको मैं यहाँ से बहुत कुछ सीख कर जा रहे हैं और अपने अपने जो यहाँ पर कुछ देखने को मिला, सुनने को मिला, अपने जीवन में उतारेंगे। आगे जाकर उनको बहुत फायदा होगा। मैं उन्हें धन्यवाद देना चाहता हूँ और मैं पुरजोर धन्यवाद देना चाहता हूँ अपने छात्र छात्राओं को जिन्होंने जितने भी था उनके पास ताकत था, उन्होंने अपनी सारी ताकत को झोंक कर इस कार्यक्रम को सफल बनाने में योगदान दिया है। मैं पुनः विभाग की ओर से उन्हें हार्दिक धन्यवाद देता हूँ।
तो स्टूडेंट्स अगेन मैं सबकी तरफ से धन्यवाद और मैम को, वाइस चांसलर सर को और यूनिवर्सिटी एडमिनिस्ट्रेशन को बहुत बहुत धन्यवाद और उम्मीद करते हैं फ्यूचर में भी हमें ऐसे मौके मिले और वैसे हम ऐसे मौके लाएंगे। अपनी तरह से कोशिश करके हमने प्लान किया है एक वुमेन्स इन साइंस करके एक सेमिनार कराने का, जिसमें सारी वुमेन्स ही टॉप देंगी और हो सकता है वो 1.5 महीने के बाद हो, लेकिन मैंने काफी लोगों से कांटेक्ट किया है और मैम से ही मैं वो उनका गाइडेंस और सारी जो स्टूडेंट्स लेडीज हैं, मैं जितनी फीमेल स्टूडेंट्स हैं सबको जो पार्टिसिपेट कराएंगे और सबको अप्रोच किया है। डीएसटी सेक्रेटरी हैं, डीबीटी सेक्रेटरी हैं, हेड है फिजिक्स की आईआईटी दिल्ली की, मैम है खुद, ढेर सारे साइंटिस्ट हैं लेडीज, वो सब उसमें स्पीकिंग करेंगे और आप लोगों को दिखेगी कि आप लोग बाहर आइए पढ़िए, बहुत कुछ महिलाएं भी कर सकती है। थैंक यू। इन्हीं सब वर्ड्स के साथ सबसे फिर से सभी लोगों का एक बार धन्यवाद और इस आज कॉन्फ्रेंस के समापन का मैम के आदेश से घोषणा करना। धन्यवाद।